there. And on the bottom we have our trainer port, the USB-C charging port for the internal battery. We also have this little button down here, and this is again like what sets this radio apart. So that puts us into the ELRS menu. Now when I start this radio up, I want you to notice it does say HD0. It does not say Edge TX on this radio because this radio doesn't have Edge TX, and they say that to make it more affordable, they put their own OS on here. So this is HD0 independent OS on this, not Edge TX. So you know, if you're making this one of your dedicated radios, you have to know that you can't use Edge TX configurator on this radio. If you do a firmware on it, you're going to have to go to HD0's website, hd-0.com, to get the latest firmware, which again you can update right here with that update port. Now across the top of the radio, we have a latching switch here. There's another latching switch here, 3-position switch, another 3-position switch, a latching switch, and a momentary switch for guys that like to use those. On the back of the radio is where the sticks screw in for storage, and you do have, again, 10 channels on this radio. It is ELRS 2.4 and up to 250 milliwatt, again, way higher more than twice the amount of power for this radio versus the other two radios on the bench. And the official model name of this radio is actually the HDZ 7000, and that's the name of this radio. So you can see there is a screen in the middle, which is very helpful. If I want to get out of the HD0 independent OS, I click the button on the bottom, and it cuts off momentarily the power to the radio. It won't do that if you're flying the quad. It will not go into that ELRS menu and make your quad drop to the ground. So you could crash if that was allowed, but this radio has a block for that and won't let you crash or go to the Express ELRS menu when you press that button. If you're on the ground and it's not armed, the arm switch is out, you can go into the Express ELRS menu, which is very nice. You can see all your information here for the version. We can see what hertz we're running, 50 milliwatt, running 1/64 for telemetry and TLM. And we're just going to use the joystick if we want to navigate through those. You can see the LQ, the RSSI. Now I zoomed in a little bit so you can see the HD0 independent OS right here. It does show us all of the main features on the main screen, very similar to Edge TX. You've got your potentiometer movements here for both sticks, throttle and roll and pitch on the right, your RSSI up top, battery level, and your trims all the way around here. And if we use this little joystick down there, if we press to the right, it's kind of like page over or page back. So I can see my channels there, 1 through 10, all of them up on the screen. And we have channel maps here. And once we get to the channel map, if we press up and down on the joystick, it'll let us switch from channel map to calibration, battery levels. We have startup check, and we have the timer. We also have DSC. We have firmware, and we have reset to the factory settings here. You can see these little arrows on the right. That tells you to use the joystick to press up and down to go through these features. If you press to the right, it's going to change the menu back to the main menu. And again, what sets this radio apart is the fact that you can do ELRS configuration using this button. So if I press that button once, it'll go dark for a second. And again, that does cut the power to the radio momentarily. You'll lose all of your power out of your radio. It will not let you do that again while you're armed. If the arm switch is armed and engaged, HD0 does have that blocked in the software, so that's cool. We have Express ELRS version 3.62 on there. We have at 250 hertz, 1/64 telemetry, TLM, and we have it running at 100 milliwatt. We can increase that as well. So if we use the joystick again in here, we can go through, we can see our uplink, RSSI, our antenna info, and our downlink. If we long press, it'll take us into the packet rate, and this is where you can configure all of your ELRS. It will go all the way up to 500 hertz for the packet rate, which will give you a more low latency type of flying experience. If we press down, it'll go through the switch modes. You can change your switches, TX power here, and again, we can go all the way up to 250 milliwatt, which is the most powerful of these game style radios. And we have the telemetry ratio here, the BLE gamepad. If you want to use it for Bluetooth to connect to your computer to use your FPV simulator, and we have bind mode also in the menu. So you can long press here, or you can do it right inside the ELRS menu. And all I'm doing to get through all these menus is just pushing up and down. You can also do updates through ELRS Wi-Fi on your computer, ETX admin here, and back to the packet arrays. So that's all of the configurations for the ELRS settings in the radio. And if I press this button again, it'll take us back to the independent OS screen. Now here's all the radios on the bench so you can see them all together, and obviously they all choose different colors here. I know that the TAL does come in some different colors. You can also get this one in white, but the biggest thing is probably the screen difference here. HD0 is running their own OS, which is pretty cool. None of these two have this ELRS configuration button, and even if they did, they don't have a screen. You still have to use your computer. So yeah, that's a difference.
Oh.
The longer sticks on the HD0 controller I like better. It does feel fairly light for having a 4,000 milliamp battery in there, and it does run for up to 10 hours with that 10 milliwatt setting. So if you wanted to run a super long time, if you're just flying around the house and things like that, you can run it on 10 milliwatt and have plenty of power. If you're out in the backyard again, you can switch it up to 250 and fly a much bigger quad at a further distance than both of these radios. It's kind of crazy that you have twice the power. Now, so at the end of the day, it's a pretty awesome first release because HD0, they've waited a while. They have been around for many years now. HD0 has been climbing the ladder of quality, and they've also been watching what people are saying on the forums and engaging with the FPV community. So in my opinion, this is more of the all-around FPV pilots radio, and not just really just for beginners, but for guys who already really know what they're doing. You'll appreciate the functions and the quick access of the OS and the ELRS in this radio. It's just very simple to operate if you're somebody who's already into drones. If you've already been flying FPV, this will be an easy radio and maybe a great backup radio for 55 bucks. So I think that's pretty cool, and I'm looking forward to see what they come up with next, because I think they have a great start here, and they kind of have a head start on some of the other companies as far as just listening to everybody and what we want. That's like the most important thing about the community, is finding out what we want and then making a product that, you know, reflects that. That's awesome. So I would give this one definitely 2 thumbs up, and honestly, I think if you're going to consider a gamepad style radio or an FPV simulator.
This is the new HD0 remote. It is their first entry into the remote market, and it is a low-cost gamepad style controller that is designed to get the job done. It also has quite a few nice little features, and what we're going to do today is give you a complete overview of this remote. I'm going to walk you through how it works. We're going to tear it down, take it for a fly, and then at the very end I'm going to share with you my thoughts. Now, just before we get into it, I just want to say I did get sent this remote controller to take a look at for free. However, I've not been paid to make this video. HD0 have not seen this video before it's been published, and as always, my thoughts are entirely my own. Okay, so this is HD0's first remote controller. Over the last few years, HD0 has been diversifying into other areas. However, remotes, this is the first time they've entered that market. They're coming in at the lower entry level area. This remote is going to cost roughly $60. It's competing with the likes of the Radiomaster Pocket, T8L, Light Radio 4 from Beta FPV. So when you get the radio, it comes in this nice semi-rigid carry pouch. We open it up. Inside, you will find the HD0 RC controller itself, held in place with our little Velcro strap there. As you can see, it is a gamepad style controller, but we'll come on to that a bit more in a minute. And then also included in the kit that I've got here is we have a HD0 lanyard, which is nice to see. And then we have a USB cable. Okay, so walking you around the HD0 radio. Now, as you can see, it is a plastic gamepad style controller. It is a beginner radio, a simple radio, but it does have a couple of nice little features. Whether you're a new user or someone who's after a good backup radio, or just someone who doesn't need all of the bells and whistles, this radio really should have you covered. Looking around it, you can see it features a small built-in OLED display. It has Express LRS built in as well, and it has all of the basic switches and buttons you should need. Going into the main details, as you can see on the front, obviously we have our main gimbals. These are potentiometer gimbals. Size-wise, they sit around the AGO1 Mini sizing. You might be able to get a set of AGO1 Minis into this. I will have a look at that later on. As I've said, it has Express LRS built in, supporting up to 250 milliwatts of RF power. That is based around the SX128 series of chipsets, so it is 2.4 gigahertz only. That antenna for that is a separate antenna mounted internally on the back of the radio here. We'll have a look at that in the teardown. And it has all of the basic switches and buttons. So on the front, you have a power button. We have a 5-way joystick for controlling the menu system on the radio. We've got our 4-way trim switches on either side. And then on the top, we've got two 2-position switching buttons, 2 3-position switches, and then you've got a momentary and a latching on the back corner. On the bottom, you will find that we have a USB-C port for charging and updating the firmware on this radio. It does have a built-in 1S battery that is 4000 milliamp hour, and that is charged by the USB port down there. But you can also use that USB port for updating the firmware as well. We also have a DSC trainer port, and there's a little button here which is quite interesting. This button allows you to switch the display between the operating system for the radio and the built-in Express LRS module. So if I just press it, you can see it will switch over to the Express LRS menu system, allowing you to fully control that just like you would on any Express LRS module with a built-in display. So we can scroll through the main options and then press and hold the button to enter the main Express LRS menu system, where you can change things like your packet rate, your switch modes, your TX power, your telemetry ratio, and all of the other features. And then if you want to switch back to your main options, you press the button again and it goes back to the main screen. Looking at the gimbals in a bit more detail, as I've said, they are potentiometer gimbals. They are plastic, but they do feature full metal stick ends. These stick ends are CNC machined. They feature a knurled area around the side and a crown on the top. These are also removable as well. You can unscrew these and they have what appears to be an M2 thread. And HD Zero have added an area on the back of the radio for you to store them. Instead of having the usual horizontal storing position though, they've added screw bosses into the plastic, and you actually screw the stick end into the back of the radio, which hopefully will prevent you from damaging your gimbals in transit. Just something to note on these gimbals is that there is no external controllability on these. There's nowhere externally to adjust any of the settings. I don't know what can be adjusted on these gimbals. You usually can always adjust things like tension here, but there's no screw holes at the back to do that. So we'll have to have a look at what we can do exactly when we tear the radio down. When it comes to the ergonomics and the fit and the feel, it is a plastic radio. Feels okay. It's not going to feel the best and it's not going to feel the worst. There's no rubber grips on the sides, but there is this sort of molded in rough area like rubber, which is nice to see, which just offers a bit of an extra grip. The gimbals are actually really nice and solid on this radio. There is no flex at all in the corners. Really quite good. Reaching the switches and buttons is easy. Gimbals are not really much of a stretch. They'll be fine for everyone. On the top, our buttons are nice and easy to get to. Our top ones are fine. For me, it's a little bit of a stretch to get to the 3-position switches. It's not too bad. It is a little bit, but other than that, it's fairly good. Configuring this radio is all fairly straightforward. It's all done by this little 5-way joystick. We can scroll through the pages on the main menu system. So you can see we have our home page here, which shows us our main outputs. So you can see there the control sticks, and then it also gives us a view of our trim switches as well. We then have the next menu, which is our channel outputs, and then we go across into the main menu of the system, and this allows you to do things like set channel map, calibrate the radio, look at the battery status, control the startup checks, timer, functionality for your trainer, your firmware update, as well as your reset settings. When it comes to changing things like your channel map, this is all done in here. It's really simple and straightforward. So you would scroll down to the channel that you want to change, so for instance number 7, and then you simply press the button and scroll through the input that you wish to use with it. Then you simply apply the changes and then it's saved. When it comes to the other options, you have things like calibration. So here is where you would calibrate your sticks. We have our battery information. This shows us the current voltage on our cell. We can set our warning voltage and the warning type. So we can choose beep, vibration, or both. We've got our startup check options, so you can set the individual positions you wish the switches to be in and warn you about when you turn on. You've got your timer functionality, so you can enable a timer on the radio as well, and it will give you an alarm. You've got your trainer options, you can turn that on and off. Your firmware update options showing us things like our version of firmware and programming our Express LRS or the backpack functionality. And then you've got a full system reset. On the Express LRS system, that again is very similar. We simply switch the radio over to the Express LRS control screen, and this then has all of the main options that you would find in a normal Express LRS module with a built-in display. So we can scroll through and see the link status information, or I can press and hold the button and go into the main options. In here we can select our packet rate settings, so you've got all of the usual options that you have on the 2.4 GHz option. We've got our switch mode settings, our TX power settings, our telemetry ratio settings, Bluetooth gamepad controller option, that is fully supported on this radio, bind modes, as well as our Wi-Fi and our VTX admin. What's really nice about that backpack support on this radio is that it does mean you have that full VTX admin support with the HD0 system. If you haven't seen this, it allows you to fully control the HD0 VTX from your radio. You can do things like change the RF power, the channel, the band, and that's all supported within the backpack functionality that HD0 have added. But you don't have to use this radio with HD0. It is a normal Express LRS radio that you can use with any normal Express LRS receiver. When it comes to switching between that radio configuration and the Express LRS module configuration, there is something you need to be aware of. When your radio is disarmed, using the button to switch between the radio's display and the Express LRS module's display will actually cause the RF output from the Express LRS module to shut down for about a second. This only happens when it is disarmed. HD0 have introduced a block that prevents you switching the display when your Express LRS system is in its armed state. This is similar to a behavior we'd seen on some early Express LRS modules, where pressing the button on the module on the back would result in it entering the menu and shutting down the RF output, and the Express LRS dev team introduced a block when you were armed, and HD0 have done the same here. The reason I'm highlighting this is that you may see this on the bench when you're testing and might think this could cause you a problem in flight, but don't worry, there is a block in place, which I'll show you in a minute, that prevents it actually happening when the Express LRS system is armed. Just to quickly demo this behavior, I've got my spectrum analyzer up in the corner. At the moment, this radio is not armed, so if I switch the display, you will see it goes blank and the output from the module completely stopped. Then, when the display kicks back in, the output kicks back in and everything is fine. Interestingly, this only happens when you switch from the radio's display to the module. If I now switch back, you will see that nothing changed. However, if I try switching again, you will see that the output stops until the module boots up and then it kicks in. As I've said though, you don't have to worry about this in flight because it only happens when it is disarmed. If I now arm my Express LRS module by pressing that button down there and try swapping the display, you will now see that it says disarm SE to open ELRS menu, and again this prevents you from having that issue in flight. One of the nice little additional features on this radio is a quick and easy external bind button. This allows you to bind the radio to your aircraft without having to mess around going into menus, mess around with things like the binding phrase. I'm going to walk you through how you do that next. To do this, you simply press and hold the button we use to change the screen. Here we have the HD0 M8 Freestyle HD. We're now in binding mode, and it's really nice and simple. You just press and hold the button, and you will hear it vibrate, and then the radio links and your binding is done. Alongside the binding button, you also have the usual binding methods available, so you can flash the radio with a binding phrase, or you can add the binding phrase via Wi-Fi, like I'll show you next. From within the main Express LRS menu, you simply go down to the Wi-Fi functionality. This then allows you to turn the TX Wi-Fi function on. You then enable that, connect to the Wi-Fi on your computer just like you would before, and this would then bring up all of the normal options available with an Express LRS. You can set your own binding phrase in here without any issues, just like you would on any other normal radio. Now, before I share with you my final thoughts on the HD0 radio, I just want to make sure it works as expected. We're going to try it. I always try to test radios in the field before giving any final thoughts. Today we're going to test it with HD0. We have the HD0 goggles and we have the little modular as well, which is using the HD0 AIO. So hopefully this will just give me a little bit of flight time to get to grips with how the remote feels. And at the end, I'll share with you my final thoughts. Okay, so let's get this in the air. Oh, it's been a little while since I've flown this quad. So I'm just down at the field. Nowhere particularly exciting, but testing a remote, it's perfect. This is obviously, as I said just now, the HD0 modular with the HD0 AIO5 2S. It's a great little quad, this, for the HD0 system. Really sort of showcases the best HD0 is doing in small and lightweight right now, because this is where HD0 wins. Small, lightweight, and latency, and there is nothing else that is coming close to that in digital FPV. Oh. HD0 is giving the lowest latency in digital there is today, and whilst others have produced 1S boards, no one is really getting down to the size and weight HD0 is doing with the AIO5, the AIO15, and all of their recent stuff. Obviously HD0 in recent times have pushed into making more FPV hardware, and that is what we're seeing here today with this remote controller. It's another product from HD0. It's not just about the digital FPV system anymore. They're making remotes as well. We have the flight controllers, the ESCs. They are building themselves into a really great FPV brand, and the one thing you can absolutely say about HD0 is they listen, and if there's anything people in the community want, they will do their very best to implement it, and that's what we've seen with the HD0 goggles, the VTXs, and it'll be interesting to see what they do with remotes. Could they go bigger from here? You know, this is a beginning. Could they start making larger remotes with more capabilities for people who are after a little bit more than what the HD0 remote today is offering? You know, this isn't a replacement for the Boxer, the TX15, the TX16. This is a somewhat starter remote, but it does have a bunch of features, and I'm just moving it around. I like it. No complaints. Ergonomics feel decent. Sticks aren't too sharp. One complaint I do have with some radios is the sticks are a little bit too sharp at times. You know, this isn't going to be an exciting area to fly, and I'm going to be honest, I really don't want to crash here today with all of this water around. You can see, look through there, look at the water, it's horrific at the moment, it really is. I do not want to be putting the quad in this mud or puddles, but yeah, what I'm going to do is head off, have a bit more flight time, because there's no point wasting your time watching this, because it's boring as hell, and I'll come back and talk to you in the studio. So the next thing we're going to do is a quick tear down just to have a look at the radio inside. We'll take a closer look at the gimbals as well and just try and see what the manufacturing and construction and build quality is like. So the next thing we're going to do is take the radio apart and have a look inside. Looking around the back, there are a number of screws. We've got 1, 2, 3, 4, 5, 6, 7, 8 to remove. They all appear to be Phillips screws, so I'm going to go and get them undone and then we'll try and split the shell. I've removed the screws and the shells start to pop apart. I'm just going to go quite carefully because there is usually wires that go between the front and the back. Yes, there is. We have a battery wire, and there appears to be a couple of wires as well going to switch buttons on the back corner. So we're going to need to just carefully pop these off. They are normal connectors, they're not JST GHs, so they don't have latches. So we're going to have to just pop these off one at a time. There we go, and that reveals the inside of the radio. So looking at this radio inside in a bit more detail, you can see we have a single main PCB, a bit like an upside down T shape. We then have two additional boards, one on each side with our switches mounted, and then we've got our gimbals on each end. Looking at the gimbals, these are the potentiometer gimbals. I will get one out to give you a closer look a little bit more later on. You can see we've got the wires for the pots coming over the top into the board on either side. Obviously this is our sprung gimbal, and then this is our throttle with our tension adjuster there mounted over the top. Looking around the board, there's actually some interesting circuitry here because there's a lot going on. The radio is powered by an STM32F103 microcontroller. That's handling the main radio operating system. We then have our Express LRS system at the top. You have an ESP32 for the main Express LRS system and a second ESP32 for the backpack functionality. There is an external antenna for the main Express LRS radio, and you can see that is stuck to the top of the plastic of the radio there, just behind that little hole that you see there. And then there is a little chip antenna for the backpack function. Radio wise, it is using the SX series of chipset for Express LRS, so it is not dual band, 2.4 gigahertz only. Looking around the rest of the board, you've then got some additional circuitry that you wouldn't usually see in a radio. So for instance, down here, you've got a USB 2 hub. That appears to be here to allow communication between the two separate systems. Remember, you've got the Express LRS built into this, so the hub allows the USB connectivity for the microcontroller, but is also going to allow the USB connectivity for the Express LRS system. There is a CH340 over here, USB to serial driver, that is likely communicating with the Express LRS side of things. And then over on this side of the board, you've got your battery charging circuit, our battery charging IC, and then our output. Looking around the rest of the board, you can see we've got our buzzer over here. There is a rumble motor built into this as well. I'm guessing it's on the other side of the board. We'll have a look at that when we flip it over. And overall, it is a rather unique design compared to what we've seen on other radios. It's good to see that the Express LRS system in this is a full Express LRS system. It's not running on the STM32, it is ESP32 based, which means it should be fully compatible with the Express LRS project now, but moving forward through official firmware updates as well. Looking at the build quality, it's nice to see some stuff on here. So we have that Express LRS antenna glued in place, which is good to see. There's glue on the potentiometers. The thickness of the cables on the pots is pretty good as well. And then we've got these connections that go over to our switches. All looks pretty nice and tidy. Just giving you a bit of a look at the gimbal removed from the radio. I don't normally pull the gimbals out, but because these are new to look at, I thought it's worth a look. You can see on the back here, we have our potentiometers. You can see that there and there. Nice to see there's a bit of glue over the top of the connections to offer some strain relief. There's no spring adjustment on these gimbals. You obviously have the tension adjustment for the throttle on the other gimbal, but there's no adjustment for the tension of the springs. That all appears to be fixed. There's no screws on the front or anything like that. With it mounted into the radio, just showing you around there, you can see the mounting. I will grab a vernier in a minute and just measure the aperture of that hole, just so people have it, because people always do like to modify radios, put their own gimbals in. I don't know at this point if any of the sort of mini gimbals from other manufacturers would fit. We'll need to measure it and take a look, but really, yeah, overall pretty basic, straightforward gimbal, but has everything you would expect it to have. I've done some measurements on this gimbal and it is coming out basically the same size as the AGO1 Mini. This sizing here is about 41.7. This sizing across here is about 35, 35.2.
No.
The only measurement I can't find for the AGO1 is this circle here in the middle. If I just measure that on this gimbal to give you an idea, that is coming in at 37.1 mil. That's the circular area there. So there is a fairly good chance an AGO1 Mini style gimbal will fit. Looking on this side of the board, we have some power regulation from the look of it. Looks to be a typical regulator there. We've got our rumble motor down here, our joysticks, our buttons, and then our screen is connected on this little standoff board at the top there. Looking at the back case, you can see our boards in the top with our switches on for each corner. It is just worth me noting that these are not swappable. They are handed, so if you did want to swap your radio type over, you'd actually have to swap the switches over on the PCB. And then in the middle, we have our battery. It is a 1S cell rated at 4,000 milliamp hour or 14.8 watt hour. That is held in place with these little clips that go over the top. There is a little bit of movement on it, but it's not going to move in normal use. But it is obviously replaceable as well if at some point later down the line you wanted to replace it with a new pack. Okay, so to share with you my thoughts on the HD0 radio, and I have to say there is a lot to like here, especially for that $60 price. About the only thing I do want to mention as a downside quirk is about the case, which I'll talk about in a minute. Now, for $60, you're getting a lot of radio here. It is cheaper than the likes of the Radiomaster Pocket, although, yes, it doesn't have all of the features the Pocket has. The Pocket has an external module bay, larger screen, and external batteries. This has the screen, a bit smaller, but it is OLED. You have a built-in battery, and it doesn't have an external module bay. But it is more expensive than the likes of the T8L, but the T8L doesn't remotely have the same features that this has. Price-wise, it sits around the same price as the Light Radio 4 from Beta FPV, and I think it's a better radio than that for a number of reasons. HD0 have put a lot of thought into this radio, and it's just little things. I like the stainless steel stick ends, which you can store in the back. I like the fact that you can switch the display between the system on the radio and the Express RS module, and even things like the fact it's got 250 milliwatts of RF power, but it's not using one of those chip antennas. They've put a proper internal antenna in there, which should offer much better performance than you do get on some of the others. It really sits in the middle price range of the lower cost radios, and I think you're getting a good value radio here. HD0 haven't cut back. They've put in that backpack functionality as well. And if you're looking to get yourself your first starter radio, a backup radio, a second radio, or one for training, it is definitely worth a look. There really is no major downsides here to choosing this over the others, and there are a few upsides, that's for sure. If you want the option of an external module bay, you're going to end up having to look at the Pocket. That's a reality. However, if you're not worried about that, this is definitely worth a look. Now, as I mentioned, there is a bit of a quirk, though, that I do just want to mention with the case. When you put the radio in the case and strap it in, there is the possibility of that strap accidentally powering the radio on. Here, if you have the radio in the case like this, it is absolutely fine, no problem at all. However, if you put the Velcro strap over the top of the radio, it does have a habit of pressing on the power button that is here and accidentally turning the radio on. Just to show you this in real world, I'm just going to put the two pieces of Velcro together and leave go. And basically, even the lightest touch on this Velcro here will press down on the power button and power the radio up. Now, this isn't really a fault of the radio or a fault of the case. It's a quirk simply because of the way the power button is sitting slightly proud on the top of the radio and the strap goes over the top. You're going to need something just to stop that happening, there needs to be just like a piece of cardboard or just a little 3D printed piece to go over the top there to stop it happening. It's just really simple to do. If I just press there, you can see that it kicks in, and you don't actually have to press right on that part of the strap. If you press on a couple of the other parts, if I press down there, you can see it powers on as well. It isn't a downside, but it is just something I wanted to warn people about because I did spot it in my testing. Okay, so that is pretty much it. If you're interested in getting one, there will be a link to it in the description. I do want to say a big thank you to HD Zero for sending this over. If you guys have any questions on this, please do pop them down below in the chat, and I would
So here's an example. This has this copper foil that I've wrapped around it, going to a GPS saver, which is basically a battery and buzzer, so that should you crash and eject the battery, you get both a buzzer and your GPS stays on. And then if you have this powering your transmitter, your telemetry transmitter, you're going to be good to go for receiving GPS of a downed bird. So here's an example. This has this copper foil that I've wrapped around it.
Oh, it's fun. Oh, it's fun. Is it? Oh, that's fun. Oh my gosh. That's. Oh my. Okay. Really? We're in public. Oh, it's fun. Is it? Oh, that's fun. Oh my gosh. That's. Oh my. Okay. Really? We're in public. Oh, it's fun.
Hello, and thank you for coming along to my event tutorial, which I've cheesily and somewhat regrettably called Get Loft and Get Creative. The name of the tutorial is based upon the primary tool which I'll be using in this guide, which is the Loft command, which you'll find in the Part Environments ribbon bar. Now, the Loft command's been invented for quite some time. I want to say it came out in around about release 10. That's not 2010, that's release 10, which is about 2008, I want to say, ish. So it's been here for quite some time. However, I found on my travels that not a lot of people have used it. They've not dived into it, when they go about, self-teaching themselves. They stumble across it, maybe open it up and go, with the bloody hell, Christ, forget that. So, yeah, I found not a lot of people use it. Now, if you have used it, then good for you. So it begs the question what you're watching this for, but, you might learn something, maybe. But yeah, it's quite a good command. It allows you to get creative with various different shapes and forms. What it does is it takes two sketch profiles and it will blend a solid between two sketch profiles. Now, those sketch profiles can be of any shape, any size, and any place within reason, and it will blend a solid between those two shapes. Now, you can sort of let your imagination run wild with this a bit. You can create all sorts of funny forms and create kind of shapes. It's used for product design mostly, or you could use it for sheet metal for squared around, as the image depicts. But there is a sheet metal function for that, which I'll not get into. But yeah, so as I get through this tutorial, I'll be showing you other different areas of Inventor which I'll be using to get to the end point, which is to create a lofted shape, and hopefully you may pick up something as I go through, and I'll be explaining what I'm doing as I go through. So I'm starting with an empty part file. There's nothing going on in here whatsoever, and I'm going to start by creating a 2D sketch in a completely empty part file. I'm going to sketch on the XY plane. Now, I'm using Inventor 2015. If you are using an earlier release of Inventor, you may not see these work planes, these sort of construction planes appear in the center of the screen. If you don't worry about it too much. If you want to sketch on the XY plane, as I am doing here, you can expand the origin folder from here and then pick it in there. Everything that I do in here, you should be able to do in an early release of Inventor. So you don't have to have release 2015. So sketch on the XY plane, and here we go. Now, to create the solid that I'm going to end up creating, I'm not going to be sort of taking a shortcut and playing the easy card here. I'm not going to be creating primitive circles and rectangles and squares. I want to get a bit more funky with things. I'm going to be using the spline tool, which allows you to create sort of non-standard shapes to create sort of weird and funky products with. So there's a number of different splines. Now the one I'll be using is the interpolation spline, which basically is a fancy word for saying you draw some points and it bisects a spline between those points. Now the best advice I can give you for creating splines is to not just click random points like this and hopefully, and hope for the best that you get a nice symmetrical, lovely shape to work with, because you'll end up spending the rest of your life dragging points around and well, that doesn't look right. Let's move that here. Let's move that down here. That's still not quite right. Well, where's the bottom point there? And you move this along here and it starts to do. Yeah, it's not the best approach to sort of randomly do it on the fly. The best advice I can give you is to plot out where you want your major spline points to be first before you create your spline, and you do that using the point tool here in the sketch ribbon box. So select point and then pick some approximate points where you want your spline to intersect. Now I want a kind of egg-shaped kind of spline going on, so I'm going to create 4 spline points, and they're all going to be based around the center point. What I want is my profile to be symmetrical around the center point, because the center point is going to become quite important later on. I'm going to use this for a path, which I will explain a bit more about later on. So I've got these points here. These are kind of just floating around in space. They're not constrained. If you've been working with sketches quite a lot, you'll know what not constrained means. It just means that they've got no dimensions. They're not fixed in space, and they're not referencing anything else in the art environment. They're just sort of free to float about. So I need those to be constrained. I need to tell Inventor where I want them to be. So I can use the standard 2D constraint panel, which is up here, and I can use the dimension tool. So I'm going to get started by just making this a bit more structured. I want to make things a bit in line and a bit more rigid. So we create the horizontal constraint, pick that, and then select these 2 points here, which will line those 2 points up horizontally. So when I grab and move these, they sort of move up down with each other because they're horizontally fixed together. I want to do the same but vertically for the top and the bottom points. Just to confirm what that's done. That's made sure that those 2 points are now vertically in line with each other. I'm going to create another vertical constraint and make this point here vertically constrained with the center point of the part, and that will align both points such that they're sat on that central axis running through the part file. Super. Right, well, what next? Okay, well the next thing I want to do is make sure that these points are symmetrical around the center line. How do I do that? Well, you could just create a dimension, say maybe make a dimension from there to there, say make that 10, and then put another dimension. I'm pointing at the screen like you can see my hand, but maybe put a dimension there of 10 and then make another dimension from here to there is 10. But it's not really best practice. The best way to go about doing that is to give yourself some center lines to work with. So you can say project geometry, and then you can use these axes. The reason for this being such a good idea is these axes will never ever change. They'll never move. They'll never vary. They're a fixed constant throughout the part file. So grab those axes once you've projected them, and then select them, and then convert them into construction lines. Now that doesn't really serve any purpose other than it just makes them a bit more sort of out of focus. They're not so prominent on your screen anymore. So now that you've got this center line here, what we can then do is create a symmetrical constraint, which is this one here, and then pick these 2 points, pick that point, and then this axis. And then that will make these 2 points symmetrical around that axis. Whee! Great, eh? Right, you can do the same thing, symmetrical constraint between this point here, and then this center line here. And then that will do the exact same thing. Make these 2 points symmetrical around that axis. So now we've got that done. The next thing we can do, if you want to, is plate some dimensions. Now it'll be quite alright now that everything's symmetrical to create a spline between these points, but if you are designing a product, you might want to put some dimensions on this point so you know what kind of size you're working with. So we can maybe create a dimension from here to here and make this say 25. You might want to put a dimension from here to here and make that, I don't know, 30. Whatever, it doesn't matter. I'm just sort of making this up as I go along, if I'm honest. And then make that one 10. Now all those sketch points have gone blue. When a sketch line goes blue, it does, I don't want to get into too much depth, but depending on the colour scheme you're working with, they can go different. But when they do change colour and go to a darker colour, generally means that they're constrained. And when they're constrained, means you can't move, drag them in, anyway. Right, now that I've got those points and I'm happy with those points, I'm going to select the drop down list here and I'm going to select interpolation spline. Now, the bizarre thing about this, and again I don't want to get into too much detail, but when you select spline and you start splining through the points, the start point does kind of make a difference. Now if you look what I've done there, I've started at this point and I've gone clockwise and I've got this sort of bizarre off egg shape here. No good. No good at all. So what I want to do is go back to the spline command, start at the bottom point and then kind of go anti-clockwise. And then even though I'm going through the exact same points, look at that. I've got a lovely symmetrical egg-shaped spline, which I'm happy with. And as I say, I don't want to get into the detail of why it's different, but you know, you tend to start in a symmetrical center point and then go around. If it doesn't work out quite right, start at a different point and try again. If you're quite confident that your points are all in the right place, everything's symmetrical, you know, just keep trying. Start at the right point and just keep trying. Okay, so that's my first profile done. That's the first profile that I'm going to use with the loft command. I'm going to finish the sketch. Now the next thing I want to do is create a path. Now the path is going to be, it's going to kind of be like a center line that the loft's going to go through. You can loft between two profiles. I could just draw another egg-shaped profile here and just loft in a straight line between 2 points. But you can also loft and tell it to follow a curvy path if you want. What do I mean by that? Right, well I'm going to create a sketch. And I'm going to sketch on this plane here, which is, because I've made everything symmetrical around that center point, this plane here runs smack bang through the center of the sketch. It is effectively a center line. If I just turn around, you can see there I'm sketching on this plane here, which is central through that sketch. Okay, I want to create a center line. Now, it totally depends on what you're doing. Obviously, I can't explain every eventuality of the sketch line that you can create. So what I'm going to do is create another spline. I'm going to start at this point here, and I'm going to come maybe here, and then down to, let's say, there. That'll do. That's going to be the center line for my loft profile. However, if you look at where the spline comes out of the profile, can you see it sort of bends up before it goes down? That's not good. I want it to come out perfectly normal from the sketch plane. I want it to be a smooth transition out and then down. Because if I do loft the profile along this line, it's going to kind of go up and then it's going to go down. It's not going to terminate against the sketch profile kind of perpendicular or normal to that sketch plane. So we need to sort that out. Now there's a number of ways of doing that. Again, like everything in CAD, there's a number of different ways of doing this. But I find the best way to do it is to look at the handle of the spline. What the bloody hell is the handle of the spline? Well, I'll tell you what it is. If you select the end point of your spline, you get this little line appear here. Now that's the spline handle. If you try and select it, it's going to troll you. It's going to just vanish. What the hell? So what you do is you select the dot, right click, and then you activate that handle. Now these little dots here, if you pull the handle, you'll see you're modifying how the spline behaves at that point. Now I don't want to get too technical with this. I just want to keep it simple. So effectively what I'm going to do is make that spline handle horizontal. So you select the horizontal constraint, select that spline handle, and hey, look at that, it's not actually horizontal because the sketch has been flipped, it's actually vertical, which is a bit mind-boggling, but never mind. Make that spline handle vertical. And now you can see if we just exit the handle, it now comes out perfectly normal from the sketch plane because the handle is flatlined through the sketch profile. Lovely. Lovely joby. Right, I'm quite happy with that profile. I'm going to finish that sketch, and the next thing I need to do is to create my second profile, the one that's going to start the loft. This is the termination profile. I want to create a new profile around about here. How do I do that? I've got nothing to sketch on. Well, I need to create a work plane. How do I create a work plane which is going to be exactly where I need it to be on the end of this line, kind of making sure it's going to blend smoothly into this path? Right. Well, the way you do this is you select the work plane command, pick the end point of this line, which should appear, and there you are. You then pick the line itself, and it will give you a work plane which is perfectly normal to that spline. To test that this is actually adaptive and it's going to move with the spline, you can pick up the end of that line, move this to say here. It's not updated, right? We'll click the update button here, and it will move. Go. So your work plane is always going to be perfectly normal to the end point of that line. happy days. Next thing to do is to create your sketch on this work plane. And then we'll move the camera so it's looking straight down the work plane. Now we're not going to worry too much about what's going on down here, we're going to be worried about what's going on here. Okay, next thing to do is just to create another shape. Now this could be anything you want, it could be just a square, it could be just a circle, it could be anything you want, but I'm going to create another spline. So I'm going to create points here, point there, and point up here, another one there, another one there, another one over there. Okay, and I've got to go through the rigmarole again of making sure the points line up. The reason I'm doing that is because if it's an off-shaped spline, if it's not symmetrical, you're going to start you off in a bad way. The profile that you're starting the blend from is going to be off-center, and you're just going to get this horrible, ugly-looking solid sort of blending into another profile. It's just going to look awful. So let's start by doing the horizontal constraints between here and here, and then here and then here. Did that do that one? Yes, it did. Okay, all right, and then we'll do a vertical constraint between here and here, and then this one. Nothing to pick. There's nothing to pick there. So what we're going to do is project the geometry of the center point, and that'll give us a point which will allow us to vertically constrain that point to point. Good times. Right, for the center lines, to make everything symmetrical, I'm kind of now off the part axis. I'm not kind of like away from the center point of the part, so I can't really project the axes now. So an easy way to make yourself some center lines is to just start the line command, make it a construction line, and then draw yourself a center line going across here, and then draw yourself a center line going up there. And then we can use this symmetrical constraint to make that one and that one symmetrical to that. And then same again, just repeating what we did before, that one and that one. And symmetrical should have done that. Yeah, that's working like a treat. And then there was no point in those okay, so we make that one symmetrical around the center line. Great days. Okay, right, so for the size of this profile, now I want this to be a bit larger than that profile. I want it to be sort of a larger shape, blending down into a smaller shape. So just to get the size approximately right in the first instance, I can sort of move these points over here and move those points over there. And if I wanted to, I could put some dimensions on them. I'm not bothered about those, not really, but I'll make the center ones symmetrical, so we'll say 4, and then yeah, well, that's symmetrical, so it's going to be okay. Right, the next thing I'm going to do is my spline. So I'm going to start by doing the exact same thing as I did before, the interpolation spline. I'm going to start at the bottom and then spline out to here, through there, to that point, and then back to the start. And just made a construction line, so we'll just select that and then take that. Okay, so there's our profile. It's a bit funky looking. You can grab the handles if you want to, move it around and pull it around to make it a bit more specific. If you want it to look a little bit different, like I say, your dimensions, if you are designing a product, you would put dimensions on it, but I'm not overly fussed for the purposes of this tutorial. I'm quite happy with that. So we'll finish the sketch. Now, just to make things a bit more visually appealing, I'm going to switch off that work plane because I don't like having work planes in my face once I finish with them. Turn that off. Right, that's it, done. So the next thing I'm going to do is to create the loft. What I'm trying to achieve here is to blend this profile into this profile, but I'm going to run it along this path here. So we'll create a loft, and the curves are going to be the sections. Click to add. So we're going to go from here to here. Now, as you can see, I haven't selected that little line going through the middle of there, so it's going to do an as the crow flies blend from one shape to the other, which is fine. That's absolutely fine. But I wanted to follow this center line. I wanted to blend and curve along that center line. So I then select this one here, which I've said probably enough already, which is the center line. And then you select the sketch, which is going to be this one here. Oh, look at that. Isn't that great? So it's going to blend those two profiles together along that center line. And you go, okay. And then look at that. Look at what you can do. It looks absolutely fantastic. Well, it looks a bit drab actually because it's just in grey, but then you can sort of go into your colours and you can go to the the salesman's dream, which is the chrome polish. How shiny that is. And that's looking good. Now, if you are in product design, one of the good and again underused aspects of Inventor is the Zebra analysis utility, which allows you to inspect the surface quality of your models. So visually, just looking at this, yeah, it looks pretty smooth. It looks all good, it looks funky and hunky-dory. If you select this zebra button here, which is on the inspect tool, you can mess about with the density and whatnot, but select OK, and it turns your model into this sort of pinstripe zebra contour. And that just lets you inspect surface quality. So if there are any sort of weird off-symmetrical, maybe surface breaks in the model, maybe the loft didn't quite go perfectly symmetrical, you'd see that immediately in the zebra analysis. But as you can see, it is absolutely smack bang perfectly symmetrical. Okay, so just taking that one step further, I've sort of got this Blue Peter job going on here in the background. So this profile here and this profile here, that's pretty much the same as what I've just created. But then I've created an additional couple of profiles here, finishing with just a single point. Now they've been created in the exact same way as my other. Is the last example was just a profile on an angle, a send line, another profile. And these ones here are just sort of offset profiles from that one at the same in the same angle. So with the loft command, not only can you go from here to here, following sort of a guide rail, if you like, which gives you this, you can then create additional lofts. You don't even need a sketch for it, actually. You can pick a solid face and then sketch from here, loft from here to here to here, and you can loft through multiple points, and it'll, you know, you can come up with some really quite creative shapes. It all depends on the inputs that you give Inventor to work with. Right, a couple of other things just to finish this off. This loft coming out of here, you can see there is, you don't even need the zebra analysis to look at it. You can see there's a clear sort of deformation there on the surface. It's not a smooth transition from one profile to the other, but just for clarity I'll switch this on. You can see there, that's what the zebra is showing up. Look, there's a clear break in the surface. And it will... Hello, and thank you for coming along to my event. Only can you go from here to here. Now the loft command's been in Inventor for quite some time. I believe, I want to say it came out in around about release 10. That's not 2010, that's release 10, which is about 2008, I want to say, ish. So it's been in for quite some time. However, I found on my travels that not a lot of people have used it. They've not dived into it. You know, when they go about, you know, self-teaching themselves, they stumble across it, maybe open it up and go, bloody hell, Christ, forget that. So yeah, I found not a lot of people use it. Now, if you have used it, then good for you. So begs the question what you're watching this for, but you know, you might learn something maybe. But yeah, it's quite a good command. It allows you to get creative with various different shapes and forms. What it does is it takes two sketch profiles and it will blend a solid between two sketch profiles. Now those sketch profiles can be of any shape, any size, any place within reason, and it will blend a solid between those two shapes. Now you can sort of let your imagination run wild with this a bit. You can create all sorts of funny forms and you can create kind of shapes. It's used for product design mostly, or you know, you could use it for sheet metal for squared arounds as the image depicts, but there is a sheet metal function for that, which I'll not get into. But yeah, so as I get through this tutorial, I'll be showing you other different areas of Inventor which I'll be using to get to the end point, which is to create a lofted shape, and hopefully you may pick up something as I go through, and I'll be explaining what I'm doing as I go through. So I'm starting with an empty part file. There's nothing going on in here whatsoever. And I'm going to start by creating a 2D sketch in a completely empty part file. I'm going to sketch on the XY plane. Now I'm using Inventor 2015. If you are using an earlier release of Inventor, you may not see these work planes, these sort of construction planes appear in the center of the screen. If you don't worry about it too much. If you want to sketch on the XY plane, as I am doing here, you can expand the origin folder down here and then pick it in there. Everything that I do in here, you should be able to do in an earlier release of Inventor. So you don't have to have release 2015. So sketch on the XY plane, and here we go. Now, to create the solid that I'm going to end up creating, I'm not going to be sort of taking a shortcut and playing the easy card here. I'm not going to be creating primitive circles and rectangles and squares. I want to get a bit more funky with things. I'm going to be using the spline tool, which allows you to create sort of non-standard shapes to create sort of weird and funky products with. So there's a number of different splines. Now the one I'll be using is the interpolation spline, which basically is a fancy word for saying you draw some points and it bisects a spline between those points. Now the best advice I can give you for creating splines is to not just click random points like this and hopefully, and hope for the best that you get a nice symmetrical lovely shape to work with, because you'll end up spending the rest of your life dragging points around and, well, that doesn't look right. Let's move that here. Let's move that down here. That's still not quite right. But where's the bottom point there? And you move this along here and it starts to do it. Yeah, it's not the best approach to sort of randomly do it on the fly. The best advice I can give you is to plot out where you want your major spline points to be first before you create your spline. You do that using the point tool here in the sketch ribbon block. So select point and then pick some approximate points where you want your spline to intersect. Now I want a kind of egg-shaped kind of spline going on. So I'm going to create 4 spline points. And they're all going to be based around the center point. What I want is my profile to be symmetrical around the center point, because the center point is going to become quite important later on. I'm going to use this for a path, which I will explain a bit more about later on. So I've got these points here. These are kind of just floating around in space. They're not constrained. If you've been working with sketches quite a lot, you know what not constrained means. It just means that they've got no dimensions. They're not fixed in space, and they're not referencing anything else in the part environment. They're just sort of free to float about. So I need those to be constrained. I need to tell Inventor where I want them to be. So I can use the standard 2D constraint panel, which is up here, and I can use the dimension tool. So I'm going to get started by just making this a bit more structured. I want to make things a bit in line and a bit more rigid. So we create the horizontal constraint, pick that, and then select these 2 points here, which will line those 2 points up horizontally. So I'm going to grab and move these sort of move up down with each other because they're horizontally fixed together. I want to do the same but vertically for the top and the bottom points. Just to confirm what that's done, I have to make sure that those 2 points are now vertically in line with each other. I'm going to create another vertical constraint and make this point here vertically constrained with the center point of the part, and that will align both points such that they're sat on the central axis running through the part file. Super. Right, well, what next? Okay, well the next thing I want to do is make sure that these points are symmetrical around the center line. How do I do that? Well, you could just create a dimension, say maybe make a dimension from there to there, say make that 10 and then put another dimension. I'm pointing at the screen there, you can see my hand, but maybe put a dimension there of 10 and then make another dimension from here to there is 10. But it's not really best practice. The best way to go about doing that is to give yourself some center lines to work with. So you can say project geometry, and then you can use these axes. The reason for this being such a good idea is these axes will never ever change. They'll never move. They'll never vary. They're a fixed constant throughout the part file. So grab those axes.
The fuck?
Once you've projected them, and then select them, and then just construction line. Now that doesn't really serve any purpose other than it just makes them a bit more sort of out of focus. They're not so prominent on your screen anymore. So now that you've got this center line here, what we can then do is create a symmetrical constraint, which is this one here, and then pick these 2 points, pick that point, then that point, and then this axis. And then that will make these 2 points symmetrical around that axis. Whee! Great, eh? Right, you can do the same thing,
喂，
symmetrical
哎，刚
constraint between this
打
point
给
here,
我。
this point,
啊，对对对，
and then this center line here.
有在这样在这样
The。exact same thing. Make these 2
好，感
points
谢谢谢。
symmetrical around that axis. So now we've got that done. The next thing we can do, if you want to, is plate some dimensions. Now I'll be quite alright now that everything's symmetrical to create a spline between these points, but if you are designing a product, you might want to put some dimensions on at this point so you know what kind of size you're working with. So we can maybe create a dimension from here to here and make this say 25. You might want to put a dimension from here to here and make that, I don't know, 30. Whatever, it doesn't matter. I'm just sort of making this up as I go along, if I'm honest. And then make that one 10. Now all those sketch points have gone blue. When a sketch line goes blue, it does, I don't want to get into too much depth, but depending on the colour scheme you're working with, they can go a different colour. But when they do change colour and go to a darker colour, generally means that they're constrained. And when they're constrained, it means they can't move. They don't move anywhere. Right, now that I've got those points and I'm happy with those points, I'm going to select the drop-down list here and I'm going to select Interpolation Spline. Now, the bizarre thing about this, and again I don't want to get into too much detail, but when you select Spline and you start splining through the points, the start point does kind of make a difference. Now if you look what I've done there, I've started at this point and I've gone clockwise and I've got this sort of bizarre off egg shape here. No good. No good at all. So what I want to do is go back to the spline command, start at the bottom point, and then go anti-clockwise. And then if I'm going to the exact same points, look at that. I've got a lovely symmetrical egg-shaped spline, which I'm happy with. And I say I don't want to get into the detail of why it's different, but you tend to start on a symmetrical center point and then go around. If it doesn't work out quite right, start at a different point and try again. If you're quite confident that your points are all in the right place, everything's symmetrical, just keep trying. Start at the right point and just keep trying. Okay, so that's my first profile done. That's the first profile that I'm going to use with the loft command. I'm going to finish the sketch. Now the next thing I want to do is create a path. Now the path is going to be, it's going to kind of be like a center line that the loft's going to go through. You can loft between two profiles. I could just draw another egg-shaped profile here and just loft in a straight line between 2 points. But you can also loft and tell it to follow a curvy path if you want. What do I mean by that? Right, well I'm going to create a sketch, and I'm going to sketch on this plane here, which is, because I've made everything symmetrical around that center point, this plane here runs smack bang through the center of the sketch. It is effectively a center line. If I just turn around, you can see there I'm sketching on this plane here, which is central through that sketch. Okay, I want to create a center line. Now, it totally depends on what you're doing. Obviously, I can't explain every eventuality of sketch line that you can create. So what I'm going to do is create another spline. I'm going to start at this point here, and I'm going to come maybe here, and then down to, say, there. That'll do. That's going to be the center line for my loft profile. However, if you look at where the spline comes out of the profile, can you see it sort of bends up before it goes down? That's not good. I want it to come out perfectly normal from the sketch plane. I want it to be a smooth transition out and then down. Because if I do loft a profile along this line, it's going to kind of go up and then it's going to go down. It's not going to terminate against this sketch profile kind of perpendicular or normal to that sketch plane. So we need to sort that out. Now there's a number of ways of doing that, and like everything in CAD, there's a number of different ways of doing this, but I find the best way to do it is to look at the handle of the spline. What the bloody hell is the handle of the spline? I'll tell you what it is. If you select the end point of your spline, you get this little line appear here. Now that's the spline handle. If you try and select it, it's going to troll you. It's going to just vanish. So what you do is you select the dot, right click, and then you activate that handle. Now these little green dots here, if you pull the handle, you'll see you're modifying how the spline behaves at that point. Now I don't want to get too technical with this, I just want to keep it simple. So effectively what I'm going to do is make that spline handle horizontal. So you select the horizontal constraint, select that spline handle, and hey, look at that, it's not actually horizontal because the sketch has been flipped, it's actually vertical, which is a bit confusing, but never mind. Make that spline handle vertical. And now we can see if we just exit the handle, it now comes out perfectly normal from the sketch plane because the handle is flatlined through the sketch profile. Lovely. Lovely jubbly. Right, I'm quite happy with that profile. I'm going to finish that sketch, and the next thing I need to do is to create my second profile, the one that's going to start the loft. This is the termination profile. I'm going to create a new profile around about here. How do I do that? I've got nothing to sketch on. Well, I need to create a work plane. How do I create a work plane which is going to be exactly where I need it to be, on the end of this line, kind of making sure it's going to blend smoothly into this path. Right, well the way you do this is you select the work plane command, pick the end point of this line, which should appear, and there you are, and then pick the line itself, and it will give you a work plane which is perfectly normal to that spline. To test that this is actually adaptive and it's going to move with the spline, you can pick up the end of that line, move this to say here, it's not updated, right, we'll click the update button here and it will move. There you go, so your work plane is always going to be perfectly normal to the end point of that line. Happy days. Next thing to do is to create your sketch on this work plane. And then it will move the camera so it's looking straight down the work plane. Now we're not going to worry too much about what's going on down here, we're going to be worried about what's going on up here. Okay, next thing to do is just to create another shape. Now this could be anything you want. It could be just a square, it could be just a circle, it could be anything you want. But I'm going to create another spline. So I'm going to create points here, point there, point up here, another one there, another one there, another one about there. Okay, and I've got to go through the rigmarole again of making sure the points line up. The reason I'm doing that is because if it's an off-shaped spline, if it's not symmetrical, you're going to start your loft in a bad way. The profile that you're starting the blend from is going to be off-center, and you're just going to get this horrible, ugly-looking solid sort of blending into another profile. It's just going to look awful. So let's start by doing the horizontal constraints between here and here, and then here and then here. Did that do that one? Yes, it did. Okay, all right, and then we'll do a vertical constraint between here and here, and then this one. Nothing to pick. There's nothing to pick there. So what we're going to do is project the geometry of the center point, And that'll give us a point which will allow us to vertically constrain that point to that point. Good times. Right, for the centre lines, to make everything symmetrical, I'm kind of now off the part axis. I'm not kind of like away from the centre point of the part, so I can't really project the axes now. So an easy way to make yourself some centre lines is to just start the line command, make it a construction line, and then draw yourself a centre line coming across here, and then draw yourself a centre line going up there. And then we can use the symmetrical constraint to make that one and that one symmetrical to that. And so again, just repeating what we did before, that one and that one. And the symmetrical should have done that. Yeah, that's working like a treat. And then, those, nope, I haven't done those ones yet, so we'll make that one symmetrical around the centre line. Great days. Okay, right, so for the size of this profile, now I want this to be a bit larger than that profile. I want it to be sort of a larger shape, blending down into a smaller shape. So just to get the size approximately right in the first instance, I can sort of move these points over here and move those points over there. And if I wanted to, I could put some dimensions on. I'm not bothered about those, not really, but I'll make the center ones symmetrical, so we'll say 4, and then, yeah, less symmetrical, so it's going to be, okay. Right, the next thing I'm going to do is my spline. So I'm going to start by doing the exact same thing as I did before, the interpolation spline. I'm going to start at the bottom and spline out to here, through there, to that point, and then back to the start. And it's made a construction line, so just select that and then take that. Okay, so there's our profile. It's a bit funky looking. You can grab the handles if you want to, move it around and pull it around to make it a bit more specific. If you want it to look a little bit different, like I say, your dimensions, if you are designing a product, you would put dimensions on it, but I'm not overly fussed for the purposes of this tutorial. I'm quite happy with that. So we'll finish the sketch. Now, just to make things a bit more visually appealing, I'm going to switch off that work plane because I don't like work planes in my face once I finish with them. Turn that off. Right, that's it, done. So the next thing I'm going to do is to create the loft. What I'm trying to achieve here is to blend this profile into this profile, but I'm going to run it along this path here. So we'll create a loft, and the curves are going to be the sections. Click to add, so we're going to go from here to here. Now, as you can see, I haven't selected that little line going through the middle of there, so it's going to do an as the crow flies blend from one shape to the other, which is fine. That's absolutely fine. But I wanted to follow this centre line. I wanted to blend and curve along that centre line. So I then select this one here, which I've said probably enough already, which is the centre line. And then you select the sketch, which is going to be this one here. Isn't that great? So it's going to blend those two profiles together along that centre line. And you go, okay. And then look at that. Look at what you can do. Looks absolutely fantastic. Well, it looks a bit drab actually because it's just in grey, but then you can sort of go into your colours and you can go to the the salesman's dream, which is a chrome polish. Shiny that is. And that's looking good. Now, if you are in product design, one of the good and again underused aspects of Inventor is the zebra analysis utility, which allows you to inspect the surface quality of your models. So visually, just looking at this, yeah, it looks pretty smooth. It looks all good. It looks funky and hunky-dory. If you select this zebra button here, which is on the inspect tool, you can mess about with the density and whatnot, but select OK, and it turns your model into this sort of pinstripe zebra contour, and that just lets you inspect surface quality. So if there are any sort of weird off-symmetrical, maybe surface breaks in the model, maybe the loft didn't quite go perfectly symmetrical, you'd see that immediately in the zebra analysis. But as you can see, it is absolutely smack bang perfectly symmetrical. Okay. So, just taking that one step further, I've sort of got this Blue Peter job going on here in the background. So this profile here and this profile here, that's pretty much the same as what I've just created. But then I've created an additional couple of profiles here, finishing with just a single point. Now they've been created in the exact same way as my other. Is the last example was just a profile on an angle, a centre line, and another profile. And these ones here are just sort of offset profiles from that one at in the same angle. So with the loft command, not only can you go from here to here, following sort of a guide rail, if you like, which gives you this, you can then create additional lofts. You don't even need a sketch for it actually. You can pick a solid face and then sketch from here, loft from here to here to here, and you can loft through multiple points, and you know, you can come up with some really quite creative shapes. It all depends on the inputs that you give Inventor to work with. Right, a couple of other things just to finish this off. This loft coming out of here, you can see there is, you don't even need the zebra analysis to look at it. You can see there's a clear sort of deformation there on the surface. It's not a smooth transition from one profile to the other, but just for clarity I'll switch this on. You can see there, that's what the zebra is showing up. Like there's a clear break in the surface. So, how do we get shot of that? Right, well I'm going to go back into the loft, the last loft that I created, which is loft 9 in the browser, edit that feature, and then go to the conditions. Now the conditions, again, I don't want to go into too much detail, so I'll stop short of being a training course, but this this edge here, this is the transition between the first profile and the rest of the loft. So you've got a number of different conditions you can work with. The free condition just means the profile's coming straight directly out. The loft's coming straight directly out of the sketch profile. If we make this a smooth G2 condition, it will blend, it will try its hardest to blend the profile normal to the sketch that it's coming out from. There's still a tiny bit of a break there, but it's a hell of a lot smoother than it was. If you go back to Zebra, you can see it's made a big difference. It's not quite perfect, there's probably a little bit more work to do there, but it's better than it was before. I'm happy with that. Alright, and the final point, I've blended the final point of the loft into a sketch point. Now you can see here it's sort of terminating into an absolute razor sharp point, which good luck trying to manufacture that and getting it past any safety audits. But go back into the loft, edit the feature, go back to the transitions, and this point sketch here, this is the final point where the loft's terminating at. If I select this drop down arrow here, it knows that it's blending into a sketch point, so it lets you toggle how the loft ends on the point. Now you can change it to say tangent loft into a tangent point, so it'll sort of make a smooth spherical termination point, and you can increase the weight of that tangent point, like so. So just try and now just bump it up a bit, add a bit extra weight there, and we've got something much more manageable to manufacture. And as you can see, it's a rather cheap 10-pence disposable razor. Okay, so that's the loft command. I hope you found that useful. Like I said, a lot of people have used that before, but as you've seen the processes I've gone through, you can use any shapes you want. You can create any sketch shapes, any sketch profiles, any center lines you want, any distance and any size, and you can create literally anything you want using the loft command. The world's your oyster, depends on what your imagination can do. And also, as I've shown, is the spline command, a couple of tips and tricks on how best to get the spline command to work for you, and the zebra analysis tool, and a couple of the transition effects which you can use within the loft command. Thank you very much for checking this out. If you did find it useful, apologies, it's quite a long one, but you know, these things do take time. You kind of figure out Inventor in 2 minutes. It's quite involved. Thanks for your patience, sticking it out until the end. If you did like the video, press like on the video, that would be great, it helps me out. I'm just getting started, so it'll help you create some more videos, get them shared around a bit, and put some comments in. If you've got any questions, I'll be happy to answer them. Thank you very much for your time, and good luck playing around. Thank you. Hello, and thank you for coming along to my Inventor 3D sketching tips and tricks. More of a what the hell is 3D sketching than tips and tricks, but well, we'll see what we can do. Now, I've done many seminars in the past on Inventor to many people, to many engineering companies all over the world, and when I finish up and I say, right, you know, whilst I'm here guys, is there anything you want to know? Most people say 3D sketching. I need to do something with 3D sketching, or I've heard I can use it, but I don't really know how to work it. And I get that, I completely get it. 3D sketching is useful to many people, but it's not the most intuitively or best designed part of Inventor, let's say. So I thought I'd dedicate a bit of time to it, just to give anybody who needs a bit of a head start on it a bit of a clue on what's going on with it. So here I've got a new part file, and on the ribbon bar on the top, you see we've got the button Start 2D Sketch. Now I'm in Inventor 2015. which is the current release as of today, as I'm recording this video. If you've got a previous version of Inventor, the button might look a bit different, but it's there, it's in the same place, and 3D sketching is also in the same place, which is, I'll show you that in a second. So, what's the difference between a 2D and a 3D sketch? You might be thinking, well, do I even need 3D sketching? I mean, what does it do? Well, again, that's the whole point. You might want to know about it, but you don't know what it does. Now, with its traditional two-dimensional sketch, when you hit that button to say start a new sketch, Inventor presents you with a few starting points. The best way to think about sketching with 2D sketches is to take these origin planes, this XY plane, this YZ plane, and this XZ plane. If you're on an earlier version of Inventor, they won't be on the screen, but what you will find in the origin folder is they are there, and you'll be able to see them if you just hover over them. Don't click them, just hover over them, they'll appear in the graphics window. Now, if you think of these planes as bits of paper, that's the best way to think about them. Think of them as a bit of paper, and you're about to lay your pen on that bit of paper. So creating a 2D sketch or starting a 2D sketch is you placing your pen onto this bit of paper, and whatever you sketch, all the lines, arcs, and circles that you sketch will be completely restrained and restricted to that plane. So up, down, left, right on that particular plane. You can't go up above it, down below it. It's completely on that plane. So for this plane, you'll be sketching in the XY direction, so your lines will be going this way and that way, and same with the XZ plane and the YZ plane. So if I create a sketch on this XY plane, it gives you your sketch plane, it gives you your axes, it might give you grid lines if you've got them switched on, and if you draw a line, you can go up, down, left, right, you can go all over the shop like this. You can zoom out and you can go up here, down there, way, all over the place like this. And when you finish your sketch, and then you do a bit of a 3D zoom, you can see your sketch is completely flat. It is completely restricted to where that XY plane was. So you can't go up above it or down below it. You're completely stuck on that XY plane. Now, that's perfectly alright. To be honest, in 99.9% of the times, that's all you need. Because when you're creating your 2D sketch, you're effectively just drawing a shape. You're drawing a square, you're drawing a circle, and you then extrude it. You then apply a 3D feature to convert that flat 2D sketch into a solid. So you draw your circle, you extrude it, you give it depth, you're giving it mass, you're creating a solid from a 2D sketch. With a three-dimensional sketch, however, you're not restricted to sketching just on one flat surface. You can go look down, left, right, you can go up above, down below, you can go all over the shop. And you think, well, why? Why would you want to do that? Well, there's multiple reasons why you'd want to do that. You may not ever need to use any, you may not come across any of these reasons, but think of a pipe run, for example. Pipes never just go in a straight line, they kind of go from the point of source, they go outwards, and they might need to go up over an object, then turn left, then sort of go down a bit. And to model a pipe in Inventor, you can. One of many ways is to sketch that profile path, the path where the pipe is going to go, up, down, left, right, all over the place, draw a circle, and then sweep that circle along the path. That's one reason. Wires, cables, there's loads of reasons, but whatever your reason, this is how you do it. So I'll get started on my two-dimensional sketch. To create a three-dimensional sketch, you select the arrow underneath this button here, and then you've got Start 3D Sketch. And the ribbon bar changes at the top, and this is where it starts to become a little bit kind of baffling. Right? Well, what the hell is a silhouette curve? What's an intersection curve? And it doesn't really give you much to go off. There's not much guidance here built into the product to let you know what you should be doing. If you say, oh fine, well I guess I should be drawing a line, you get this sort of triad appear here, and you're like, well, fine, okay. You click that and sort of nothing happens, and it's like, well, what do? I don't understand what's going on. Okay, so a couple of tips to get you started, right? This bar here, this is called precise input. It's very useful to have. If you don't have this switched on the draw panel, sort of sneakily hidden away, we've got this precise input button here. Make sure that's switched on, and that'll give you this precise input. Still, if you've never seen it before, you're probably looking at it going, what the hell is that? And that's fine, that's fine. Now don't worry about this yet, but it will make sense. Okay, I'm going to press F6, that takes us to isometric view, so we've got Z, because traditionally Z is up, that's kind of, you know, the norm, so it gives us a bit of a basic understanding before we kind of crack on. Alright then, so how do you start with 3D sketching? Right, well I guess it depends where you want to start your lines from. Where do you want to start sketching from? If you do have a blank canvas like I've got here, you could start sketching from the centre point of the model. The centre point is where all the axes cross over, the x-axis, the y-axis and the z-axis. Where they all intersect, that's your centre point. Good place to start would be the centre point. So you click line, you kind of click it there, that's just a little bit annoying. That would be good if you could, but you can't. Just select centre point in the browser on the left hand side, and then your line will start from that centre point. Now if you were to just start randomly clicking willy-nilly, you're going to get nowhere. You're going to have a sketch that's all over the shop. You don't want to do that. You want to be a bit more precise about it, and that's where the precise input comes into it. There's two ways you can be precise about how you get your 3D sketching down. The easiest and most convenient way of doing it is to look at this triad. Now you've got 3 planes on the triad which are extremely difficult to see because they're dead small. Here's another tip. Press escape, go to the application options of Inventor, and the general tab, increase the annotation scale to 2 or whatever is comfortable for you, but that will double the size of all the on-screen triads and prompts and whatnot. So the triad's just a little bit bigger now. You can maybe see better now you've got these 3 planes to play with. Okay, so when you start your line command off, select the center point. You can then pick one of these planes. Now that will restrict your lines to be drawn purely in that plane. You'll get this little grid axis thing come up, and you can then go up, down, left, right, and you're purely restricted to that plane. Now you might be thinking, well, I could have done that in the 2D sketch. Why do I want to do a 3D sketch then be restricted to just one plane? Well, you can switch it after you've drawn each line segment. So say for example this particular line is going to be 50 mil long. Let's just say 50 millimeters long. Move the arrow up until you see the horizontal or the vertical constraint appear. Again, I'm pointing at the screen there, you can see my hand, but you cannot. But that will say that your line is going to be constrained vertically upwards on that z-axis. And then click. And you can then right click and select OK. You've now got a line which is 50 millimeters up in the z-axis. You can then, if you want, just so you've got a good starting point, a good reference for sizing, you can then put a dimension on there and say, well, that's now 50 mil. Great. How do you carry on with this? Well, select the line again, and for some bizarre reason, the triad's now down there. I think that's because that's where we finished the line. When I made it 50, it got a bit bigger. So you can then just select the line button and then move the mouse over the green dot, which is there, and that's where the end of your line is. So you're effectively snapping to the end point of the line. Great. You can then use these planes again to say, well, now I want to go this way in the x-axis. So you can then select this plane here, and then you can go this way, and then you can go that way, and then you can go that way. You're completely restricted to the axes of this plane. If you want to change it, you can then select this plane here, and now you can go down and across and up and across. You can then switch between all the planes. You can go in any which way you want. Once you've completed that and you're finished, you can then go back to the dimension tool and start putting some dimensions on here. But be careful, if you place too many lines and then you dimension them afterwards, it starts jumping all over the place. You start to distort the sketch a bit. Things start kind of going a bit out of control. But do it one small bit at a time. So that's one way of doing your 3D sketch. Another way of doing it is to utilize better this precise input. Start your line command, select the center point, and then understand the X, Y, and Z coordinates. If you want a line to go up in the Z-axis, you just want it to go vertically up by 50 mil. You can say, well, okay, I'm going nowhere in the X because that is the X direction here. So we're going nowhere in the X, 0, press tab. We're going nowhere in the Y direction, 0, press tab, but we're going 50 mil in the Z-axis, press return. Now you've got a line upwards of 50 mil. Now if you want to come 50 mil in the X-axis, you would go, well, okay, I'm going 50 mil in the X, I'm going nowhere in the Y, and I'm going nowhere in the Z. There you are. If you want to combine them, you might want to go, say, 30 mil in the Y, but 10 up in the Z, so you're kind of going up on an incline. You could then say 0 on the X, can't remember what I said, maybe 30, and then 10 in the Z. And you're kind of going up and along at the same time. So that's another way you can do your 3D sketching. But like I said, be very careful about drawing too many lines without dimensions, because when you start placing dimensions, it starts pushing your sketch around. So dimension here, 50 mil. If you change that to 40, it starts, because this line's under constraint, it's going to start distorting to suit the dimensions that you're placing. However, another tip, if you're not too fussed about placing the accurate dimensions on there, because you've sketched that using precise input, as it is right there, it is correct, you can then finish your lines in the constraint tab, press fix, and then just fix the lines. Just say, look, I don't care about the numbers, I know they're right. I know that's 50 mil, and I know that's 30 along and 10 up. Just fix it. It's now fully constrained, and you can then use that 3D sketch to do a sweep, to do whatever you want. Maybe that is the center line of a pipe, and you want to carry on to create the sweep. Great. So, in basic terms, that's the 3D sketching. Now you can, if this is for a pipe run, or if it is for a wire or a cable or something like that, you can do auto bends as well. It's like a fillet. Now you can either ask Inventor to create bends as you're sketching. When you're creating the line, if you right click, you've got the auto bend option here. So when you do two lines, it will automatically create a bend in between them of 5 mil or whatever this variable is set to. You can do it that way. Alternatively, after you've finished creating the lines and you've just got the hard 90-degree right angles there, you can go to the bend, let's say 2 mil, and then hover your cursor over the two lines, and then just put that 2 mil bend on the lines. Simple enough, isn't it? Not bad. It's not that bad at all. Okay, once the 3D sketch is complete, you click Finish Sketch, and your 3D sketch is then appearing in your browser as a three-dimensional sketch. Now, if you zoom around, you can see that that sketch is in fact 3D. It's not restricted to one plane. It is going up, along, and then in another direction. You can then do whatever you need to do to create the sweep. I guess if you're a bit confused about how you would do that, I suppose you should probably follow it up. We're playing on there to there. It's two-dimensional sketch on that work plane. Draw yourself a circle, which is probably not easy to see when you're looking straight on like that. There you go. 5 mil, and then just go and place it on, so 2 mil. Finish that sketch. Sweep that circle along that path. And there you go. You've got something that kind of looks like a pipe. Okay, a couple of other things you can do inside 3D sketching. A couple of the other options that are there, which you might be thinking, what are all of them? I can't go over them all. I don't have time to talk too much already as it is, and it'll go on for a bit too long if I cover them all. But let's just create a cylindrical solid, any size and any dimensions. I am not fussed. Okay, so there's a cylindrical solid. Now what I'm going to also do is create a sketch, which is going to be offset from, say, 20 mil. Okay, so just for clarity, I'm sketching, about 20 mil from the center of the cylinder, and I'm going to create a random line, say, let's just go straight on so I know exactly what I'm sketching. Let's say, about that, that'll do. And this is, there'll be a reason, which will become apparent soon, that's not why I'm doing this, let's make that 70 mil. Okay, so put a 70 mil line in the middle of nowhere, kind of offset from a cylinder. And you're, what the hell are you doing this for? Well, if I go back into 3D sketching, I can then say to Inventor, project to surface. Right, okay, project to surface. If you select the cylinder and then select this little red arrow here for curves, curves is, again, it's bizarre terminology, intentionally there to confuse you, but select that line and then say wrap to the surface. It takes that line and it wraps it around the surface of the solid directly in front. That's project to surface. Now the reason I made that line 70 mil long is just for verification that it is taken that line and it's wrapped it like for like, 1 to 1 around that cylindrical surface. So if we do measure a loop, select this line here, it's exactly 70 mil long. And then what do you do next? Well, this work plane and this line here, they're effectively construction geometry, so I can take them and hide them. And then we can go back to our cylinder. What do you do with this? What can I do with it? Well, again, work plane, pick the end of the point, pick that line, it creates a work plane normal to the end point of the 3D sketch. I can then say make a 2D sketch on that work plane, press F7 to slice the graphics tidy, project the geometry of, well, I need to draw a circle on the end point of this 3D sketch, so is it going to give me, yep it is, draw a circle, just doing this really quickly, so that'll do, finish the sketch, and then sweep that along that path, and then you get, something like that, which you would probably not be making a solid, you're probably going to be cutting, and then you get something like that. I mean, come on, you're not going to do that in production, but you kind of get the gist of what that is intended for. Another thing you can do, if I just undo all of these and keep my work plane on, click the sketch. Where's my work plane gone? I've hidden it, didn't I? Okay, if I sketch on this work plane and I draw let's just do a spline. Let's do a very approximate spline, something like that. That'll do, just finish the sketch. I'm going to extrude this spline. I'm going to extrude the spline as a surface, but I want to go that way. Now, my surface that I've just extruded intersects that solid. But why? What can I do with it now? Well, what you can then do is go into the 3D sketch environment and then say create an intersection curve between the solid and the surface. And then wherever the two intersect, it's going to create a sketch line. You can then use that sketch line as a sweep path. It's kind of broken off the bottom there, the surface needed to be raised a bit, but never mind. But you can use that as a sweep path for anything. You can split the solid with it perhaps, you can do whatever you want with it, but that's what the intersection curve does. That projects the surface and I guess what you would normally use in the 3D sketch, which is the line. You can also do helical curves as well, where you can input pitch and revolution. That bit's kind of self-explanatory. That will just give you a kind of curvy helical coil type line. And yeah, so that's 3D sketching, or as much as I can cover in a video on YouTube, I guess. But hopefully you found that useful. If you did, please press like. It helps get my videos around. I'm just getting started, and I'd like to make some more if they do become popular. So put some comments in the video below if there's anything else you want to see, if there's anything else you want to learn. I'll read the comments and I'll get back to you all with any feedback and new videos that I'm going to create. Thank you very much, and thanks. Hello sir, welcome to Inventor Tips, Tricks, Tutorials. Oh my god, I'm doing this video again. I've already done it and it was 20 minutes long. I'm not going to subject anybody to 20 minutes of work planes. That's a bit harsh. So I'm going to try and condense this and make it no more than 10 minutes. If you're looking at the video time and it's longer than 10 minutes, I do apologise. I talk too much. I'm doing it right now. Anyway, work planes. What is a work plane? A work plane is a means to create sketches and make new features in your model. So when you've started up Inventor and you've got part and assembly up and you've got a work features area in your ribbon bar here, which has got planes, axes and points. These are your work features. And we're not looking at points and axes, we're just looking at planes. So when I used to be an Autodesk instructor, so doing 8 Autodesk training centers, training courses, and I used to always explain planes to people as bits of paper, right? You need to make a sketch. You need to sketch a shape within your part, and there's nothing to sketch on, right? So you say you want to create a cut through this plate, but you don't want to sketch on the face, you want to sketch slightly offset from it. You need a physical face to sketch on, and that face is the plane. And in terms of placing your sketch in the Inventor part, think of the work plane as like a bit of paper. You're always going to be sketching on a flat face, a flat plane, and it's going to be like a paper thing. So think of work planes as pieces of paper, and you need to put these bits of paper inside
the inventor space. And that's the best way to think about them, because when you're placing work planes in funny positions, it's always best to think about it as like a flat bit of card or a bit of paper that you're putting down to sketch on. So that's what a work plane is in essence. And primarily they are used to create sketches, to facilitate new sketches, or to represent center lines for creating a mirror, something like that. So there's loads of different ways of creating them, and there's loads of different purposes, I guess, for work planes. So straight out the box, when you start a new part, you're given an origin folder. You've got YZ plane, XZ plane, and XY plane. They are work planes. They're standard work planes that you can't change. You can't do anything with them. So you would typically, not always, but typically, you would use these to start a new part. You would sketch on like the XY plane, and then you would create a sketch, create a profile, extrude up, and then start modifying it from there. But we'll get to there'll be a point very soon afterwards where you need to create a sketch, and you can't use these 3 standard work planes, and you might not be able to use the faces of the geometry that you've created so far, and that's when you start to need to use work planes. So in the interest of trying to keep this as quick as possible, I'm not going to go through every single method of creating a work plane, but what I will say with a huge degree of confidence and controversy is don't use these. These are relatively new in Inventor, and they're there to assist beginners. But I'm a beginner. Well, yeah, you are, but these options here, right, what they do is they will restrict what you can click based on which one you select. So if this one here, for example, 3 points, this allows you to create a work plane intersected between 3 points. But what it does is when you select this, it stops you picking anything other than points, which is great. That is great, but when you're a beginner, you might not know what you need to click. You know where you want your plane to be, you know where you want your sketch to be, but you don't know what you need to click to get it there. So if you've selected this one, then you might have selected wrong, and you've stopped any chance of being able to select the right way because your cursor's still stuck to just picking points. So it's great if you know for sure, for 100% that that's where you want the work plane to go, but if you're just a beginner and you're just getting your head around it and you're playing around, try to not use these. They'll just cock block you. They'll cock block you into not being able to pick the right thing. So what I would suggest you do, and this is what I use all the time, I'm old school, I learned all this sort of stuff before any of these buttons existed, so I'm trained to use this thing here. So if you just use the plane button, this lets you pick anything in the model, absolutely anything, faces, edges, and points. And it will create a work plane based on whatever it is you click. So, like I said, there are a number of different ways of making work planes, and I'll go through the most common ones. So, one of the most common ones is just to select a flat face, hold down the left mouse button, and then pull away. And then that will offset the work plane from that face by a set distance. So, if you type in 50mm here, and then click OK, that creates a work plane 50mm away from that face, and it's adaptive. So, if that face moves, then the work plane will move with it, and you can then sketch on that plane like that, and then that's your bit of paper in space ready for you to sketch on. Right, for that particular method, there's probably somebody out there ready to jump in the comments and you did it very slowly, that was a really unproductive way of doing it. Yeah, no, right. So what that particular method that I've just shown you, if you were to create a new sketch and then do exactly the same thing, hold down the left mouse button and then pull away, and then say 50mm, and then OK. That does like a 2-in-1 type thing. That will create the work plane and the sketch at the same time. So that's a little bit better, I guess, for that particular method of creating a work plane. Alright, so once you've made a work plane, there it is in space. If you want to get rid of it, you can if you want to interact with a work plane, by the way, you've got to hover over the edge. Right? You can't interact with the work plane in the middle. You've got to hover over the edge, right click, and then if you want to, you can delete that work plane. When you delete a work plane, normally there are things associated with the work plane, like sketches, and then there's features associated with that sketch, which is associated with the work plane. So it's giving you the option here to delete everything that goes along with it. So that's sketch there is associated to that work plane. Do I want to delete the dependent sketching feature? Yes, and the way it goes. Alright, so that's the first common way of making a work plane. Another really common work plane creation method is to create a work plane and then pick a flat face and then pick a second flat face. And what that will do is it will intersect a work plane through the middle of those two faces, essentially finding you the center line of your part. So if I was to click there, that work plane is now representing the center line of the part. And again, it's adaptive. So if this face was to move up, that work plane would follow to always be central between these two faces. And then you can use this plane here as, like, say, for example, let's do a mirror of that feature. And then the mirror plane would be this work plane here. And then that's essentially a center line for a mirror. Alright, so that's another way of doing a work plane. Other ways are, like, for example, angled work planes are tricky to get your head around. And again, you've got to think of the paper, or think of the work plane as a card concept. So if you want to create an angled work plane, what you'd do is you'd say, all right, give me a work plane, and I want the work plane to be angled around this edge here. So you click that edge. So think of this now, right? Think of having a bit of A4 card in your hands, and you're going to put the A4 card onto this edge. Now that card can spin around the edge. It's touching the edge, but it can spin around it. You've then got to say to Inventor, right, this is the angle I want the card to be. But you can't verbally tell Inventor where. You've got to click things and say, right, well, this is the angle based on a flat face. So you say, right, hinge the card around that edge, but click that face, and then you can tell Inventor, I want the card or the plane to be angled 45 degrees from that face there. So it's hinging, intersecting the work plane through that edge that we clicked, and then it's going to be 45 degrees from that face. And you can put in a negative value as well, negative 45 degrees. Click OK, and then there's your work plane, angled work plane. And what you can also do as well is you can create work planes to create further work planes. That work plane there could exist purely to make another work plane. So I might now want to create another work plane, hold the left mouse button down on the edge of that work plane, and then drag away. And then that first work plane exists to do nothing else other than make this work plane here. And now we've got an angled offset work plane, which again is adaptive. If that one was to move, that one would move. If this face was to change angle, then these would always be 45 degrees from that face. So nothing wrong with doing that at all. Okay, other ways of making work planes. Sketches, for example. So if we say, let's create a sketch on this face here. Creating a sketch on a flat face doesn't make a work plane. It doesn't need one because you've got an entity there to sketch on, so it doesn't need to make a work plane for that. But what we can do is create, like say an arc like that. Finish that sketch, and you can create a work plane associated to the end point of the arc. So you might want to put a work plane parallel to the end point of the arc, so to create a sweep, like a pipe or a cable or a cut, something like that. So you create work plane. You would select the end point of the arc, and then if you pick the actual arc itself, it'll create a work plane which is always going to be perpendicular to the end point of that arc. So if the arc itself was to move, like here, and then we click update, the work plane will always be normal and perpendicular to the end point of that arc. And then what you can do is sketch on that work plane, press F7, slice the graphics. That point there, that's the end point of the arc, so we can project that, and then we can create a circle, something like this, finish the sketch, and then we can, obviously this has got nothing to do with work planes, it's just kind of a, finishing the story type thing. There's a cut, using that work plane, and that cut is now perfectly kind of, so it's absolutely sound and legit, because the work plane is at the right angle. So that's another way of creating a work plane. There's loads of ways. I mean, I wish I could go through, you can click work plane, you can pick, that point, and then sort of around that point there, and it'll intersect the work plane between all those 3 points. Loads of different ways. The best, like I said at the very start, the best thing to do is to use this button here, and then that will let you click anything. Just click things, and then, right, so if I click that face there, and then I was to click that there, so I'll get a work plane there, right, I see what it's doing. So if I was to click that face and then that point, so it's gonna intersect the plane through that point, but at the same angle as that face. I see. Do you see what I mean? You can then get a bit creative with it. It'll let you click various different things. If it puts a work plane somewhere you don't like, you can just undo, and then there's nothing lost. Okay, so that's a couple of different ways of creating work planes. What I want to do now is just show you some different interactions you can have with your work planes. Now, the first and most, well, probably not the most important thing, but is the work plane size. Visibly on screen, your work plane it's that big, right? It gives the illusion of only being able to sketch within that rectangle. Not true. If you were to create a sketch on this plane, for example, you're not restricted to sketching just within it. Work planes are infinite in size, mind blown. They are. There's no edges to them. They represent an infinite plane, an infinite face running through space. But visibly within your modelling environment, it has to represent the work plane somehow to show you that it's there, so it gives you this rectangle. Now, the best way to prove this is just, there's the work plane, I'm going to zoom out and I can create, you can sketch anything you want. You're sketching on the plane of that work plane, but it can be any size you want, but we're still on the same edge as the work plane. Now, if you find that you're sketching something and your work plane is sort of being dwarfed and it's fading off into nothingness, what you can do is right click on the work plane itself and then select auto resize, and it will resize the work plane to suit whatever sketches are associated to it. So it'll just sort of magnify itself around the larger sketch, and if you do change that sketch, it'll always increase the size of the work plane because the work plane's set to auto resize. A couple of other things which are quite important for work planes is you can't really miss it, but there's two colours on a work plane. You've got an orange side and you've got a blue side or a purple side, depending on your screen colours and that. Orange is positive, blue is negative. It doesn't really matter until you start doing extrusions and offsets. So, for example, if I was to sketch on this work plane and then extrude this sketch, anything in a positive direction is going to come away from the orange face. So a positive value is coming away from the orange side of the work plane. If I put a negative value in, it's going to go in the opposite direction. Well, it should do. Okay, no, you can't extrude in a negative direction, can you? Never mind. But if you were to offset plane from this work plane, that way, the orange way is a positive value, blue value, the blue face is a negative value. That's pretty much it. If you've created work planes and you're finding a mixture of orange and blue faces and it's just killing your OCD, you can interact with the edge of the work plane, right click on it and then flip normal, or flip the blue and the orange side, and it'll flip any sketches and features which are already created. So if we were to extrude again, extrude that there, that's extruded in the positive direction. If we were to flip the work plane, it'll flip the extrusion. So because it's a positive value extrusion, it's always going to come away from the orange side of the face. Right, I hope this isn't too long. Right, turning them off. Interact with the edge of a work plane, right click, and then you can untick visibility and that'll turn the work plane off. Once you've used a work plane, there's no hard and fast rule, but in most cases you tend not to need to use them again, so you can just turn them off. And you'll see in your browser any work planes which have got a grey icon have been turned off. You can right click on them and you can turn them back on. And there is a shortcut for doing this for all work planes. You can go to the view ribbon bar and then go to object visibility and then turn off either all work features, which is all axes, points and planes, or you can just untick user work planes. And the shortcut key for that is Alt and square brackets, and that'll just turn them off, turn them back on again. You can rename work planes if you want to. I wouldn't recommend it because you get that many of them. You can end up with hundreds of work planes in a complex part, so renaming them would just be a waste of time. But if it's something important, you can, you can type stuff in there and rename them whatever you want them to be. You can right click and interact with work planes in the browser as well. You just get a more structured menu where you can create a new sketch. You can edit the dimension. The dimension, if you see edit dimension on a work plane, that's because the work plane is being created using like an offset value. If you intersected a work plane between two faces, there is no numeric dimension controlling that work plane, so you won't see that option. But if you do have edit dimension there, that means you've got a value which you can edit. So this is because I offset that work plane by 50 mil, edit dimension, and then you can change that to whatever you want it to be. No visible change really because I'm zoomed out that far. So that's edit dimension. So there's a work plane which doesn't have a dimension to edit. This one does. Redefine feature is quite an interesting one. Redefine feature will let you completely redo the work plane from scratch. And I'm going to get rid of these because I'm starting to lose what I'm looking at. Let's get rid of him. Delete. Get rid of this. Delete. Yes, delete all consumed. Yeah, so if you delete work, did I cover that? I can't cover that. Yes, you can delete work planes and then I'll get rid of all consumed sketches and features. Okay, right, so yeah, redefining work planes. So for example, if we were to create a work plane between this space here and then this space here, that'll intersect the work plane through the middle. I'm not sure why it's made it that way, but you can, if, well, actually it's a good thing it did. If you want to manually resize a work plane, you can do it by hovering over the edges of the grips, and you can either move them around if you miss the grip, or there you go, you can change the size like that. But redefining a work plane, right click on it, if you select redefine, and notice as well, I've kind of cocked this up, but this work plane, I've just resized it and it's sort of moved the work plane away from the model, which just sort of blows your mind, boggles your mind. The work plane is actually still going through the middle of the part, it's just sort of moved away, but you can see there it is, still intersecting the middle. So right click on a work plane, if you go to redefine feature, you can then click two different faces, and then you can completely reposition that work plane and it'll, that's something right, pigs hear this. It'll reposition the work plane based on the new inputs that you select. I'm sure it's making that big. Never mind. Alright, I think that's probably about enough. So that's work planes. If you liked the video, if it was useful, slap that like button, give it a good slapping. Subscribe if you haven't done already, and until next time, cheery bye.
Hello and welcome to this Autodesk Invented tips and tricks tutorial in 60 frames per second. Goodness. Okay, this is going to be a quick start guide, a how to get started with sheet metal. Right. Disclaimers, as always, in most of my videos, this is not a training course. If you were to go to your Autodesk reseller and say, give me a training course please on sheet metal, they'll say, are you got a day free? Because it's a big module, and I'm going to try and condense that into, I don't know how long it's going to be, but probably around 10 to 15 minutes. So it's going to be short. I cannot cover everything, but I'm going to try and get you started on it. So the first thing you need to do, whenever you're working with sheet metal, it's all about your styles. You've got to get your styles down. So how would you manage your styles? Well, the easiest thing to do is to get it right in your template. Whenever you start a new file in Inventor, you'll notice you've got a sheet metal template. Now that template exists on your computer. Hover the cursor over it and you can see there's a tooltip saying where the template is. The best thing to do is to open up that template and create the styles that you're going to use in that template. So that's exactly what I'm going to do. I'm already there. It's C uses, this is the default template, it's C uses public documents, Autodesk version Inventor templates. So open up that sheet metal template and it presents you with what looks like, oh, I can start modeling here. No. Don't do any mod.
And everything.
In this box is what I believe to be the world's smallest proper RC drift car. I'll show you in a minute what I mean by a proper mini drift car, but this is from BM Hobby. BM Hobby says FR Legends, first learn drift. I can't see it because there's bubble wrap on it, but what it should be in there is a nice classic looking A86 from Toyota, and it's a slightly tuned looking one, by that meaning a little bit shorter and wider generally, not to scale. There's some details there. It's got a proper servo, it's got a 28,000 RPM motor, guess it's brushed, electronics, and well, yeah, a dedicated drift chassis. There's some more details there. There's the body, looks like the bumper. Does the rear bumper come off as well? Got a moving head, moving lights by the looks of it, and then you got a touring mode and a drifting mode. Nice. Now I featured a fair few of the little mini four-wheel drive, cheaper drift cars. More recently, the die-cast Porsche and Nissan, which were really good, like really good. But they're only like, I think they're less than $40. This is 100 and something, and actually I can see from the box it's a bit bigger than I thought it was going to be, which means this track that I've got out is probably not going to be ideal, which is fine because we'll just build a bigger track in the workshop. Why did I think it? I thought it was a lot smaller than that. There's your driver. His head wobbles. Don't know if that's a spare bit of chassis or whether you need to fit that. There's also some rubber tyres in there. Looks like some, I don't know whether they're to be to do with the axles, but we'll have a look. But there's some metal-like rods in there. We've got either a spare motor or maybe a slightly different one. Guess that's for your wheel nut, screwdriver, whatever they are, and an Allen key. Two Allen keys, a set of instructions, looks like a list of parts. There's no part numbers there, it just tells you what all the bits are. Oh, hang on, what are they? Right, that says racing steering knuckle, and then you've got a drifting steering knuckles. So I wonder if you have to switch them rather than it made it out on the box. So it says switch, touring and drift, but I thought that meant a switch on the controller, but you might have to change the steering knuckles. I guess we better try both then. I paid extra for a battery. I don't know what size battery tray is, but there's a link in the description where I got it from, and you can have the option with battery. Comes with a Dumbo RC transmitter. These are quite common with a lot of stuff now. You have your dual rates and trims and dip switches, and this probably has got a gyro. You've got a channel 5 there, which is usually your gyro, and we've got a channel 3 and 4 at the top there. And then this is the little car. It looks so cool, but it is definitely a lot bigger than I thought. Definitely giving me some Mini Z or Mini Z vibes. Oh, hang on a minute. It's got a battery in it as well. Why did I pay extra for a battery? Oh, I'd say it's definitely got the drift steering knuckles in it. Look at that angle on that. Wow. That is so cool. We've got some suspension as well. A little bit of tape in there holding the lights down. Nice little feature to have. I don't know. Doesn't look like there's any way to put a servo in there to remotely do them, but I guess they stay up if you move them up. It looks so cool. It's got some really nice detail on it. I love that it's got authentic like mini light or super light wheels or whatever you call them. I think they're called something else like the Japanese variant. Wheels don't quite line up at the back, but I think that's because they've got quite a bit of toe in. I guess that's to do with how it performs, but this is a really nice looking car. And as you can see, it is a little squished, it is a little tuned, but it does look really cool. I put the interior in there, it just slots in underneath, and it's got like a few little holes that it just slots onto. Look at this cool feature as well, that the bumper's just got a magnet. I guess the rear's the same. Is the rear the same? Yeah. And the rear as well. Maybe if you have a bit of a wall tap, it'll knock that bumper off. That is so cool. I just realised it comes with this battery, but it didn't have a charger or anything for it. Luckily, I think this one I bought comes with an adapter so you can charge it off of like one of your standard USB chargers. Ah, I just realised that's the battery. That's the battery charger. I bought the one with a battery and a charger. So USB-C, this is just a little 3D printed case by the looks of it. But I don't need that adapter. I should be able to just plug it in with a USB-C charger, see what it does. Wow, it's charging at some rate. That's quite a high rate it's charging at. That's only 350 milliamp hours as well, so I can't imagine that is going to take very long. Most chargers that I plug in here are like 1 or 2 watts. Right, well the battery's charging, let's have a look at this. So it's got this, like it says, modular chassis design. Everything looks like it just comes apart really easy. You can adjust the wheelbase. I don't know what this spare bit is here. Does it say? The touring mode shows you there you have to change the steering knuckles over. No, I don't think it tells me. It's certainly different to that one. Anyway, that looks like our steering servo there. Just, oh yeah, there you go. There's your little steering arm under there. Like I've shown you out there. It's got a proper drift angle on it, that is crazy. This is your ESC. Battery goes in there. You've got the motor cable there. You've got a plug there that says lights on it. And I'm not sure what that one is. I think, I'm looking through my phone, I think it says switch. I think that's what it says. There's your motor there, it says 28,000 RPM. You've got a really big spur gear just down there. You've got your drift wheels on it. Really, really nice. They're staggered as well, look. So the rear have got a nice deep dish and the front are a bit more shallow. The front are also thinner. That looks so cool. And I've not mentioned yet, but most of you probably realise what I mean by a proper drift car. What I mean by that is, it's rear-wheel drive. So for all those that have watched some of my other videos that have had a 4-wheel drive and I've said drifting, and you've gone, it's not drifting, it's not rear-wheel drive, well there you go, we've got one. So because I thought this was probably half that size, I've got my little Turbo Racing drift track out. But I reckon this is going to be a little bit small, but give it a try on here We'll just get it set up, make sure that it drives, and then we'll build a better track on the workshop floor. As I expected, that battery charged super quick. I mean, that's good that it was a really quick charge, but a battery that size, you probably need to be a little bit careful chucking too much in it. Right, let's give this thing a go. Right, so definitely got a gyro. I've got a feeling we might need to turn that down. It seems very sensitive. It's all very well turning the steering by hand, but look, this is how it actually works. That is awesome steering. Seems pretty quick as well. I really hope this drives well. Oh yeah, this surface is way too slippery for it. You're going to need to use carpet, but still, once you get going, let's see if it's going to go on carpet. Oh, there you go. Now we're talking. Right, I need to set a track up, don't I? So I spent a little bit of time yesterday getting this thing dialed in. I've also adjusted the wheel slightly. It's really easy to adjust. You just undo those two screws there and you can slide the wheelbase. I've lined them up because they were actually rubbing. They were too far forward and they were rubbing a little bit on the body and it was causing it to, well, not drift as good as it could. Anyway, I made a little obstacle course. The workshop's too messy to make an actual drift track, but I'm working on that. I've got plans for next year for an epic permanent track. But anyway, this thing absolutely rips on the drift. Look at it. It is, I'm going to say it right away, not even by the end of the video. This is the best mini drift car I've ever driven. It is just absolutely dialed. The gyro does need a little bit of tweaking, and it does have that gyro wobble a little bit. But man, this thing, I've never driven anything so small that handles like this, as it's meant to handle. It's mad, absolutely mad. We go wide, all the way around, wide, 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 and then we'll tuck it in and go, look at that. Just look at that. Incredible. Whoa. That was so much fun, so much fun. Anyway, I've switched the tyres, I've switched the steering knuckles at the front, so we're now in touring mode. It tells you to turn the steering jaw rate down for this to 25 to 50. I reckon we probably need to turn the gyro right down as well, or off. I don't think that this mode is going to excite me as much as the drift mode did, because this is a drifter, isn't it? Although, we are going to give it a go. Let's see what it does. Oh, actually, that handles really well. I can tell straight away that the steering on this and the handling, you can still slide it around a bit. Let's put a little bit of gyro on. Well, there you go. This thing, it handles and steers really well with them rubber tyres. Obviously, I'm not getting a proper track or anything set up, but well, there you go. I didn't think this was going to do all that well set up like this, but man, see what it's like on a bit of concrete. Oh, we're going to need a bit of gyro on here, I reckon. Can we get a slide? No. Oh, a little one. Well, there you go. What a little beast. What a little beast. Absolutely mad at drifting. And I reckon if you got a little mini Z track, you might find that this is actually quite competitive. Be worth a try anyway. If you compare this to the cost of your average Mini Z, it's actually a decent deal, was it? I think it was just over £100, so like $120. You can drift it. It's got lots of adjustments on there. It looks good. It drives amazing. Super impressed. I've had my eye on these for a while, so I'm glad I finally got one.
This is a Tiny Whoop, a micro FPV drone that is super fun to fly. It is really durable and people love them because you can freestyle and race with them. However, they have a couple big problems. One of them being the small LiPo batteries that come with them only provide 2 to 5 minutes of flight. That's just not enough. And when you're ready to go outdoors, these little Tiny Whoops get blown around in the wind. Today, I'm going to show you how to modify your Tiny Whoop to use this battery, a lithium-ion cell, to get way longer flight times and better wind resistance. Some of you may be thinking that a lithium-ion cell is not going to work very well with a Tiny Whoop. Well, you're partially correct.
An 18650 weighs about 3.5 times more than the LiPo, and Tiny Whoops just aren't designed for that much weight. You can simply just strap this battery to a Tiny Whoop and it will fly. But it flies horribly and is way underpowered. With the LiPo, it's way more zippy. Here's full throttle on the LiPo, but my flight time was only 3 minutes. Here's full throttle with the lithium ion, much slower. It doesn't fly well, but it flew for over 10 minutes.
And that is why we need to do some modifications to make this battery fly more like this battery. The only tools you'll need are probably a Phillips and a hex. You may need some hardware, and then possibly a soldering iron as well. Now we're going to take our Tiny Whoop and add a new frame to it. This is the Beta FPV Twiglet 2.5-inch frame. It is super lightweight, pretty durable, and it's going to give us a little bit wider stance to help us carry that extra weight. One of the best parts is this guy only costs about $4 off of AliExpress. But before you switch all of the electronics onto this frame, let's talk motors. So a lot of 75mm Tiny Whoops come with 0802 motors. Now these are just too small to efficiently carry a lithium-ion battery. I found that 1102 motors are about as small as you can go and still carry an 18650 effectively. So if you have a Tiny Whoop like the Meteor 75 Pro that comes stock with these 1102 motors, you're in luck, you won't need to switch anything out. If you have a smaller Tiny Whoop like a normal 75mm or even a 65mm Tiny Whoop, you're still in luck, because I have found these generic 15,000 kV 1103 motors that perform very similarly to the 1102. And the kick is, on AliExpress, these cost $375 a piece. That's insane. So it just costs $15 for a pair of 4 of these, and you'll just switch them over. Lastly, you'll just need to upgrade to 51mm props. This larger motor, paired with the longer props, will give us a ton more lift. I designed these 3D printable battery holders for the 18650. They've been really durable, and they have this nice skid plate to protect the battery. Simply just slides in, and it'll mount right into the frame. If you don't have a 3D printer, I want to make these really affordable on my online store in the future, but that is not set up yet. However, on AliExpress, you can buy these 2S LiPo battery holders, and it will squeeze an 18650.
Hello, Sam. Welcome to Get My Gun Tips. And on today's episode, we are going old school, Kylie and Jason old school, Coolio old school, with this ridiculous yes go-kart, which looks absolutely disgustingly bad. But I don't care. I don't care. Do brake discs really hover around an axle with no means of support? No, they don't. But in the world of Inventor, they do, because they can't, because we're just gangsters like that. But we're going to do an Inventor test drive, right? It's for beginners, odds, that's what I do. But I'm going to take you through part design, and what we're going to be doing is we're going to be modelling from scratch, from absolute scratch, this bad boy here. So we're going to take Inventor from nothing and get to this. And if I can get it onto a file sharing site, I'm going to upload this entire data set so you can follow and do the exact same thing, because that's kind of the point of a test drive, I suppose. So we're going to be doing this, and it's not going to take too long. In fact, you can get to this from scratch in about, well, once you know exactly what point it's in, probably about a minute. It's that easy to do. So we're going to be modelling that up, we're going to put it into this assembly, and we're going to bolt it into place. And we're going to be putting a bit of adaptivity in there. So we're going to be doing a mixture. We're going to spice it up, a mixture of some basics, but also throw in some little advanced teasers in there as well to show you some of the things that you can do with Inventor. Alright, so we're going to start from scratch. So we're going to go into an IPT. And this is all done on Inventor 2016, by the way. This dataset was originally done in Inventor 10. Right, now I'm not talking not 2010, oh no, Inventor 10. That's like from 2000, in fact, there might even be a date stamp on here. Date stamp. Is there a date stamp? That would be nice if it was. 2001, that's not coming, right? It might be, actually. It might be. But Inventor 10 was, what, 2005, 2006? Well, this is old school. Yeah, that's how old school it is. I mean, look at the tyre. Look at the tyre. That is a next level, pro, legit tyre. They don't make tyres like that anymore. Right, anyway, so we're going to start a new part file. Right, and in this new part, we're going to start modelling, like I said, from scratch. So feel free to follow as I'm going. I'm going to be doing this slow, I'm going to be talking a lot, I'm going to be explaining a lot. So whatever I do can be done a million times quicker if I wasn't gassing. But I'm gassing so people can follow what I'm doing and can understand what I'm doing and why I'm doing things. That's the whole point of a test drive and a tutorial. Alright, so we're going to start by creating a new sketch. So we're going to start a new 2D sketch, and then Inventor 2016 gives you these little orange squares, right? These are your work planes. So these are your starting points for new sketches. So XY, YZ, and XZ. Now, whichever plane you start on, it doesn't really matter. It can, but it normally doesn't. But mostly best practice, sort of, kind of, you would normally sketch on the XY plane. That's like, if you think AutoCAD, right? If you think AutoCAD X, Y, and Z axes, then XY is kind of like the ground. It normally is, anyway. Z pointing up, usually Z points towards the sky, so X and Y is usually the ground, so there's XY. So we're going to start on the XY plane, and then orientates the sketch, and it shows it looking straight down on the sketch. Now, I've configured a couple of application options, which might look a little bit different from yours. What I tend to do, is I'll set the annotation scale normally to 1.5 just to make it a little bit bigger. I'll normally select the other prompt to 1. I'll normally go into sketch and I'll turn off grid lines, but I'll leave on minor grid lines and axes. Again, normally that's what I do. Doesn't matter, it doesn't matter. I'd always turn off point alignment because it gets on your nerves, and I'd leave the rest of them on. And that's pretty much it. That's pretty much it to get going. You don't have to do any of that, but it just, in my opinion, makes things a little bit easier on the eye. In display, I've got display quality set to smoother, just so it makes things a little bit smooth and slick and cheesy on screen. And then hardware, I've got it set to quality as well. But if you've got a bit of a potato of a computer, you can set that to conservative or performance, just to make things a bit easier. Right, let's get going. So the first thing we're going to do, we're already in a sketch, so we're going to start by drawing a circle. Right, in the circle, let's just go back and reference the part that we're going to be drawing. So we're going to be modelling this. So we need to figure out how to get this shape down. So I'm going to start by sketching out the outline of the main body of this carrier part. So we're going to go back into part 1, and then we're going to draw a circle. Now, you can keep on going with the ribbon bar if you want to, or it depends, right? It depends. If you want to get used to working as fast as you can and start using more of the more recent, modern utilities that are put into Inventor, you can right click, and then you can use these, they're called markup menus. So you can use these like center point circle. That is exactly the same as that there. It's just in a different place. So you can use that. If you want to be an absolute and utter pro, you can hold the right mouse button down. Remember that center point circle is at the top left, and then just hold the right mouse button down and then draw a line, and then let go of the right mouse button. Like that. And that if you can do that, if you can remember where line is, where circle is, and where rectangle is, you can be an absolute legend. You could just be that guy that sits in the office just doing. But actually, it might be. But Inventor 10 was what, 2005, 2006. Well, this is old school. Yeah, that's how old school it is. I mean, look at the tire. Look at the tire. That is a next level, pro, legit tire. They don't make tires like that anymore. Right. Anyway, so we're going to start a new part file. Right, and in this new part, we're going to start modelling, like I said, from scratch. So feel free to follow as I'm going. I'm going to be doing this slow. I'm going to be talking a lot. I'm going to be explaining a lot. So whatever I do can be done a million times quicker if I wasn't gassing. But I'm gassing so people can follow what I'm doing and can understand what I'm doing and why I'm doing things. That's the whole point of a test drive and tutorial. Alright, so we're going to start by creating a new sketch. So we're going to start a new 2D sketch, and then Inventor 2016 gives you these little orange squares, right? These are your work planes. So these are normally these are your starting points for new sketches. So XY, YZ, and XM. Now, whichever plane you start on, it doesn't really matter. It can, but it normally doesn't. But mostly best practice, sort of, kind of, you would normally sketch on the XY plane. That's like, if you think AutoCAD, right? If you think AutoCAD X, Y, and Z axes, then XY is kind of like the ground. It normally is, anyway. Z pointing up. Usually Z points towards the sky, so X and Y is usually the ground, so there's XY. So we're going to start on the XY plane, and then orientates the sketch, and it shows it looking straight down into the sketch. Now, I've configured a couple of application options, which might look a little bit different from yours. What I tend to do is I'll set the annotation scale normally to 1.5. So
What the fuck is that?
I'll normally select the other prompt to 1. I'll normally go into sketch and I'll turn off grid lines, but I'll leave on minor grid lines and axes. Again, normally that's what I do. Doesn't matter, it doesn't matter. I'd always turn off point alignment because it gets on your nerves, and I'd leave the rest of them on. And that's pretty much it. That's pretty much it to get going. You don't have to do any of that, but it just, in my opinion, makes things a little bit easier on the eye. In display, but display quality set to smoother, just so it makes things a little bit smooth and slick and cheesy on screen. And then hardware, I've got it set to quality as well. But if you've got a bit of a potato of a computer, you can set that to conservative or performance, just to make things a bit easier. Right, let's get going. So the first thing we're going to do, we're already in a sketch, so we're going to start by drawing a circle. Right, in the circle, let's just go back and reference the part that we're going to be drawing. So we're going to be modelling this. So we need to figure out how to get this shape down. So I'm going to start by sketching out the outline of the main body of this carrier part. So we're going to go back into part 1, and then we're going to draw a circle. Now, you can keep on going with the ribbon bar if you want to, or it depends, right? It depends. If you want to get used to working as fast as you can and start using more of the more recent modern utilities that are put into Inventor, you can right click and then you can use these, they're called markup menus. So you can use these like center point circle. That is exactly the same as that there. It's just in a different place. So you can use that. If you want to be an absolute and utter pro, you can hold the right mouse button down. Remember that center point circle is at the top left, and then just hold the right mouse button down and then draw a line, and then let go of the right mouse button, like that. And if you can do that, if you can remember where line is, where circle is, and where rectangle is, you can be an absolute legend. You can just be that guy that sits in the office just doing this. Yes, I don't know if you saw, I don't know if you saw what I did there, but I'm flicking my wrist like this and I'm activating commands, whereas you, mere mortals, would have to go to the ribbon bar. So you can do that if you want. Right, so we're going to start by drawing a circle, and then we're going to snap to the center point. Best practice, right? This really is important. This is not to be forgotten. Best practice, if you're drawing a part that's symmetrical, so if it's square, rectangular, circular, always draw it symmetrically around this center point. So if you're drawing a circle, make sure the center of the circle snaps to that yellow dot in the middle. If you lose the dot, right, for example, if you delete the dot away, so you might have drew something, put a window around everything and deleted it, yeah, you need to get that dot back because it's now not there, you can't snap to it anymore. Well, it looks like you can, but trust me, it's not snapped there, it'll move away. So what you do if you lose the dot is select Project Geometry, expand the origin folder, and then select the center point. And then right click and OK, and it projects. All the dot is the center point of the part. It's where all the axes and all the planes cross over. So it's the absolute central point in the 3D model. So everything, you want ideally everything to be symmetrical around that center point. And the reason for that, I've done a separate video on this quite earlier on. I think it was last year I did a video on this. But if everything is symmetrical around that center point, then you can use these planes as like mirror lines, and it makes placing the part into assemblies later on a lot easier. So back to drawing a circle. We're going to snap to that little yellow dot. We're going to move out, and then we're going to put a dimension in straight away. So there's a couple of ways you can do this. If you're not too sure of the sizes of the part that you're doing, you can just sort of conceptually, well, it might be about 25, so I'll draw a circle there, and then this one might be around 40. And then once you've drew the circles and you can come back later on. Just whenever you've finished sketching stuff, just right click and then click select OK or press escape to clear out the command. You can then come back to it later on, select dimension, and then say, right, well, I want to now, I drew it approximately 25, but now I'm going to make it exactly 25. Because the difference between Inventor and AutoCAD's sort of changing to be like this now. It wasn't back in the early days, but Inventor, the dimensions control the size of the object. So they're called parameters. The parameters control the object. So you can draw something approximate, come back at it later on, put a dimension on, and it'll constrain. That's the buzzword here. Constrains it to the right size. Okay, right. So that would be a drawing it approximately, but we're going to draw it precisely straight from the go. And we're going to be a bit more clever. We're going to snap to the center point, and we're going to name this dimension. I'm going to call them dimensions. They're not. Technically, specifically speaking, they're not dimensions, they're actually parameters, but I'm going to call them dimensions just for simplicity. But we're going to put in a name, right? So we're going to name this parameter, so later on we can find it and we'll know what it is and we'll know what it means. So we're going to say this is going to be inner diet. When you're giving your dimension names, when you're typing into this little dialog box and you're giving it a name, don't put spaces in there, don't put any daft characters in, it'll just completely cock block you on that. So we're going to say this is called inner diet, and then you put an equal sign in, and then you put the size in. So we're going to say inner diet equals 40 mil. Right click and OK. And it doesn't look any different. It doesn't look any different to what it would have been if we just typed straight 40 in. But that dimension is now called inner diameter. How do we know? Well, there's another way to find out. Right click inside the graphics space, go to dimension display, and if you put on name or expression, it'll show you that this dimension is 40 mil and it's called inner diet. If you change dimension display to just name, it'll just say, well, that dimension is inner diet. If you want to look at a complete list of all the dimensions inside your part file, go to this FX button at the top here, and then it'll show you them all. So model parameters, you've got one called inner diet and it's 40 mil. And if you want to, you can change it straight from here, just put in a different number and it'll, inner diet, right. So, because what will happen is later on you'll get a massive list of dimensions or parameters, and if you don't name them, they'll just be called D0, D1, D2, D3, D4, so on and so forth, up to D500 and something or other, and you'll not know which D number equals which sketch dimension. So if you name them, it just helps you identify them if you want to make a change to them later on. Right, so we're going to make that 40 mil. Okay, and I'm going to change the dimension display back to expression. Right, so that's the inner diameter. The next one we're going to do is the outer diameter. So we're going to draw another circle, and then we're going to snap to the center point. And for this one, we're not going to put an expression in straight away, because what I want to do can't be done at this point. So we're going to just drop the circle down. We're going to right click and OK. And we're going to go to dimension, place a dimension on this circle, left click to place it, and then we're going to reference this one, because I want the size of this circle to be controlled by the size of this circle. Huh? What? What are you talking about? Right, well watch. If I want the diameter of this circle to always be 20 mil larger than the diameter of this circle. So what I can do is select that one. So I'm building an expression here, I'm building in a formula. So I can say this one is the inner diameter plus 20 mil. And that will mean D2 equals inner diet plus 20 mil. Or I can put the cursor at the start and I can name this one. I can say, well actually this is outer diet. Outer diet equals inner diet plus 20 mil. And then there you go. now got a little fx. That fx means that this circle or this dimension is being controlled by a formula, and this dimension is called outer dia, and it is inner diameter plus 20 mil. So its resulting value will be 60 mil. So okay, go back to dimension display, and then you can see the value 60 and 40. Alright, so we're going to finish that sketch, and we're going to zoom out a little bit, and we're then going to perform our first 3D command, right? The first one we're going to do is the most basic of 3D commands. It's the one that's the first one on the written bar, and it's the one you're probably most commonly use more than anything else, and it's extrude. Extrude, lad. Extrude. So we're going to extrude, and then what it wants you to do is pick a profile. So you've got to select a section. So in this case, we've actually got 3. You might think 2, isn't there not 2? No, there's technically 3 different profiles here that we can extrude. We've got the inner one, we've got the outer profile, and then you've got the entire circle. So that would be this outer boundary here, which would be the entire circle. So we've got 1, 2, and then the overall one would be the third one. So it's asking you to pick which one do you want to extrude. So I'm going to pick the outer diameter, or the outer profile, and then it sort of finds that fill. Think of, if you're an AutoCAD user, think of like a hatch fill. So it looks for a water or an airtight area, and it goes, there's a sketch region which is closed. I can extrude that into a solid. So that's what it does. You can hold the left mouse button down on this arrow and just sort of conceptually move it around and say, what do I want it that? Maybe that big, is that a bit too big? You can sort of drag it down and it'll show the size here. So in some commands in Inventor, you can either use these little mini toolbars which pop up next to your cursor, or you can use a dialog box. Old school people like me prefer using a dialog box because that's what I was going to say grew up using, but that's what we learned using. But if you want to get used to using these, you can minimize the dialog box by clicking that arrow. You can carry on using these. But I'm going to stick the dialog boxes because personally, I don't like these. I don't like these. I don't like the little icons because you don't immediately know what they are. And sometimes in some commands, there's more information in the dialog box than there is here. So I'm sticking to using dialog boxes. So I tend to ignore these. So for the extrusion, what we're going to do is we're going to give this a height of 40 mil. So that's what the extrusion size is going to be. And you can also name the parameter or the dimension within the extrusion. So we can say height equals 40 mil. Now the extrusion's going up from the sketch. You can go down from the sketch, or you can go mid-plane, so that'll go 20 mil either way. So in order to keep things symmetrical, again I'd recommend, if it is going to be symmetrical, that you use the symmetric direction. So you go 20 mil and 20 mil either side of the sketch. It just makes things a little bit easier. And then click OK. Woohoo! Got our first solid. Right, what's now happened is on the left hand side, right, this here is your browser, so this is where it keeps track of everything you've done. So we've now got our extrusion, which is that thing we just created using the profile, and then if you expand extrusion, you've got a sketch underneath it. And that is the sketch which we've just drew with the 2 circles. It is consumed by the extrusion. At any point, if you want, you can double click the sketch and you can make a change to this. So if you make these circles bigger, so for example, if I was to double click that dimension and make it 50, that outer one, because that's always 20 mil larger, turns into 70. If you finish the sketch, it'll then adaptively update any 3D features associated with the sketch. So it's kind of bread and butter. In the early days, that was like mind blowing. When you went from AutoCAD to 3D, you're like, wow, that is amazing. But you kind of take it for granted now. It's sort of it's expected behaviour is probably what I would say it is nowadays, right? So what we're now going to do is add additional features. I need to create these legs that are sticking out from the side. How the bloody hell do you do these? How the sudden hell do you even start with them? Right, well, it's not too bad. What we're going to do next is create a new sketch, and we're going to sketch on the XY plane. Now, because I did an extrusion both ways, our XY plane, the ground plane, is running exactly through the middle of the solid. So we can sketch on that. Alternative, if you want to be an absolute pro, you can just press escape, because I've already started a sketch, so press escape. Create a work plane, so select plane here. These work planes are construction planes. You see that XY plane, the square? That's plane. What I'm doing by clicking this is creating a new plane, just like these XY planes, but I'm telling Inventor where to put it. So I'm going to say create a new plane, and I'm going to intersect. I'm going to make this plane intersecting between mid-plane, so a center line between that face and then that face. And then that puts a new plane parametrically placed between that face and that face there. Now you might be thinking, well, that's just totally counterproductive. Why would you create that plane there, where you've literally just shown me that you've already got the XY plane there? Why would you do that? Why would you do that? Well, the reason I would do that is because this plane is parametric between that face and that face. So if I was, for whatever reason, to move this solid up, for example, if I was to bump the entire thing up by 50 mil, the XY plane would stay there. The XY plane never moves. However, that work plane would move with that move command. So anything that I create from now on associated with this plane would move with it. So this plane is attached and assigned to the model, whereas the planes here they're fixed, they're a constant. They don't move with the rest of the model. So kind of getting a bit ahead of myself there, I guess, but it's I don't know. Maybe you do follow that. I don't know. I apologise. I don't know whether you will follow any of that. It's not important. It's not important, right? So we've created that work plane. What we're then going to do is create a sketch on this work plane. So we're creating our sketch. We're not using the standard planes, but when you do create a sketch, you need a flat face to put the sketch on. Inventor needs a flat surface for you to sketch on. You can't sketch on circular faces, so you can't sketch on here, for example. You can't sketch on the inner face. I can sketch on that. I can sketch on the bottom face, and I can sketch on here. So we're going to create a sketch on that flat surface. Now, when I'm drawing lines, our sketch is running through the middle of the 3D model. So take that front of that cube, and that looks straight down. Now, because of that, whenever I draw some lines, the rest of the model is interfering with my view. If I draw lines through the solid, I can't see them because we're sketching through the middle. Not a problem, not a problem. I'm going to take these lines away. What you can do is right-click, and then you can select Slice Graphics or press F7 for short. And what that'll do is it'll use the sketch plane to cut away material. So it removes everything above the sketch just temporarily, and then you can see what you're doing better. And then when you finish the sketch, it just cancels it out. It doesn't remember that you ever did it. It's just a temporary view thing. It's like a slice, like a section view, temporary. It's up to you whether you use that or not. I find it quite useful. Anyway, right. So what we're then going to do is draw the outer profile of the leg. So we're going to draw a line, or right-click, create line, or be a gangster, drag up. Yeah. And then you're going to hover the cursor over the edge here. Now, if you've got the application options set the same as me, so we've got sketch, auto project edges during curve creation. It makes absolutely no sense, but that ticky box means that when you draw a line and you hover over an existing edge, it's going to automatically project that edge up and allow you to snap to it, because that edge that we're snapping to there is actually that one there, but it's not on this sketch. So what it's going to do is project that edge up. It's going to burn it, is a better way of putting it. It's going to burn that edge onto this sketch and allow us to snap to it. And it's adaptive as well. So if that edge was to move, so if that face was to come over to here, the projected edge would move, and anything that's snapped onto that edge would move with it. So it's all adaptive, it's all associative, and it just makes things a lot easier if you do it that way. So we're going to draw a line. We're going to snap to the edge. We're going to draw this approximately, so we're going to click here. We're going to draw a line down to about here. And here's another tip as well. If you hold the left mouse button down on the end point of a line, so you draw the first segment, hold the left mouse button down here, and then pull away in like an arc like this, it'll draw an arc tangent to that last line. So you see that little symbol just there? That means that this arc is tangent to that line segment. We're going to let go about here, so you get the little tracking vector coming down. Let go just as the tracking vector appears, and then pull away, keeping the tangent symbol there. So again, don't do this, don't snap here because you'll not get a tangent constraint there. Pull away, and then finish about here, snapping to that black line. Right click, and OK. So what that's given us is a lovely sketch which is all constrained up, almost constrained. We've got a tangent here, we've got a tangent here, and then we've snapped to this yellow line here and here. And that yellow line is, don't forget, it is that edge there. It's that edge burned onto our sketch. So if this face was to move, that yellow line would move, anything that's snapped onto the yellow line would move as well. So there's the associativity built in. It prevents your entire model from collapsing later on if you make any big changes to it. Right, the next thing we need to do is we need to make sure that this point here is in line with this center point, so we need that to be exactly in the middle here. Now you could, if you wanted to, create these are sketch constraints up here, so these sketch constraints allow you to create conditions in your sketches that are fixed. So you can say, right, this one here is a horizontal, so I can say make that dot horizontally aligned to that dot, and then it'll do that. And then when you grab this dot, it's now fixed or constrained horizontally to that dot. So we're going to do that. I'm going to undo it though. What I'm going to do instead is I'm going to create a line, and then I'm going to click this button here, which makes this a construction line, and I'm going to snap to this dot and then pull it along here. Right click and OK. And instead, what I'm going to do is just hold the left mouse button down on this dot and then just drag it so it snaps to that line. So now our center point here, the center point of this arc, is now constrained to the construction line. Why did I do that though? Why did I do that? Well, the reason I did that is because these two lines here, that one there and then that one there, I want these to be symmetrical. And the only way I can do that really is to have a center line. So we're then going to use the symmetrical constraint, which is this one here. So we're going to create a symmetric constraint between that line, that line, that line there. Right click and OK. And then that makes sure that these two lines are always symmetrical. So now that that's done, we can now put some dimensions on. So we'll click the dimension button again, click this arc, and then we're going to make this, you could say, I don't know, I'm kind of over naming them. The whole point of naming them at the start was to just show you that you could do it, but you can say, you know, rad equals 6 mil if you want to, or you can just type in 6 mil. 6 millimeters, and then we're going to create an angular dimension. Oh, how an angular dimension? We've only got one dimension. Where's the angular dimension? No, you don't need to do no. You don't have to. No different dimension buttons. All you do is you pick the dimension button. There is just one, and then depending on what you click, depends on the type of dimension that it gives you. So I'm going to click that line there, and then it gives us an angular dimension. And then we'll just drop that down, and we can say this is going to be 20 degrees. Right click and OK. So the only dimension that it needs now, in order for this to stop moving around, is the distance of the center point of this arc away from the center point of the part, so that the leg length, but I'm going to leave this. I'm going to leave the length of the leg free to move, and the reason for that will become apparent a bit later on. So we're going to finish that sketch, and we're going to do a second extrusion. And you might be thinking, why didn't you draw that? Why didn't you draw this in this sketch here and just have that leg poking off the end of there? Because if I'd done that, I would have had to extrude this leg up the same distance as this. You would have ended up with a leg like 40 mil high, and it wouldn't. One of the golden rules when you do invent models is to keep your sketches as simple as possible. Look or think about what it is you're designing, and think about this as being different features and different manufacturable bits. So this body here needs its own sketch. This body here needs its own sketch. Try and think about it that way. Have a sketch per feature if you can. Don't put too much in your sketches. If you do start sketching something and it starts becoming an absolute cluster ball of a sketch, you've got loads of different squares and rectangles and all lines and dimensions all over the place. Try and think, can I break this down? Can I have a different sketch for this bit here and for this bit here? And it'll just make things a bit easier to manage in the future. So that's the reason why I didn't combine it. Right, so we're going to do another extrusion. So we're going to click extrude, we're going to click the leg, and it's defaulting to 40 mil because that was the last one we did, but we're going to change that to 12. We're going to go symmetric, and yeah, that looks about right. You'll notice how it's now almost welded to the side of this part because our line of our sketch stops there to be controlled by the size of this circle. What? What are you talking about? Right, we'll watch. If I want the diameter of this circle to always be 20 mil larger than the diameter of this circle. So what I can do is select that one. So I'm building an expression here, I'm building in a formula. So I can say this one is the inner diameter plus 20 mil. And that will mean D2 equals inner dia plus 20 mil. Or I can put the cursor at the start and then I can name this one. I can say, well, actually, this is outer dia. Outer dia equals inner dia plus 20 mil. And then there you go. So I've now got a little fx. That fx means that this circle or this dimension is being controlled by the formula, and this dimension is called outer dia, and it is inner diameter plus 20 mil. So its resulting value will be 60 mil. So okay, go back to dimension display, and then we can see the value 60 and 40. Alright, so we're going to finish that sketch, and we're going to zoom out a little bit, and we're then going to perform our first 3D command, right? The first one we're going to do is the most basic of 3D commands. It's the one that's the first one on the ribbon bar, and it's the one you're probably most commonly use more than anything else, and it's extrude. Extrude, lad. Extrude. So we're going to extrude, and then what it wants you to do is pick a profile. So you've got to select a section. So in this case, we've actually got 3. You might think 2, is there not 2? No, there's technically 3 different profiles here that we can extrude. We've got the inner one, we've got the outer profile, and then you've got the entire circle. So that would be this outer boundary here, which would be the entire circle. So we've got 1, 2, and then the overall one would be the third one. So it's asking you to pick which one do you want to extrude. So I'm going to pick the outer diameter, or the outer profile, and then it sort of finds that fill. Think of, if you're an AutoCAD user, think of like a hatch fill. So it looks for a water or an airtight area, and it goes, there's a sketch region which is closed. I can extrude that into a solid. So that's what it does. You can hold the left mouse button down on this arrow and just sort of conceptually move it around and say, what do I want it up? Maybe that big, is that a bit too big? You can sort of drag it down and it'll show the size here. So in some commands in Inventor, you can either use these little mini toolbars which pop up next to your cursor, or you can use a dialog box. Old school people like me prefer using a dialog box because that's what we, I was going to say grew up using, but that's what we learned to use. But if you want to get used to using these, you can minimize the dialog box by clicking that arrow, and you can carry on using these. But I'm going to stick the dialog boxes because personally, I don't like these. I don't like the little icons because you don't immediately know what they are. And sometimes in some commands there's more information in the dialog box than there is here. So I'm sticking to using dialog boxes. So I tend to ignore these. So for the extrusion, what we're going to do is we're going to give this a height of 40 mil. So that's what the extrusion size is going to be. And you can also name the parameter or the dimension within the extrusion. So we can say height equals 40 mil. Now the extrusion's going up from the sketch. You can go down from the sketch, or you can go mid-plane, so that'll go 20 mil either way. So in order to keep things symmetrical, again, I'd recommend, if it is going to be symmetrical, that you use the symmetric direction. So you go 20 mil and 20 mil either side of the sketch. Just makes things a little bit easier. And then click OK. Woohoo! Got our first solid. We got our first solid. Right. What's now happened is on the left-hand side, right, this here is your browser. So this is where it keeps track of everything you've done. So we've now got our extrusion, which is that thing we've just created using the profile. And then if you expand extrusion, you've got a sketch underneath it. And that is the sketch which we've just drew with the 2 circles. It is consumed by the extrusion. At any point, if you want, you can double-click the sketch and you can make a change to this. So if you make these circles bigger, so for example, if I was to double-click that dimension and make it 50, that outer one, because that's always 20 mil larger, turns into 70. If you finish the sketch, it'll then adaptively update any 3D features associated with the sketch. So it's kind of bread and butter. In the early days, that was like mind-blowing. When you went from AutoCAD to 3D, you're like, wow, that is amazing. But you kind of take it for granted now. It's sort of, it's expected behaviour, is probably what I would say it is nowadays. Right. So what we're now going to do is add additional features. I need to create these legs that are sticking out from the side. How the bloody hell do you do these? How the sudden hell do you even start with them? Right, well, it's not too bad. What we're going to do next is create a new sketch, and we're going to sketch on the XY plane. Now, because I did an extrusion both ways, our XY plane, the ground plane, is running exactly through the middle of the solid. So we can sketch on that. Alternative, if you want to be an absolute pro, you can press escape, because I'd already started a sketch, press escape. Create a work plane, so select plane here. These work planes are construction planes. You see that XY plane, the square? That's plane. what I'm doing by clicking this is creating a new plane, just like these XY planes, but I'm telling the inventor where to put it. So I'm going to say create a new plane, and I'm going to intersect. I'm going to make this plane intersecting between mid-plane, so a center line between that face and then that face. And then that puts a new plane parametrically placed between that face and that face there. Now you might be thinking, well, that's just totally counterproductive. Why would you create that plane there where you've literally just shown me that you've already got the XY plane there? Why would you do that? Why would you do that? Well, the reason I would do that is because this plane is parametric between that face and that face. So if I was, for whatever reason, to move this solid up, for example, if I was to bump the entire thing up by 50 mil, the XY plane would stay there. The XY plane never moves. However, that work plane would move with that move command. So anything that I create from now on associated, this plane would move with it. So this plane is attached and assigned to the model, whereas the planes here they're fixed, they're a constant. They don't move with the rest of the model. So kind of getting a bit ahead of myself there, I guess, but I don't know, maybe you do follow that, I don't know. I apologise, I don't know whether you will follow any of that. It's not important. It's not important. Right, so we've created that work plane. What we're then going to do is create a sketch on this work plane. So we're creating our sketch. We're not using the standard planes, but when you do create a sketch, you need a flat face to put the sketch on. Inventor needs a flat surface for you to sketch on. You can't sketch on circular faces, so you can't sketch on here, for example. You can't sketch on the inner face. I could sketch on that. I could sketch on the bottom face, and I can sketch on here. So we're going to create a sketch on that flat surface. Now, when I'm drawing lines, our sketch is running through the middle of the 3D model. So take that front of that cube, and that looks straight down. Now, because of that, whenever I draw some lines, the rest of the model is interfering with my view. If I draw lines through the solid, I can't see them because we're sketching through the middle. Not a problem, not a problem. I'm going to delete these lines away. What you can do is right click, and then you can select Slice Graphics or press F7 for short. And what that'll do is it'll use the sketch plane to cut away material. So it removes everything above the sketch just temporarily, and then you can see what you're doing better. And then when you finish the sketch, it just cancels it out. It doesn't remember that you ever did it. It's just a temporary view thing. It's like a slice, like a section view, temporary. It's up to you whether you use that or not. I find it quite useful. Anyway, right, so what we're then going to do is draw the outer profile of the leg. So we're going to draw a line, or right click, create line, or be a gangster, drag up, yeah. And then you're going to hover the cursor over the edge here. Now, if you've got the application options set the same as me, so we've got sketch, auto project edges during curve creation. It makes absolutely no sense, but that ticky box means that when you draw a line and you hover over an existing edge, it's going to automatically project that edge up and allow you to snap to it, because that edge that we're snapping to there is actually that one there, but it's not on this sketch. So what it's going to do is project that edge up. It's going to burn it, is a better way of putting it. It's going to burn that edge onto this sketch and allow us to snap to it. And it's adapted as well, so if that edge was to move, so if that face was to come over to here, the projected edge would move, and anything that's snapped onto that edge would move with it. So it's all adaptive, it's all associative, and it just makes things a lot easier if you do it that way. So we're going to draw a line, we're going to snap the edge, we're going to draw this approximately, so we're going to click here, we're going to draw a line down to about here. And here's another tip as well: if you hold the left mouse button down on the end point of a line, so you draw the first segment, hold the left mouse button down here, and then pull away in like an arc like this, it'll draw an arc tangent to that last line. So you see that little symbol just there? That means that this arc is tangent to that line segment. We're going to let go about here, so you get the little tracking vector come down, let go just as the tracking vector appears, and then pull away, keeping the tangent symbol there. So again, don't do this, don't snap here because you'll not get a tangent constraint there. Pull away, and then finish about here, snapping to that black line. Right click, and OK. So what that's given us is a lovely sketch which is all constrained up, almost constrained. We've got a tangent here, we've got a tangent here, and then we've snapped to this yellow line here and here. And that yellow line is, don't don't forget it is that edge there. It's that edge burned onto our sketch. So if this face was to move, that yellow line would move. Anything that's snapped onto the yellow line would move as well. So there's the associativity built in. It prevents your entire model from collapsing later on if you make any big changes to it. Right, the next thing we need to do is we need to make sure that this point here is in line with this center point. So we need that to be exactly in the middle here. Now you could, if you wanted to, create these are sketch constraints up here. So these sketch constraints allow you to create conditions in your sketches that are fixed. So you can say, right, this one here is a horizontal. So I can say make that dot horizontally aligned to that dot. And then it'll do that. And then when you grab this dot, it's now fixed or constrained horizontally to that dot. So we could have done that. I'm going to undo it though. What I'm going to do instead is I'm going to create a line, and then I'm going to click this button here, which makes this a construction line, and I'm going to snap to this dot and pull it along here. Right click and OK. And instead, what I'm going to do is just hold the left mouse button down on this dot and then just drag it so it snaps to that line. So now our center point here, the center point of this arc, is now constrained to the construction line. Why did I do that though? Why did I do that? Well, the reason I did that is because these two lines here, that one there and then that one there, I want these to be symmetrical. And the only way I can do that really is to have a center line. So we're then going to use the symmetrical constraint, which is this one here. So we're going to create a symmetric constraint between that line there. Right click and OK. And then that makes sure that these two lines are always symmetrical. So now that that's done, we can now put some dimensions on. So click the dimension button again, click this arc, and then we're going to make this, you could say, I don't know, I'm kind of over naming them. The whole point of naming them at the start was to show you that you could do it, but you can say, you know, rad equals 6 mil if you want to, or you can just type in 6 mil. 6 millimeters, and then we're going to create an angular dimension. Well, how an angular dimension? We've only got one dimension. Where's the angular dimension? No, you don't need to do no. You don't have to. No different dimension buttons. All you do is you pick the dimension button. There is just one, and then depending on what you click, depends on the type of dimension that it gives you. So I'm going to click that line there, and then it gives us an angular dimension, and then we'll just drop that down and say this is going to be 20 degrees.
Fuck, I'm so hungry.
So the only dimension that it needs now, in order for this to stop moving around, is the distance, the center point of this arc away from the center point of the part, so like the leg length. But I'm going to leave this. I'm going to leave the length of the leg free to move, and the reason for that will become apparent a bit later on. So we're going to finish that sketch, and we're going to do a second extrusion. And you might be thinking, why didn't you draw that? Why didn't you draw this in this sketch here and just have that leg poking off the end of there? Because if I'd done that, I would have had to extrude this leg up the same distance as this. You would have ended up with a leg like 40 mil high, and it wouldn't. One of the golden rules when you're doing inventor models is to keep your sketches as simple as possible. Look or think about what it is you're designing, and think about this as being different features and different manufacturable bits. So this body here needs its own sketch. This body here needs its own sketch. Try and think about it that way. Have a sketch per feature if you can. Don't put too much in your sketches. If you do start sketching something and it starts becoming an absolute cluster ball of a sketch, you've got loads of different squares and rectangles and all lines and dimensions all over the place. Try and think, can I break this down? Can I have a different sketch for this bit here and for this bit here? You know, it'll just make things a bit easier to manage in the future. So that's the reason why I didn't combine it. Right, so we're going to do another extrusion. So we're going to click extrude, we're going to click the leg, and it's defaulted to 40 mil because that was the last one we did, but we're going to change that to 12. We're going to go symmetric, and yeah, that looks about right. That looks about right. You'll notice how it's now almost welded to the side of this part because our line of our sketch stops there. So it's using this boundary here for the profile of the leg. And then we're going to click OK. And then there we go. Look at that. Looking mint. Turn this work plane off. This work plane's now done. We don't need this anymore, but it's just going to kind of hover there and linger like a bad smell. So we're just going to left click it so it's selected. If you want to select a work plane, you can't pick it in the middle of it. You've got to select the edges of it. Then right click on it and then just turn the visibility off by ticking that or unticking that Right, what next? What next? Well, the next thing we're going to do is we're going to create a pattern. So we need 5 more legs. Notice how there's in total 6 legs spaced around the outer diameter of this part. So we need to create 5 more of them. Are you going to draw it 5 more times? No, of course you're not. Of course you're not. We're going to do a circular pattern. We're going to start a pattern command. So this is like array in AutoCAD. Create a pattern, we're going to select the leg, and then we're going to pick this red arrow here, and then select the interface. That uses the inside center line of the part as the center line for the pattern. And then we'll want 6 legs in total. That's including the original. And instead of just saying 6, we're going to name this one. We're going to have no number of legs equals 6. So we're going to name this parameter. And then we're going to click OK. There you go. Now the reason I've named that parameter is going to become apparent later on. But for now, just roll with it, man. Just roll with it. Okay, next thing we're going to do is create some fillets. Now, normally, best practice is you do fillets at the very end of the model, or as late as you can at the end of the model. The reason I'm doing this now is because we're going to have some holes. We're going to drill some holes into the model, and I don't want the fillets to affect the holes. I don't want to fillet any hole edges and internal faces of holes. So we're going to start doing fillets. We're going to select the fillet button. And now the fillet command, again, I've done a video on this, a separate video on this, how to work with fillets, but you can pick edges. You can say I want to fillet that edge, and that edge. But what I'm going to do here is I'm just going to do a blanket fillet everything. So I'm going to select all fillets in all rounds, which is all concave and convex edges, and put a fillet on literally everything. And the radius, I'm going to say make it 1 mil. So we're going to have a 1 mil fillet on absolutely every edge in the model. And the reason just to reiterate, the reason why I'm doing that at this point is if I did have a hole here, if I tapped a hole through that leg, it would have filleted the edge of the hole and everything like that. So we're just going to click OK. And then look at that, man, look at that! So absolutely delicious. Isn't it? Crispy. Crispy. So we're nearly there. Right, what I would do at this point is save it. Right, save it and call this the carrier. And ready to crack on to the next bit. Right, the next thing we're going to do is we're going to use the hole command. So, yeah, so that's kind of why I'm doing this. The test drive's taking you through different features. So we've started with sketching, we've done a bit of constraints, a bit of dimensioning, we've done an extrude, we've done a pattern, and we're now moving on to holes. So we're kind of utilising most of the major Inventor 3D model creation tools that Inventor's got. Not all of them, obviously, it would take all day, and probably impossible to do something which incorporates every button, but most of the major ones. So we're going to do a hole, and there's a number of different ways you can create a hole. You can have predefined points, you can line it centrally to an edge, you can pick edges and say I want it so far away from some straight edges. We're going to use the concentric placement. And we're going to say we want our hole to be tapped on this leg here, on this face, and we want it to be aligned to the center point of this edge here. And that's called a concentric placement. So we're telling it what face we want the hole to be on, and we're going to align it to the center point of an existing circular edge, so it's concentric to that edge there, or concentric to that face as well. Okay. Next thing we're going to do is we're going to say I want a tapped hole. Yep. So we're going to select this one here, and then that loads up Inventor's database. It's got a big database behind it, a big spreadsheet full of industry standard threads, various different standards. Defaults to ANSI, but we're going to drop this down. We're going to select the ISO profile, and it then loads up the ISO threads, and it says, right, well, basically, what size do you want? And as you can probably tell, I'm just filling time here until it populates this dialog. Well, there you go. And then we're going to say we want a size 6, because I'm making this up, but I'm thinking that's probably big enough. Yeah, that's probably big enough. So we want size 6. We want a full thread depth, which means it's going to be tapped all the way through.
Recently, I did a video on
right-hand
Cadex
thread
walks around the
direction, and the hole itself
DRX, and my
goes through
thoughts
the
on this
entire
were, hey,
part. So
I do not recommend this product. And on related features, we always try to have the information for you to make the right decision. We don't want to miss words. We have no affiliation with any companies out there. It is purely for
That,
you
what
to
you're looking
get
at though,
flying.
that
It's
is
not about
not
having
an
the best gear,
actual
it is about
tactile,
having the best
that is
time and
just,
the best information to
it's
make the
supposed
most
to
out of
be, but
FPV
it
for
looks
you.
like a
So when
thread,
I
but
said,
it's just
hey,
a picture
do
of a
not
thread.
buy this product, I
If
do
you
not
want
recommend
an
it, there
actual
were some people
real
saying there's going to
thread,
be a bit of
go
backlash
on the
from Cadex, and I just want to make it
I'll
clear
show you.
they
Go on
did
the cool
respond. I got an
orange
email from
website.
them,
In fact,
and
I've done a
basically,
video for this
shout
video.
out to them. This
Look
was
on Rachel and
kind
look
of a
at the
nice,
cool
pleasant
orange
surprise
thread
where they
on
said, hey
the
Stu,
video
thanks for
already,
your
but it
video
does
talking
take
about the
threads
Voxnel
and it
Ascent
will
and all the issues that you
convert
had
them
with it.
into actual
They
real
agree that the
threads.
cables, they
But
definitely
it's
need to be
obviously
fixed, and in the
done
future they're going to be shipping some longer HDMI cables that are the correct ones. They talked about the mounting solutions. They showed me some early prototypes of putting it on their chest, some straps that they're developing and things like that. And overall, I thought, hey, I just want to make this video out there because I know in the past with distinction issues with Cadex and other influence and things making content, I've never experienced any of this. This is just my situation that I thought, hey, I'm going to give Cadex a thumbs up here. So even though I don't like their product, I still don't recommend it in its current form. They wrote me an email and they said, hey, we hear everything that you said with this, we're going to work on that. They talked about talking to engineers and reducing the fan volume, a whole bunch of things in there that hopefully in the future we can get a better system, and that's exactly how companies should take that feedback. Reviewers like myself should be able to say whatever they want about a product, because that's what makes the best video. That's what gives you the right information to get flying. So look, I just wanted to make this video out there to say, look, there's no hidden agendas behind the scenes. I don't hate Cadex. I could see some people in the comments saying, Stu, this is unfair. They did bring up some good points. I'm also not affiliated with Cadex, but shout out to them. They took everything on board to say, oh yeah, I understand what you're saying. We're going to work towards that in the future. Now, I must say about this, I think maybe as an FPV pilot, we are not who this is designed for. A lot of people spoke about using this on their crawler systems or hooking it up to a TV, where if you are using a full-size HDMI cable and you're hooking it up to a monitor, that makes a lot more sense. This, though, still has a lot of issues if you're trying to hook it up to your Voxnel Goggle X and everything in its current situation. So everything I said in my original video, I still stand by as an FPV pilot who wants to hook it into my goggles. Something I didn't really think about though, was people are going to use FPV for different reasons, like crawlers or hooking it up to the TV monitor and flying around, things like that. That might be a different use case scenario. Anyway, I just wanted to make this video to put that out there to shed some light on my experiences and say, hey, Cadex, I do really appreciate you taking that feedback on constructively so you can make a better product for the community. So anyway, let's hopefully we can get across the line and fix some of those issues, because the better this is, the better options we are all going to have the better options we are all going to have in choosing a cheap digital system.
Yeah, we could sketch on the X airplane instead. What I'm going to do is going to create a work plane though, and we're going to create a work plane intersecting that face there.
It's hard to say whether.
And that creates a work plane which is exactly the same as the X airplane. It's in the same place, but it's not.
Just like
that. It is. It's in the same place, but this work plane is linked to the leg. And
That's
the whole point of
bonkers.
that
I
is if
can't
the leg
do that.
moves, it will rotate the leg around somewhere else in this work plane.
This is the sound of me questioning everything that I think I know. There are a lot of exciting things about the new HD0 goggles, but one of the most exciting things about them, if you are a user of HD0, is the new 90 frame per second nano camera from HD0. And my first thought when I heard about this camera was 90 frame per second, big freaking deal. DJI will do 120 frames per second. Voxnel will do 100 frames per second. High frame rate FPV is not anything new or revolutionary. But HD0 has something unique that no other FPV system has done before. And that is that it can offer a low latency, high frame rate experience. And those two things together might just make a big freaking difference. In fact, I know for a fact that they do make a big freaking difference, because this is the second time I've recorded this video. I'm Joshua Bardwell, and you're going to learn something today. Jesus, it is windy. It is a beautiful day. It is literally, it's 60 degrees here, Fahrenheit, obviously. 60 degrees here, the middle of January, and it feels like it's the beginning of March, because that's when the wind gets like this. I don't know why I'm shouting. I'm wearing a mic. I don't need to shout. My God. It's going to be cold next week, I'm sure, but right now, by God, it's such a beautiful day. I gotta fly. Right? The Stu90 FPS camera can operate in a couple of different modes, and we're going to demonstrate that. We're going to put the throttle at 50%, and then we're going to push all the way to the right, y'all, right? And that's going to put us into the camera control menu. We can can then use the right stick to go down to the video mode. There's a lot of other camera options here as well, but we're not going to be tweaking those just yet. And we can see that we are in 960 by 720 at 60 FPS modes. The other modes we could be in include 540p 60.
Okay, we're going to put some dimensions on this rectangle, so we're going to say this edge here is going to be
540-90. That is the mode that I'm most interested in trying today. But for now, let's just stay at 960 by 720 60. This is the standard HD0 experience. Let's give this camera a fly to see how it performs, and then we will try the other stuff. The video transmitter I'm using is the HD0 1-watt Freestyle VTX. Of course, it is at max power, and I have got a TBS Triumph antenna on it. Oldie but goodie. Brand new and in good condition. Just found it in a drawer. The goggles, as you can see, have the True RC X-Air combo on front of them, and I have got my patch antennas facing the house.
So it would be very difficult to sketch that without a slice on it.
So,
right
actually,
click
like,
on that word plane, turn it off.
the worst possible combination in terms of range and penetration,
Separate
which,
command here. Separate command is like extrude.
just sitting that way because that's where I wanted to set up my camera because of the lighting. We're just going to make the best of it. So when I go through here, this is like the worst possible way it could be.
I've never understood why the axis
But it did okay. I'm pretty close to that location. Whereas when I fly here,
so it won't
I'm going to
find the
get
center line with a circular face. You've got to pick an axis, and in our case, we're going to pick the z-axis because that just happens to go through the middle. But this thing just happens to go through. It doesn't happen to go through. We've modelled to best practice, right? You're being a Krispy Kreme legit bro here. You're doing things to best practice. And our z-axis is the center line of our pod because we model things symmetrically around the center point. So the axis is going to be the z-axis. Click that, and then you're going to get this sort of submarine thing going on here. That will create material, right? When you do a revolve and you see a green preview, that will create material. So it'll create a ring around the pod. We don't want to create material. We want to cut material. So we're going to select this second button here, and that wherever our profile spins around that center line, wherever it touches something else, it's going to cut. And then that's exactly the look we're going for here. Click OK, and then look at that. That is just juicy as dog's balls. It's looking lovely. Right, another thing you can do if you want to be, this is not important, it's not important, but it's a test drive, so it's useful to put these tips out there. On this finished Courier, you'll see the bottom faces here are shiny, right? Because it's kind of a machined feature, so you get like a shiny finish on it.
你知道吗？很多人来基隆吃东西，第一句话都是怎么这么便宜呀？但奇怪的是，基隆人自己从来不这样觉得。为什么？因为这座港口城市食物从来不是精致料理，而是码头工人的燃料，要够大，要够饱，要撑得住一天的海风与体力。久而久之，留下来的店全部通过了一场100年的生存筛选。今天我们要找的就是那些我们还没吃过、被留下来的遗珠，从警察蹲点也要吃的包子，一路吃到元宵最暖的一碗甜汤。而这场碳水与热量的挑战，就从这颗巨大的润饼开始。
润饼，它有得过500碗的一碗。你看它这么大一个，这家店呢，它主打卖的就是一些特殊的口味，像我们今天点的是虾松，这个口味是蛮受到大家欢迎的。
这个是我有史以来看过最大颗润饼。
我等一下不知道怎么入口，有那种吃汉堡的感觉。
这个我存在名单很久，因为之前就是也是被它的分量给吓到。我来试试看，它的皮看起来也很好吃。
它整个吃起来很清爽，有微微的鲜香，这个很适合夏天吃，因为今天天气呢变天了，比较冷一点点，吃起来没有那么疗愈的感觉。
我觉得这个超划算，因为它真的好大一个哦。
哎，我觉得这个下午茶我可以一个人把它吃完，
而且这个蔬菜量我觉得够一天的。
这虾松里面呢，你吃到脆脆的东西呢，比较是煎饼果子里面的薄脆，而不是我们一般吃到的油条。 那很多餐厅的虾松啊，其实也会用油条。那我觉得这样子很棒，因为它吃起来呢不会有油腻的味道。
我觉得它虾松蛮 Q 弹的，那个口味很棒。如果你单吃它的虾松，也是好吃的哦。
我们今天蛮幸运的，一来就买到了，没有排到队。如果你去翻一下评论呢，里面所有那种1颗星啊、2颗星啊，都是排队排到神奇的。
我跟你讲，它这个其实吃起来完全不传统，就像是润饼包着虾松在里面，
完全就是虾松。
不过我觉得我很想要试试看它纯素，因为这真的也很好吃哦。这我经过一定会吃。
如果你来看到有排队的话呢，就是直接拿号码牌，不要问老板。然后呢，你来也要乖乖在队伍里面等，也不可以离开队伍哦。
不过我今天来他只有一个人，然后我们没排到队的时候，老板就是也很好啊。
对，我觉得有时候就是忙起来啊，讲话的口气就会不太好，那大家互相体谅一下。
这是评论里面我们没遇到。
最后再多说提醒大家2句，最好要现吃，因为生菜比较容易出水，它如果湿掉了，那个饼皮就会比较没那么好吃。那这个饼皮呢，吃起来真的是超 Q 的，很棒。
我刚刚看到一个客人啊，然后他带了朋友来，然后说来到基隆就是吃这样，然后他那个老板啊跟他上一个客人讲说啊，这个回去会变大，因为他吸的水会越来越大颗，这样叫他赶快吃。
西发码头手工肉包，我们一路过来，这家本来呢不在我们的名单上面，结果我们看到，蛮多人特地下车跑下来买，就连警察都来蹲点。以我们的经验来说，有警察蹲点的店呢，都是厉害的店。这家的菜单没有什么好选择困难的，就是酸菜腊肉包、肉包跟馒头3种而已。那今天呢来的比较晚，它的馒头已经没有了，不过馒头质地就跟肉包的质地是一样的，
所以你可以吃到馒头的那个味道。不过我好像印象中有人说，吃起来还是不一样。
哦，真的吗？好，我们来试试。
我跟你讲，这一幕我在梦中梦过。
什么东西？
这一句话我也在梦中梦过。应该很好吃，所以我才会梦到。你现在吃的小颗的是肉包还是酸菜？
酸菜腊肉包。哇，我先咬小口就可以享受到馒头的感觉，是那种鲜奶馒头，非常的 Q， 奶香很浓郁。再咬里面一点呢，哇，就熟悉的味道来了，就是我们放在那种米粉汤、什么鱼丸米粉里面的辣
猪肠汤里面的那种辣萝卜、大高丽菜的味道。我跟它很大一口咬下去啊，它那个酸香气啊，直接冲到我嘴巴里面，好爽。
是很顺口，但是我觉得辣度是稍微有一点点高，可以配一点饮料。
爱吃辣的一定超爱的。
这个主角呢，还是以它的酸菜为主啊，非常的酸，非常的辣。那里面的肉呢，虽然说咬下去比较没有存在感，可是它那个肉香啊，还是很完整的包覆在里面，给你带点一点油润的感觉。
我觉得有经过很值得，也是因为我第一次吃到这种口味的肉包，很好吃，我自己很喜欢啊。
肉包的个头比较大，咬下去呢，哇，它非常的咸香，可是通常很多咸香的包子会带点油腻，它完全没有，清爽。
我跟你讲，咸香鲜甜，它里面带一种甜，然后我跟你讲，它里面葱也很甜，好好吃，好好吃，我讲得好好吃。
我觉得比较特别的是啊，它不是一般绞肉或者肉块在里面，它比较是那种碎肉，然后你可以吃到油香啊化在里面的感觉。
这是一颗非常鲜甜的肉包，它从皮到内馅都非常鲜甜。我给它4个字，非常喜欢。
这一家呢是西发码头炸鸡。说真的，刚刚在讲这些名字的时候，都觉得蛮想笑的。其实我第一次来的时候，就是一直笑个不停。然后后来才知道说，哦，因为这边都是码头，然后它仓库不同，它这边刚好就是编号是叫做西发，不是在骂人。
我们上次来这边吃5层猪肠汤的时候，然后很多观众也是在讲说，对，大家懂的。
我们很久之前来这边吃东西的时候，观众就有跟我们推这一间炸鸡。那果不其然呢，我们来买了之后呢，后面都排起来了。
来试试看吧。我跟你讲，在点这个的时候，真的也是会有选择困难。然后 评论都每一样都会有人说好吃，有人说不好吃什么之
说
类的。
真的啊，看它的腿排啊什么都蛮大一只的，你吃了这个那个就又吃不下。后来我选了咸酥鸡，一来是我觉得拍摄的时候比较好入口，再来是它刚炸起来的时候呢，表面油亮油亮的，我看起来很像拔丝地瓜，你知道吗？
我觉得它在发光，所以我就觉得选择它。对对对对，我跟你讲，因为我们拍吃了久，你看到那个食物就会知道它好不好吃，这一看就知道好吃。
赶快放进嘴巴。我一咬下去，它肉汁喷出来，里面中药腌料的香味非常的明显，再加上它的胡椒粉呢也是有中药香的，很好吃。
我跟你讲，这个不得了了！你看我出镜就知道，真的不得了了。一般我们吃那个炸鸡啊，就有2种粉，一种就是那种传统炸粉，那边一粒粒白白的那种，对不对？然后另外一种就是那种地瓜粉，这种就是那种什么粉，你知道吗？
市场炸鸡。
没错没错。然后我跟你讲啊，它厉害就是它很酥脆，很像我们炸鸡皮，对不对？可是它这个也是有凸出来一粒粒，可是它这种地瓜粉的质地，然后市场炸鸡鸡皮的那种凸出来的，你说它酥脆的那个角度啊，非常的多，咬下去超爽，好好吃哦，而且肉汁很多。你看我讲了嘛，它会长出一些脆脆的地方在固劲，这个是你不敢吃，但是我很爱的东西。
对，所以接下来这一趴还是给你吧。
它的粉非常的薄，我一看就知道好吃了啦。很好吃，很像那种烤鸡屁股的，它基本上可能没有沾粉，然后它炸的蛮干，可是里面的鸡屁股还是蛮湿润的，可以点的。但是我建议炸鸡多点一点，因为炸鸡真的超好吃的。
这一家的地瓜薯条呢，也是很多人推，大家是喜欢它的地瓜薯条，切的比较小条，因为现在外面呢要找到切成这样子的比较少了，大部分切的很大条。那我是觉得它的粉呢，裹得很薄，可以吃到粉的酥脆感，又不会存在感太多。
我觉得它最接近那种地瓜的原味，然后它像是那种，哇，你已经把地瓜滚到它非常刚好、很好入口的那个程度，然后之后咬下去那种鲜甜在里面，超棒。你帮我插那个地瓜起来。我跟你讲，它这一整间店啊，非常像我们台湾品牌一个很有名的炸鸡，顶呱呱。
哦，
有没有？连炸鸡什么都很类似。
我太久没吃了，已经没有印象。
但我觉得不输顶呱呱，顶呱呱加强版在那边。
汕头牛肉店，我们刚从西巴码头那边一路过来，这边叫做流浪头，其实都是属于西码头的一部分。它这边呢，其实都是围绕着码头生活为主。因为早期这边呢，聚集了很多码头工人，所以这边的饮食呢，其实都是依他们的这个需求去作为考量。像这边的沙茶牛肉啊，不是我们一般认知的沙茶牛肉，其实多了一味叫做南洋咖喱粉，因为这个东西加下去之后呢，就会非常的开胃。他们在早上的时候就能够吃的特别多，能够积蓄更多的体力。这条街呢，它其实有一个称号叫做沙茶牛肉一条街。那这一间店就是当初呢这边的第一家，慢慢的才演变成有3家、4家，所以也打出了这个名号沙茶牛肉一条街。
我们来吃吃看，我已经迫不及待了。
首先我们来吃这个是基隆的特色之一，叫做咖喱炒面。那因为秋天都不能吃牛肉，所以我们今天点的呢就是羊肉跟猪肉，这个是羊肉炒面。
这个面啊，我们都印象中就是它有点像乌龙面的粗度，但吃起来又更 Q 了一点。
哇，这个咖喱啊非常的香，一入口呢全部都是辛香料的味道。那它的咸度呢，我觉得是没有那么的高的。那酱料啊非常的浓稠扒在上面，可是吃下去又不会腻口。再来是吃一口它的羊肉的时候呢，非常的 Q， 有够新鲜好吃。
这有点颠覆我的想象，因为我觉得看到这个酱色啊，你会觉得它应该是蛮咸的，结果它的那个香气大于它的咸度很多很多。
我觉得它面条的口感也处理的非常的好，就像你刚刚讲的一样，它的粗度呢就跟乌龙面很像，可是咬下去呢，它比乌龙面还要扎实非常的多。
对，所以它应该不算是乌龙面，我觉得蛮特别，没有吃过的一定要试试看，真的好香哦。你给大家看一下，这一盘是小盘的，因为我们刚刚已经各装了一碗了，你看还是这么大盘。那因为这一间是 我们刚刚在路上碰到观众，然后他推荐给我们，他说这一间一定要先来吃，因为创始嘛。然后你先吃一吃，你再去比较别家，你就可以知道你自己最喜欢哪一间了。虽然说他最喜欢这一间了。
因为我觉得他讲的很有道理，所以我就偷偷跟他讲说，你以后多来跟我们留言，推荐我们其他的东西。
对，但我现在要讲的是，它非常的大盘，因为他说，其实码头这边的东西通常都要很大盘，它才算得上是码头这附近的经典美食。对，因为以前码头认为他们吃东西，他们是要大分量，所以你没有。
The metal edge being sort of sliced out or machined out. So if you want that effect, what you can do is go to the revolver feature in the browser here. The browser all along, you don't need
But now we're back to default UK, wet, windy, cold. So we're back to some indoor toys. And this is the first of 2 videos I'm doing at the moment in the workshop. Right, you've probably seen these before. I've done 2 videos of these. However, there's some new bodies, and one in particular I think is going to be awesome. And then this I've been holding on to for a while, waiting for a rainy day. This is a 1/28 scale, this is a 1/43 scale. Hopefully both are going to be fun indoor RC cars. So the first release of these was a little while ago now, and they were like $20. Then they changed them and they put a gyro on them, it made them quite a bit better. And the price went up a little bit, I think it was like $35 or something. And now they're $45. Still a decent price. Getting a little bit close to maybe too much for what they are. Is that a Yaris? I think it is. That's the GR Yaris, isn't it? Ooh, fancy. I missed my one, although it didn't look like that. But that is not the one that I'm really interested in. Is it this one? Nope, not this one either. That looks like a Volkswagen Golf. Again, nice. But not the one I'm looking for, which must mean it's this one. There's actually 4 new bodies. 4th one was delayed. And it's the Toyota, the AE86. Oh, there it is. Not that. It's definitely the coolest looking one. Look at that. That looks so good. So yeah, the A86 is the missing one, which is a shame because that is an iconic car, isn't it? There it is there. Anyway, these are cheap 1/43 scale, 4-wheel drive, fully proportional, like drift cars. Now I say drift cars because they come with these plastic tyres, but they do come in the box with rubber ones as well. So we'll give it a burn round on a track as well as sliding it around. I'm not sure that's the scale because these Porsches, that is, Porsche 964, or it might actually be a classic one. I can't tell with a big spoiler up. So in the box you get some instructions, common issues and maintenance tips for use. I don't remember that being in the original one. Transmitter with speed selection and gyro adjustability. Fully proportional, so you've got steering trim and you've got throttle. You get a set of cones. Oh, I've got loads of these. And then there's your tyre. Why have I got 5? Oh, and a USB charger. 5 tyres. So the Porsche is the only one that's got wider wheels at the back to the front. The rest have got all the same. Now, I thought you got a screwdriver in here to take the body off. So the body's pretty easy to get off. There's 2 screws underneath, one at the back, one at the front. Not that there's much to see under it. So there you go. You've got your circuitry there, little tiny micro servo there, 3-wire. Got some little lights up the front there. So that's it really. Not much to see. No suspension. But these are for, like I say, indoors on a slippery floor or some light carpet. Actually, when you line them up like that, they're the same chassis. They've just got little extensions there for the body. I think I saw on the website you can buy the body separate now, and you can buy the tyres separate. Let's charge you up. We'll charge it on here. It charges much quicker. There, so you have a red light when it's charging. Right, I need to tidy the workshop and build a track. Go. Ta-da! Just a little basic track, goes round, and then I've put this bit in, this loop, so I can show you it coming off the carpet, and then we'll do a long slide around here. I've put a big corner, even though it's a small car, because as you'll see, it takes quite a long drift. The same with this track, I've made the corners a little bit bigger than scale for the size of the car, because it does, it's four-wheel drive and the steering's not all that great, so you have to do a long slide. But I think you're going to be pretty impressed when you see this driving round. I've had a quick go to make sure the track was suitable. I might have got a little bit carried away with it and ran the battery all the way down, so I've recharged it and now I'm going to show you how cool it is. Right, gyro set to about 55%. I'll get some close shots in a minute for you, but just watch how this thing just slides around. This is obviously a little bit of practice. It's so good. So good. I know. Drift King. Drift King. I love it. It looks so good. The Porsche looks so good. Yeet. Let's go the other way. Whoa. I've not been this way yet. Oh yeah, just as good, just as good. Bit of fast pass there. Let's go back that way, that's quite cool actually. Nice little slide around there. Yes, whoa. So controllable, look. Round the unicorn. Nice and easy. So controllable, so controllable. Love it. And if you've got more than one, switch that one off. Use the same controller, just switch it off. Then switch the car on. Then switch the transmitter on. And you can use the same transmitter for all your cars. Now this one, to me, feels a little bit more twitchy. You can still slide it, as you can see, but I think the slightly thinner wheels, the slightly shorter body, it's probably a bit lighter. It's, well, I mean, you can see it still slides. Just feels just a little bit more twitchy. It's so much fun drifting. Right, I've got the Yaris now. I've put the rubber tyres on. Pretty simple to put them on. You just pop the plastic ones off gently with your fingers, throw the rubber ones on, and it's good to go. Now what you're going to notice with this straight away is how much quicker it is because we've got grip. I've got the gyro set at 50% again, because the less gyro you have when it's got the rubber tyres on, the more turning you get. And I'm going to show you, if I turn the gyro all the way off, it's really hot. Look, it just, it's got such a small turning circle, like such a steep steering angle, look. So tight that it's, well, it's impossible really to get around the track with no gyro. It just spins out really easy. And grip rolls, so 50%, and now it's much more manageable. It's hopping a little bit, so it has got a bit too much grip on that carpet, but now it's pretty rapid. And it's a whole different experience to the drift tyres. But as you can see, you can still slide it on a concrete floor, still slippery enough to get that back end round. I forgot how fun these things were. I don't know if they made any other improvements to it. I mean, it feels a little bit easier to drive actually than the last lot, but that might just be because I've not driven them for a while, but so fast. That's the fastest speed. Click down once on there, medium, click again, and then slow. So this is the slow speed, perfect if you've got kids or if you want to get used to the handling. I mean, actually, it's quite a nice smooth drive like that. Should we have a look at this one? So I've had this a little while, and on the side of the box it says unlock more styles. Well, they're not question marks anymore because they've already released all 3 of the new ones, and they look very
Nice. Very nice. Uh-oh.
Anthony Greco, thanks for a $10 super chat. I'm trying to figure out how to set up GPS on a Diatone Roma F5V2. Betaflight appears set up when I go fly. I'm never getting any sats. Any advice, video tutorials I could look into? So Anthony Greco, let's assume that you are starting from scratch and you are setting up the GPS. In other words, that the quad didn't come with GPS pre-configured. The very first thing that you want to do is, hello, Betaflight. Come on, baby. Come on, Betaflight. There we go. The very first thing you want to do is go into the Ports tab, and you want to enable GPS on whatever port that you connected your GPS TX and RX wires to. And then you should say auto baud here, okay? Don't set the baud rate manually, you don't need to do that. I mean, if you know for a fact what baud rate your GPS is expecting, manually setting the baud rate will slightly increase the boot time, but you can just set auto baud, it's fine. And if it's not working, set auto, because that's gonna help it. Hey, I said auto. Hey, what are you doing? I said auto. Ooh, trying to be clever. Then we're going to go to the configuration tab. And in the configuration tab, we want to enable GPS. Hold on, let me zoom in on this a little bit. We're going to enable GPS. And then what we want to do is set the uBlocks protocol, auto baud, and auto config. Okay? And then save. Alright? Now when you do that, you should see in the upper part of the screen that GPS turns yellow. Now mine doesn't turn yellow because this is just a flight controller. It doesn't have a GPS, it's just literally sitting here on my desk for demonstration purposes. At that point, GPS should turn yellow. If GPS icon does not turn yellow, then the flight controller is not talking to the GPS unit and you cannot proceed. Okay? You have to have the GPS icon yellow. Now, once you have the GPS icon turn yellow, the next challenge is getting the GPS to lock satellites. And this can be a problem because like the electrical interference from the flight controller from the video transmitter can make it very, very hard to lock satellites. Anthony Greco says it was plug and play, so it came connected and I maintained the defaults. So your GPS icon should be yellow, right? At that point, how do you get it to lock? The number one reason a GPS won't lock is that there's too much electrical noise. So you've got your quadcopter has a video transmitter, it's spewing RF emissions, it's got a receiver with telemetry transmissions, it's spewing out, even the processor on the flight controller can create high frequency noise that interferes with the GPS, okay? So how do you fix this? One way to fix this is to power up the GPS from USB. Now, if Diatone was smart, they already set it up this way. Plug in USB, don't plug in a battery, and see if the GPS lights up. And if it does, congratulations, that's your solution. If it doesn't, then you're going to want to move the GPS power to a pad that powers up from USB. So either if the GPS takes 5 volts, then the 5-volt pad that the receiver is using might output 5 volts from USB. Again, plug in USB, see if the receiver lights up. If it does, and if the GPS is already using 5 volts, move the GPS to the same 5-volt pad as the receiver. Or, if the GPS is using 3.3 volts, then almost certainly it will light up from USB. And some GPS can take between 3.3 and like 6 volts, in which case you might move the GPS from 5 volts to 3.3 volts. Regardless, you want to have the GPS power up from USB. And then what you do is, at the field, you plug USB into the flight controller, the GPS powers up, but the video transmitter doesn't, and then it may get locked a little faster. Now you don't want it to light up from a battery, because when you plug a battery in, the video transmitter is also broadcasting and it'll take forever to get locked. The other thing that you can look at is the VFly GPS Mate, which is a device that provides external power to GPS units. So what this is, it's a little battery, it's a VFly buzzer, and it's a little battery that you plug your GPS into, and it lets you power your GPS unit up separately without ever powering your quad up. And again, it helps it get locked faster. Okay? So those are some things. Those are some things to think about. This is the Flywheel Explorer. It is a 4-inch, long-range, long flight time, ultra lightweight quadcopter, and yet there's a GPS receiver on the back. Right there behind me on the wall, I don't know if you can quite see it.
然后那种宫廷里面你就放一堆桌椅什么的，老师手上还上课，觉得你不是贵族气氛就拉满，对不对？然后，我跟你讲这个这张是这样我短评过这张嘛，我有讲过这边的问题那我认为这张图整张这个背景没有办法让我能够一下子解读说它是学校哪个社团的，改给你看，整个我把背景用彩稿改掉，但我没有改很细一个大方向上能不能让你看得懂的？来，3、2、1，看一下，这我改的背景，看得懂吗？再看一次好，这样，你呢？这是一个评级的教室，非常的寒酸的教室，那这个服装看起来是有学院风的感觉，而且奇幻感是有的，对吗？所以呢，你配这种普通教室不可以的，你要配的是什么教室？这个学院以前是什么魔法的，什么宫廷之类的，后面呢直接转卖给人家当学校用。你要想的是这种做法，所以呢，你要这个做法，你要看到后面这边有那个一堆的桌椅，有没有？你可能要跟这边的鬼魂打斗嘛，所以然后后面还有那个放东西的置物柜，然后还有那种白板，还有一些贴的一些公告啊什么的，然后上面是一个宫廷的感觉，用宫廷改来的教室，用这种方式发想比较好。如果你单纯只是想从教室内容，有可能会比较延伸不出来。那这个我在改的时候呢，我有步骤给你，来看一下步骤。这个呢是整张打掉重画，看到吗？那如果你需要这个的透视呢，上面有留一个给你。一个黑黑的透视，有没有？这有留个给你，这是2点，拉一个2点透视，整个改掉。会看到我在这边立这个大的柱子，中间呢就放那个放窗，很多那种就是欧式宫廷它建筑大概结构就这样。然后那种宫廷里面你就放一堆桌椅什么的，老师手上台上课，觉得你不是贵族气氛就拉满，对不对？然后如果像原本这种就日本某个不知名小岛，整个岛人家已经移走了，人家已经就是整个荒废半片的那种小教室，是不是？改一下格局，改的再气派一点然后这边呢是把外面光打进来，原本的做法是这样的然后是我画了一些倒掉的那个桌椅去遮一遮桌椅，然后呢再来这边呢是做一些氛围的优化。其实你这个鬼魂那样飘，我觉得你的想法是不错的，这个因为想法有趣，但是你这个构图是撑不起来的。我们先叙事部分，我们先不要管它，我们先看画面能怎么理，能不能在理的在这个条件下再理的再好一点。我人物就基本上先不动我们就把背景尽量调整看看这边的话呢是照你原本那些滚飘的方向，我帮你补一点看看然后后面呢是稍微优化一下色彩效果你来回我们把透视线关掉，你来回对照一下，这样有没有比较顺一点？并不是说这样改完，那这样效果就达到最大值输出这张如果我们花时间去刻画，首先这个在刻完跟这个人物要画到同样的细节分量，大概还要再花个3-5个小时。对，就是变成我在帮你完稿然后，但是就算这样都刻完了，这张图的叙事还是不够强烈，就是因为它的动作就长这样，就是拿一个这样这个拿一个水枪在那喷那我知道那是除魔的，就是它也不惊险，也不恐怖，也不刺激，还有点悠哉然后动作呢是漂亮的，但是这个动作也没有撑起这个故事叙事，所以这张图在一开始其实我们讲就是立项上呢我觉得就没法讲所以后面就算你极力的撑起来，故事性还是最多我觉得撑满可能最多就80分，所以未来在练的时候呢，你可以更加强构图。那我先讲一下画技上的优点，我觉得你这边画的不错，这边的细节画的很不错，请继续保持下去。然后我在聊最后这个步骤的时候呢，我有你可以比较一下这2个步骤。这除了在完稿上之外呢，这2个步骤有一个蛮大差别，就是这个头发，这个飘的是不好看的你这个飘的就是这样的做法，不太优。你看一下我的话，我是把这个整个画面那个 差异拉大了啊，因为动作本身就不对称嘛，那你头发却来一个对称，那对我这个效果不好啊。那这样拉大一点，然后有些比较零碎、没有意义的挑动的把它去除掉，像这一抹没有帮上整体的嘛，就是感觉它这边卡着，像这个都没有真的这样整个很帅的整个整尾甩出去，它没有这个效果，所以我觉得那很可一样，你还是要有那种比较强烈利落的东西。那你可以比较这两个，看看头发好，然后看一下人物这个我调的小地方 ，OK。
很多人想要讲话才是他会
哦，好吵哦。
他们讲小时候才来吧，我觉得。
Cheap digital FPV is finally here, and now there are multiple systems fighting for that top spot. But which one is actually the best? Well, today we're putting two of the biggest contenders head to head. The Beta FPV P1 Air unit versus the Caddx Ascent Light system. This is the Walksnail Ascent Video Receiver Module, also known as VRX, and here we have the camera and video transmitter. Now, this VRX lets you connect to any goggles via an HDMI input. Don't let the word Walksnail confuse you. This is the Ascent video system and it is only compatible with Ascent systems. I believe the word Walksnail here is simply because the VRX works with the Walksnail goggles via HDMI. Now, this VRX comes in at a very reasonable $100, and the Ascent camera video transmitter combo just costs $35. So if you already own your own pair of goggles with HDMI input, switching to this system is going to be relatively cheap. Here's the Beta FPV VR04 HD goggles and the P1 camera system. Sadly, there's no VRX module yet, so you will be stuck with these goggles. They cost about $150, which is pretty good for a pair of digital goggles, and the camera and VTX themselves cost $38, making this overall an affordable price.
We have Ascent up first on the scale, right at 7 grams. Next will be the P1 Air unit, 7.44, pretty close.
Both of these systems are based off the same Artisan chipset, and here's what the companies claim for what they can do. Starting with Ascent, you can get 1080p by 60 frames per second, or 720 by 120 frames per second, which is supposed to give you really good latency. They claim you can get as low as 35, but you have to have compatible goggles to do that. The field of view is 147 degrees, which is alright, and then they say you can get 6 kilometers of range with the VRX versus their goggles, which is twice as much as with the goggles. Beta FPV, on the other hand, they just have 1080p by 60 frames per second, and that's it. And then they claim 60 seconds latency, which seems a lot more reasonable for this kind of system. You get a little wider field of view at 170 degrees, which is nice, and the stated range is simply 5 kilometers. The biggest difference to me seems to be that the Beta FPV P1 Air unit transmits 200 milliwatts to the goggles, while the Ascent Light VTX transmit only 100 milliwatts. If you're like me, you probably think Beta FPV definitely has the clear advantage over Ascent with double the transmission power, but Caddx has a couple tricks up their sleeves. The VRX module has a stated 2 watts output power to help extend range, which I'm not exactly sure how that works, but it also has the added benefit of being able to place custom antennas on it. So, which system will actually work best? There's only one way to find out, and that's through real-world testing.
But before we get to the real-world testing, I want to go over what my first impressions were on the goggles and VRX. Starting with the Beta FPV VR04 HD goggles, that's a mouthful. Anyway, I thought they looked pretty nice. They do feel a little light and cheap, but they are cheap, so that makes sense. I really like the antennas on here, that they're external and not just the internal ones. That should give us more range. But I don't like that there's no switching them out. It would have been nice to have more customization.
and then the power just plugs in right here, and you've got this little pouch just like DJI, except this one has switchable batteries, which is a super nice touch. Comes with two 2600 milliamp 18650s, which will give you 2 to 3 hours of runtime, which is great. You simply just plug them in here. Now that you have the batteries in, simply click and hold down. That turns it on, which will automatically turn on your screen. This P1 Air unit simply bolted right on top of the flight controller, and it plugs in, as you can see, with a normal 6-pin HD connector. All I had to do to get it into bind mode was plug in the battery and click the bind button once, and it put it in bind mode. I do wish the bind button was a little more accessible on the goggles, but you see this little hole here? You'll need like a paper clip or a small screwdriver, and you'll simply just do a short press, and it'll put the goggles into bind mode. And that's all it took. No updates, nothing. 20 to 30 minutes, and this system was ready to go. Now, I'm not gonna lie, setting up the Ascent VRX was quite the different story. So I got the Ascent VRX. I was super excited to try it out with my SkyZone goggles, and it turns out the connector that it's sent with is HDMI to HDMI, which is fine, but the SkyZones do not take HDMI, they take HDMI Mini. So I got this here, this adapter, went ahead, plugged it in to both of them, connected it, and I got a black screen, which was super disappointing. Now, at this point, I had no clue if it was the goggles, the VRX, or my connector that was causing the problem. So here's what I did. I grabbed the original connector, hooked it up to the VRX here, and then hooked it up to my TV, and hallelujah, I got a picture. That's when I realized it was my cheap cord from Amazon that was the issue. I went driving around everywhere, and it turns out Best Buy is a good place to buy high-quality HDMI to HDMI Mini cords. And this one, even though it's long and annoying, it works. I was beyond ecstatic. My system was finally going to work. But when I powered up the VRX and my quadcopter here, they didn't connect. Now the linking process is supposed to be very easy, and it's the exact same as Beta FPV. You hit the link button, you hit the link button after they're both powered on, and they should just link. And it turns out that the reason they weren't linking together is because they weren't both updated to the latest firmware, so I had to do that first before they would work. This was a bit of a process, but to be fair, the actual updating wasn't too difficult. The actual problem for me was finding their updating tool and the correct firmware. To make this way easier for anyone watching this video, I'll link everything you need to do down below in the description. As far as installing the Ascent BTX onto your flight controller, it wasn't too bad, except I don't like that it comes with this 4-wire connector, and it did come with a plug, but it's not going to plug into any normal HD flight controller. I don't know if it's possible for them just to do a 6-pin and then with 4 wires, but that would be so much better. I just ended up soldering straight onto the flight controller, which was a bit of an inconvenience. And for updating, you have another cord you have to worry about losing. This special cord here that plugs into the flight controller so your computer recognizes it and you can update it with their software. It would be way nicer if it was just a USB-C or something. So, to be completely honest, setting this up was a little bit of a headache. It wasn't too bad. Like, if I were to do it again, it would be really easy. So, like I said, I'm putting everything in the description. For anyone who wants to follow, it should make it much easier. To test the range and penetration of these systems, I'm here at this nature path. There's plenty of twists, turns, trees. It's going to be very difficult. I actually have an analog setup here, the Lion V. I'm going to be testing DJI O4, the Beta FPV P1, and the Ascent system as well. Starting off with the DJI O4 Air Unit and Goggles 3, which is the industry standard. It's known for having some of the best latency, video quality, and penetration. So I'll be using it as a benchmark for all the other systems. And I am running it at the max 700 milliwatts power. On the bottom right shows link quality, where it says 60 megabits per second. That'll go down as video link gets worse. And I'm really paying attention to the landmarks, like going through this little tunnel, the little log on the right, just so I can compare it when the other systems come through. So far, the video quality is still great, but our video link is starting to go down and we're dipping into the 40s. It really is impressive how well DJI does with penetration. Normally you have to fly line of sight with quadcopters, but DJI you can get away with some stuff. I'm starting to get pretty low here. Let's see when it starts stuttering, and that's when I'll need to turn around. The video quality has finally started to break up, and we're starting to stutter. Close save, and that's as far as I can go. Now to the opposite spectrum of things, analog, with the Hummingbird at 400 milliwatts. Earlier, I said I was going to use the Lion Bee, but it crashed and broke, so that's why we're using this one. And right away you can see the stark difference between video quality of DJI and analog, especially in a little tiny one. 5.8 gigahertz, analog is known for not having very good penetration, so I'm curious how far we'll make it. We're coming up on that little doggy station on the right and going through this tunnel. Definitely breaking up a bit more, but not too bad. I'm way less confident with this since the video feed's breaking up and I can't see too much. I don't want to hit any branches, so I'm going a bit slower. Pretty consistently breaking up now, but still going. As I come up on this section just a little further, there's a really small, skinny tree in the middle right there. I want you to remember that. I'm surprised this little guy is still going, even though it's not great. Here's that clump of thick trees. Those big trunks must be blocking the signal pretty good. Man, I can't see anything. Phew, I am surprised I recovered from that. Oh my gosh. And that's as far as analog will make it. Next up is a Scentlight with its stock stubby antennas at 100 milliwatts power. How far can we go? Right away, it takes me a little bit to get used to the extra latency because I can definitely feel it, but I am way more confident overall than analog just because I can see those branches so much better. Coming around this bend to the dogway station and through this tunnel-like thing, we are having no issues. Video quality is pretty good and we're breezing by. I will say for this type of flying with lots of obstacles, I do prefer it over analog. Okay, I'm coming up to that straightaway with that little tree right there. Analog just got a little further than this. We're doing okay. Passing these bigger trees now, and all of a sudden I started breaking up and it was jumping around, so I decided to turn back. It seems it hits that stopping point pretty quick, and it takes a little bit for that blurriness to go away while heading back. Last but not least, we have Beta FPV P1 Air Unit. It'll be running at the full 200 milliwatts transmission power. How will it do? My first impression for video quality is that it is pretty similar to Ascent. I can't say if one's better than the other quite yet. I will say I was really surprised analog basically made it as far as Ascent did. Again, the big difference being video quality. Analog is just super hard to see anything. Video quality isn't nearly as good, and that static just really makes it hard to fly. These cheap digital systems, on the other hand, have a little latency, but it's more tolerable in these kinds of situations. Okay, we're to that little straightaway, and that little skinny tree up there is close to where analog and Ascent both had to turn around. I'm curious if the P1 will stop dead like Ascent did. Going through the bigger trees, and we're past. Image quality is pretty bad, but we're still going. And P1 finally hit its turning point, a little further than Ascent and analog. But unsurprisingly, DJI did make it a little bit further up the trail. Here's a side-by-side of P1 and Ascent. They are very similar. P1 almost looked like it got a better picture up close, and Ascent got a better picture further away. I think P1 may have had a little better brightness as well, which I liked. Now for a final test to make sure we can say one system is better than the other. I'm starting in the same place that I tested the Caddx Protos for anyone who watched that video, and I'll simply follow this sidewalk as far as I can go. Eventually, it'll curve around all those trees and make it pretty difficult for both video systems. Right now, I'm on the Ascent, and again, 100 milliwatts VTX output power. While flying with the Ascent goggles and the Protos, I made it to about here, and I was going actually above the trees, and that's where I fell. This time, I'm going around the trees and staying low to test for penetration. And that right there shows that the Ascent VRX definitely works better than the Ascent goggles because it made it through pretty easy. Now, how far will it go until I have to turn around?
So guys, welcome to the channel, Mario Kart. Now,
Wow.
I've been eyeing up one of these for some time, and I have actually seen quite a few people do the conversion on them. And I quick YouTube search, and there's one that's been converted to brushless, but I couldn't find a video for it. I only saw the build video. RC Tanks and Trucks 24/7 done one with, I think it was Donkey Kong. He done one quite. Because a lot of screws means that nothing's going to break, and then we can actually get in and look what's in here. It actually looks like it's got a proper servo in there. Look, I'm pretty sure the conversion I've seen online, this is not proportional, whereas this has got an actual servo in there, which is a massive help because it means, I mean, this isn't a 3-wire, it's a 5-wire servo, but it means that we can just hopefully slot the servo. It's too big. The shaft is a little bit too big, and because of the shaft size, the pinions I had were no good. So I've set up. We've got the receiver over this side. Got a gyro. Squeeze. The signal always goes. But anyway, here we go. First run with brushless Mario. That's not bad. It's 29 kilometers an hour. That is not bad. He's only got a little brushless motor in him with a 2S. Reasonable speed for that plastic gearbox as well, but we can go 3S, but I'm not going 3S yet. I just want to have a bit of fun with him. Let's see if we can get 30 kilometers an hour, but that is more than double the box speed. And it's really good fun this fast. This is the ideal speed for him. You can see the gyro trying to hold on for dear life there. Still 29. Kilometers an hour. I'm impressed with that. I reckon we could get probably 40 with a 3S. Just worried about the gearbox in there. Anyway, let's have some fun with him. This is so much fun. It's not like silly fast, but it's enough. It's a bit slippery here today. There's a lot of frost on the ground, but still, I mean, it's got that open, it's got that diff on it, so it does handle really well. If it's had a locked diff on the back, it would be spinning all over the place. And obviously with that gyro, definitely helping it. I mean, look at that grip. And that's slippery there as well. That is so cool. Whoa. You can see when it's going flat out that it's all over the place with that gyro is trying to keep it straight. This thing's going to be crazy on 3S. At least some more tyres soon. Hey guys, little montage for you now. Cheers for watching. 29 kilometres an hour, over double the speed of the stock one. This thing's loads of fun. Look out for it running 3S. Cheers for watching. I'll see you next time.
Arms are 3.5 millimeters thick and approximately 7.5 millimeters wide. It's got two bottom plates, one for the nose and one for the tail. The rear bottom plate is 2 millimeters thick, and so is the front. And the top plate is also 2 millimeters thick. We're going to start off with my preferred flight style, which you can call kind of more racing leaning, but there is some freestyle maneuvers in there as well. And I am going to take off without waiting for the satellites. And now, each first battery that I took out, I noticed it took somewhere between 4 and 4.5 minutes to get satellites. And we'll cover the satellite portion here as we go in, although I don't demonstrate the GPS rescue. I'm depending upon the beta flight doing what it's supposed to do and that working normally, because obviously I don't fly far out. I'm a micro guy. But this one is surprisingly capable of all sorts of different flight styles and flight maneuvers. Because for a 3-incher, it can not only be used as a filming drone, if that's something that you like to do, because the props, as you can see, are out of view, as well as the ability to cut through wind. A lot of times with our Cinewhoops, our prop protected quads, they're more subject to wind and tolerances of that wind, and it causing your footage to not be as smooth as you might like if you like to do exploratory sort of flying or filming. Whereas this doesn't have that prop protection, it's going to cut through the wind much better than its counterparts that are prop protected. Also, at under 250 grams, I think a lot of people who are interested in that sort of category may, be interested in this one as well, because as I showed in the battery specifications with that 850 milliamp flat pack, you do get under the 250 grams. I'm also just using a single antenna. That's just kind of how I mounted the 04. Pulled DJI antennas out of my bag. It happened to be the single antenna, so I just went with it. And during this flight, we're going to see quite a few punch outs. As far as handling goes, I thought it handled pretty well. I thought it tracked pretty well. And I am flying at just about the highest camera angle that the camera mounting will allow in this flight. But I lower it for some slower flights, as well as the battery flight time testing that I did. So there'll be several segments to this. Also, I did start a second channel for just posting the flights. No narration, no desk review, no specs, just flights. And I have been asked a number of times to do something similar to that. So I thought it was probably time that I do it, although I probably should have done it years ago. For those of you that just don't need to hear anything I might have to say about it, you just want to see how it flies, there is flight audio.
3.0 volt. 3.0 volt. .8 volt. Yes. 0.8 volt.
Hello and welcome to the video. This is a quick
Hello guys and welcome back to my channel. Today I'm going to show you how to use the soft serial option in Betaflight in order to add 2 extra CPU based UART ports to your flight controller. Even though the soft serial option in Betaflight has been around for quite a while, I still think that you might find this video useful, since flight controllers with a limited number of UART ports, such as the AJRC Zeus 35 and pretty much every all-in-one toothpick style flight controller, are becoming very popular. In this video, I'm going to show you how to use the soft serial option in order to add a GPS unit to the AJRC Zeus 35, but you can use the same method in order to add other peripheral devices as well. First, let's start with the problem that the soft serial option is going to solve. On the Zeus 35, you can find only 2 UART ports. So for example, on this build, I'm using UART 1 for controlling the smart audio feature of the Rush Tiny 10 TX, and the TBS Crossfire Nano receiver is soldered to TX2 and RX2 pads. So both UART ports are occupied, and in case I want to add a GPS device, I'm facing an issue, which is the exact problem that the soft serial option is going to solve. The first step to configure a flight controller to use soft serial is to enable it. So under the configuration tab on Betaflight, head over to the other features section, enable the soft serial switch, and hit save and reboot. Now we need to determine which pads on the flight controller we can use. The best option in my opinion is to head over to the CLI tab on Betaflight, type resource, press enter, and here you can see the available list of resources and their mapped values. Since in order to get the GPS working, you will need to solder the RX and TX pads on the GPS, to TX and RX pads on the flight controller, and since the TX and RX pads on the flight controllers are already in use, I'm going to use motor signal number 5 and RX1 pads using the soft serial option. The GPS unit is going to be powered using 5 volts, so as you can see, it's soldered to the plus 5 volts and ground pads on the flight controller, And just as a reminder, the TX pad on the GPS needs to be soldered to the RX pad on the flight controller, and the RX pad on the GPS needs to be soldered to the TX pad on the flight controller. So the RX1 pad is going to be configured as a soft serial TX1, and the Moto Signal number 5 pad is going to be configured as a soft serial RX1. Now we will need to configure the new soft serial dual port. For that we'll need to head over to the CLI tab, type again resource and press enter, and we need to locate the Moto 5 and serial RX1 pads that we connected to the GPS. The resource value of Moto 5 is B03, and the resource value of serial RX1 is A10. First we need to free these two resources. For that I'm going to type resource Moto 5 and then none, press enter, resource serial RX1, again none, press enter, and now I'm going to map resource TX11, which is the first soft serial, to the previous value of serial RX1, so it's going to be mapped to A10. So the command is resource serial underscore TX11 A10, and the serial RX11 is going to be mapped to B03, which was the value of Moto 5. Now we need to press enter, save the settings, and now under the ports tab of Betaflight, we can see soft serial number 1. Now we can configure the GPS device. We need to enable the GPS switch on the configuration tab. I'm using a U-Blocks protocol. We can hit save and reboot. And as you can see, now the GPS is identified, and if you got everything right and the GPS is turned on, the GPS icon over here is going to be highlighted. You should note that you are limited to 2 soft serial ports. So for example, if I would like to configure another soft serial port, I will need, in a similar way like before, configure serial RX12 and serial RX12, save the settings, and as you can see, now another soft serial appeared on the ports tab. You should note that when using the soft serial option, the CPU load is going to increase, and as you can see, sometimes it gets to 100% since the gyro active frequency and the feed loop frequency are set to 8 kHz. So in case the CPU load gets to 100%, you should definitely change these values. So if I'm going to, for example, change it to 4.4, as you can see, now the CPU load is going to be decreased. And if I'm going to change it back to 8 and 8, as you can see, again, the CPU load is very high. But if I'm going to disable the soft serial option, as you can see, the CPU load has been decreased. So this is something that you should keep in mind. So overall, using the soft serial option is not very complicated, and it can be quite handy, especially when using these type of boards with limited amount of UART ports. And by the way, as I mentioned before, you are not limited only to GPS devices, and you can use it with pretty much every device that is compatible with the UART port. As always, I thank you for watching my video. I hope you enjoyed it and you find it useful. If you have any questions, feel free to ask them in the comment section down below. Don't forget to leave a thumbs up if you like this video, and consider subscribing to my channel and hitting the notifications bell if you're not already subscribed. See you in my next videos, and goodbye.
Going back in time here for just a minute. Yeah, I got a haircut. It's a different day. But I thought I need to make it especially clear in the flight video. When I narrate that, I'm specifically talking a lot about Express LRS receiver and FrSky receiver, and I talk about SPI. Well, technically they're both SPI because they're on the board. But I think if you like this quad, the only version you should look at getting is the Express LRS version. So I hope that you have got your Express LRS module, whether it's a Happy model for your jumper, or for your X-Lite, or your Namimo for a much larger box style corporate radio, because I think that's the only one that you should be getting. Otherwise, I think you should look to add your own receiver. Because we know FrSky SPI receivers don't have very good range, and this quad carries quite a bit of speed. It's obvious at this point this is the lightest of the 3.5 inch, so we can expect probably 2 things. Longer flight times, and possibly a durability issue. Well, durability is going to take some time to tell. We're going to have to get this in more people's hands and see what their experiences are, because in my particular case, I didn't suffer any damage. You've already seen the quad. You know I didn't suffer any damage. My crashes were all pretty minor. I didn't do true crash testing, as you may have seen on the channel a few times. But this flight is going to come in at over 6 minutes on that 720 milliamp battery. Now, I don't have a lot of experience flying that 720, so I'm not endorsing that. I need to get it on some different quads and kind of test it out to see how it responds to quads that are heavier and possibly require more power in order to power them. I'm thinking of a traditional 3-inch that has, say, a 1407 or 1408 motor, or even a 15 or 16 something motor. I need to get those heavy-duty powertrains on the battery before I have a good feeling about whether that battery can stand up to it. But in this particular case, I think it's pretty well matched for this quad. Like I said, 6 minutes flying like this in my backyard. I am not carrying the naked GoPro at this point, though. So, our weather data for today, actually cooler. This day was about 87 degrees, and we have winds that, well, at the beginning of this flight, I think the winds were less. I actually remember this flight because it was just 2 days ago. When I first started this particular flight, I would say, was probably around 7 miles an hour, but by the time I get down to the end, it's probably closer to 12 with some gusts above 15. So I see some flutter when I do those zero throttle maneuvers over the house, and I've got the nose down. I see that either the wind is impacting it, or we need a little bit more I-turn possibly on the pid tune. But, you know, I'm afraid to adjust that pid tune because I really enjoy how it felt in the air. Like I said in the intro, this does not fly or feel like the other 3.5 inchers. And I even kind of like the 3.5-inch class. I think it's a kind of versatile class in that you can do cruisy exploratory flight and good long flight times, or if you have the right sort of space and skill set, you can go out and just, you know, rip the skies up. But this one flew a lot like a much lighter, a much smaller quad. Now, there are props in view. Hopefully that was apparent to you the whole time. You have to decide whether props in view is something that you just can't handle or it doesn't bother you at all. If you just want a good flying quad, you don't care about the props in view, you know, that's a choice that you have to make. I myself don't mind props in view, but I think this is a little much for props in view, especially with the camera angle that I'm flying on this quad. So usually you just see the props in view a little bit lower. It's not so predominant. It usually, for my particular case, it doesn't come above that bottom lower level of the OSD. It usually comes right at that level. But, you know, here obviously you can see the props are much more predominant. And in this flight, we're going to do all sorts of the typical, you know, high-speed turns that I do, and the punches over the house. We go both ways, chimney side to broadside to chimney side. We do a couple straight up from that bush, kind of down there over in the corner of the house. And it was such a fun experience to fly. I was just really happy. Now, I will warn you, and I said it in the intro, hopefully you didn't miss it, there are two versions of this, the Express LRS, as well as FrSky, but that is SPI. And I would not get that if you're looking at doing the SPI. This quad is fast, it's larger, so you're going to need to be able to run it out further, I would think, in many cases. Maybe you find your backyard's the same space as mine, which I thought was a lot of fun. But if you get beyond my yard by too much, you're going to have issues probably with that SPI receiver. And I've been a huge advocate of Express LRS, and hopefully you've either got Express LRS equipment en route to you, or you've already got some that you can bind up to this. Finding an SPI Express LRS receiver is pretty easy. You just go into the Betaflight page, you go to the receiver tab, there is a bind button on the receiver tab that activates the bind command. You can also do it from CLI by typing bind_RX, and then you bind on your radio. Easy peasy, you don't have to flash the SPI receiver because it's Express LRS that's on the board. You just bind it up, and it'll work. It did for me. I'm flying it right here. But, you know, really interesting that they went so light. We've got, if you're into staying under that 250 gram weird number that we've kind of been thrown out in this hobby, you've got a lot of overhead. Can it fly with one of the heavier GoPros? Sure. But it's going to change how it flies. I'm flying it right here as you see it without any GoPro. So if you add, say, 30, 40, 50, 70 grams, it's going to change the flight characteristics, because that's probably, what is that, about half? If you get I think the new GoPro Hero 10 leaked, and I think it was coming in over 60 grams. So that's almost half of your all-up weight, or a third of your all-up weight. So it's going to affect the flight time and the flight performance. For me, I wouldn't put a naked GoPro on it unless I was out doing that exploratory cruising flight. And we will look at my cruising flight. It's actually, the flight I've chosen for that came as a storm was rolling in, and it was pretty interesting because you can actually see the ring of the storm cloud moving in on us. We won't watch that whole thing. That flight comes in at over 7.5 minutes. I think it's closer to 8 minutes. But we'll look at that, and I thought, again, that cloud coming in with that storm. I felt the wind right as my flight, my exploratory flight that you see next. I felt the wind picking up, and that is a telltale sign that that storm is imminent. It's going to start dropping raindrops on our head just any second, so I had to hightail it out of there. Okay, our flight is just about over. I'm going to hover it in and bring it in around the table so it's easy to reach for me. You can see our flight time, 6 minutes and 12 seconds. And we go back to the home screen, and we're going to see our battery voltage pop back up to over 3.52 volts per cell. Okay, here's my exploratory flight, and you can see that storm right out in front of us. I don't have any flight audio for this one. I was in such a hurry to get this flight in before those clouds got to me that I didn't get my camera out. So I apologize. You can hear me much more clear probably than you can over the bug noise you might be used to hearing or the mower noise that you might be used to hearing on the channel. But I'm just going to be cruising this out and around and getting some GoPro footage. And I thought that the cloud storm, as you can see it's kind of in the distance here, but we'll scoot forward in the flight. And later on, you'll be able to see that ring, that I don't know my weather terms, I don't know my cloud terms either, but that ring moves substantially closer to us just during the short period of this flight. Of course, if you've got the Express LRS version, you're going to have more range than you've got video. I think we can all kind of conclude that our VTXs now have to catch up. We have Control Link that can allow us to really stretch our quad legs and go places that we maybe didn't go before. I know Crossfire and Tracer and Ghost and those protocols have really good range as well. But at this point, Express LRS for me is the way to go because of the cost, the performance, the packet rate, all sorts of options to buy different sort of Express LRS equipment. Express LRS is pretty young and it's already performing very, very well. Can you imagine what Express LRS is going to do in say 6 months? Which it's pretty exciting to me. But if you come to the channel, you know that I'm pretty excited about Express LRS. I think it's going to really help, especially those of us that like micros and we've struggled with SPI receivers. Express LRS is going to fix that, and we can just wave goodbye to FrSky. And we can buy an FrSky radio. FrSky makes nice radios. For the longest time, I flew an X-Lite, and I've been contemplating giving the X-Lite another go. Because if I've got Express LRS, I don't necessarily need to fly any particular radio, just find the one that I like the most and fly it. But of course, there's a cost comparison. So if you're buying, I would still recommend if you're buying a radio today that you get a multi-protocol based radio, whether that's a Jumper or Radio Master, that's up to you. But those are the two main factors. You can add Express LRS modules to either one of the radios, regardless of the model of either one of those brands. Let's move forward and look at a little bit more of our cloud and our storm that's brewing in. As we circle around, you can see that ring. It's pretty cool. And you can see how much closer that storm is now just in this short period of time. I think I stayed at the time that was wrong for this flight. I went back and looked, and the flight comes in at over 8 minutes, and I'm flying it on a 650 milliamp battery. So it's pretty dang efficient. It's light. It's sporty. The only question I have is I probably need to give it more crashes. I need to see if we're going to break an arm. And I noticed that in their arm design, they went to kind of a triangle sort of design. Now, I'd heard, if you're not aware, Chris Rosser, he is an engineer, has started the YouTube channel, and one of the things that he had talked a lot about, or I've caught snippets of his, but he really talks about frame resonance and having these kind of triangle arms and really helping for that. One of the things I didn't cover during my flight, I kind of forgot, I just now referenced my notes again, is even though this is BLHeliS, they flashed this with ESC firmware that allows you to run RPM filtering. So that's part of the setup, the Betaflight configuration. Also, I probably mentioned it in the quick roll, but we have this OpenVTX, and the cool thing about that is there may be other cool things. I'm not really up to date on OpenVTX, but you don't have to go in and set the protocol for a particular version, whether that's Tramp or not Tramp or Smart Audio. This works with any of them. So you can just, this is from my reading, not from my experience. This is the only one I've experienced. You can select the Smart Audio version or protocol for any of them and it will work, whether it's Tramp or Smart Audio. And that's pretty cool. I think there'll be other developments. I can't imagine something being open and there not being more developments for the hardware. It's kind of one of the mantras of being open is future development is impending. You will have to look at the VTX performance in my flight, and I'll play the longer flight that I was out cruising around so you can see some of the analog data from the camera. There is an HD version of this one that, you know, it's listed with the Caddx Vista and the Nebula Nano. You know, it's going to have to be a nano camera because the plate, the width just isn't wide enough to get the Nebula Pro camera, which is the 19mm camera. So this has got the 14mm camera in it now, and if you got the Vista or DJI version, it would have the Nebula camera in it. Nebula Nano, excuse me. So you might get that if you want, you know, if you have a DJI radio and goggles, you don't have any other radio or goggles, then that might be the one you want to get. And, you know, it's going to change the weight too, even if you don't fly it with an HD camera mount on top. You know, the Vista is going to add, what is it, like 12 grams, maybe as much as 15 grams. So you wouldn't have the OpenVTX, and you wouldn't have the Caddx Ant, so you would just have the Vista and the Nebula Nano camera. So your weight, while some of these components would be removed to offset that, your weight does go up. Of course, that is also going to change the flight time and flight characteristics, but less than if you were to, you know, fly it with a stock, you know, new GoPro Hero 10 that might be coming out any day now. I've noticed on the frame, if you're looking at the frame because you're interested in it, that we do have other mount points. I mentioned in the quick roll how excessive this battery strap is. Let me show you that while we're looking here down at the bottom. I shouldn't have pulled that all the way to the buckle. Now that I've got the battery back in and I pull my strap over, and I'm going to get it somewhat taut here, and you can see that this is the part of the Velcro that actually sticks down. There's not much of it that gets started, or you've really got to do something with this tail. So what I tend to do, I just tend to tuck it and get this front part of the strap against it, and that's actually how I flew it. So this is all extra. Of course, you can fly with a bigger battery. I think I saw on the website that the biggest recommended battery is an 1100 milliamp 4S. So you may, if you choose to use that battery, need more of this strap. For me and my flights and the battery uses that I had, this was just, it was a bit excessive. But, you know, battery straps are so cheap. We get those with every order, it seems like. I've got, I don't know, I think I've thrown away a lot of battery straps over the, you just get one, like I said, with every order. I mentioned Chris Rosser and this triangle design arm. I think his are a little bit different, of course. Do note, let me take the battery back out, that that arm does not come back and connect to the body. It's just kind of braced with one another. So my presumption there is that if you hit an arm, that some of that force would be transferred to the rear arm. Hopefully it doesn't snap in here. Speaking of the frame, let's test the stiffness here. Okay, so I can get some flex. I'm giving it quite a bit of force there, but I am getting some flex. Of course, I've seen a number of frames with a lot more flex. Let's grab these other frames just while I'm here, if this is an important data point for you guys. Yeah, the Gepard C is thicker and stiffer. Let's go over to the Baby Hawk 2 HD. I think this one is going to be stiff too. Well, I would say this is actually about as flexible as the Crux 35, or maybe the Crux 35 might even be a touch stiffer than the Baby Hawk. And last but not least, the Avant Quads VO 3.5, and this one has replaceable arms. So if you're looking at this category and you want replaceable arms, this is the only one I'm aware of that does replaceable arms. You might be able to find just frames that are in the 3.5 inch prop category that have replaceable arms, but as far as a bind and fly or a ready to fly, this is the only one I'm aware of. You know, I think this one is stiffer than the Baby Hawk. The Aveo 3.5 is stiffer than the Baby Hawk, but it's too close to be able to tell the difference between the Crux 35 and the Aveo 3.5. So that's kind of where I see the stiffness at, to try to give you some information about that. I was a little bit concerned about this T antenna and how these wires can come down. You see how close it is? You know, again, I didn't have any problems, but there is potential, as you can see here, that if the wires somehow were to get down here and stay down here and the props were spinning, it could end up getting chopped. I think an easy fix, it's kind of a ugly fix, is to just take a part of a zip tie and just tape it on both ends, and that will stiffen these up a little bit and kind of ensure that they don't get down a prop line. I do get some questions about my Naked Hero and how I power it, because I have to transfer this from quad to quad all the time. I didn't like having this pigtail and having to find a voltage area to solder it to, so I just made this. I'm running the Beta FPV case and back. This is fairly old, so you know, mine's been working for me. I've read a lot of different reports about Beta FPV back for the Naked GoPro not working well for others, but of course, you know, you hear that about every product in some regards, because unpopular news always spreads a lot faster. But so I just made a pigtail to put between my flight battery and my quad connector, and that's how I power my Naked GoPro. It's just a simple XT30 soldered on both ends, and then I took some black hot glue and just kind of smothered it to make sure that my lead, after I of course got my battery lead for my Naked GoPro soldered on here, I just kind of smothered that, so it makes it easy, it makes it transferable, real easy for me. But that's what I do, and in this particular case, I routed it between the gap in the arms, and then I brought it up through this hole right here. That kept the wire out of the prop line. As far as price right now, what I see is that the analog version, which I have in front of us here, comes in at $142 on Banggood's website. Don't forget, I have a coupon code that you can use for anything on Banggood. It's BG Nick Burns. You get 8% off. It is limited to 10 uses per person. And there's another limit on there. I'll put the full details down in the video description. It's escaping me in the moment. If you choose to go with the HD version, I honestly don't know when that might ship. I don't know if they're shipping the Nano cameras and Vistas out right now. I just don't have information on that. So you might be able to get this right away, get this shipping if you do want the Vista version with the Nano camera. That price comes in at $269. So we have a $127 difference between the two, analog versus HD. So tell me what you think. Did it look like I was flying a 3.5 inch quad, or did it just look like another micro flying in my backyard? Did it look like a more traditional 3-incher maybe? Something a little bit more powerful and light? I'm really interested to know what you thought of the aggressive flight in the back. Sure, most quads can go out and cruise. Yeah, not a problem. This comes with a mount already on it, so if you buy one and you're worried about the mount, we have seen some of these quads come out and they didn't have mounts on them. This one does have that. You can go out and do the exploratory, get HD sort of footage on the quad. And what do you think of this arm design? I'm specifically wondering about this. This is something we haven't seen before, especially with this section on the back where it doesn't join in. You know, we've got these connectors down here for our motors. It's different, it's new, and it also makes me want to ask you what you think about it. I enjoyed it, but your purchase decision is based upon what you think. If you have any comments, questions, suggestions, or otherwise, please let me know in the section down below. I appreciate your time. And thanks for watching. Or for your... Hello everyone, today we're taking a look at the Darwin FPV Baby 8 3 Mini 2. This is a 2-inch prop, a 2S quad, and 2-inch 2S is one of my favorites. This is another analog quad from Darwin FPV, where their goal is budget-minded as well as not just the bind and fly, but also parts that you would need, be a little less expensive than you might find otherwise. The flight controller is the Darwin FPV F411. It's a 15 amp Express LRS equipped all-in-one flight controller, but as you can see there, I do have that 1 watt or 1.2 watt VTX for the analog system that I have here. On this one, they also inserted a bit of plastic down here that protects any dew or wetness that could potentially get onto the flight controller and short it out. But our USB port, our micro USB port, is right there. Motors are Darwin FPV branded. They are the Bling 1103 12,000 kV motors. And on those motors are Gemfan 2023 tri-bladed props. The camera is the Caddx Ant. It does have a capacitor, but I'm not quite able to read what that says, maybe through the viewfinder. It looks like maybe 270 microfarad capacitor. Not sure about that though. Our battery connection is an XT30. There are 2 battery pads that are mounted to the side plates, and your battery does need to fit in there, and I've got 3 options that I'll present in this video. But I do recommend go ahead and using a strap right through there if you have the space. While this is analog, it does come without an 04 or with the 04. It also comes with Walksnail Avatar. It weighs 64 3/4 grams. I flew it on these 3 different batteries. You can see here the Darwin FPV branded 500 milliamp US battery is a little bit different. It does not have a battery lead, which does make it pretty clean in this particular setup. With the Darwin FPV battery, it weighs 94.11 grams. With the Beta FPV 550, it weighs 94.16 grams. And with the G&V 550, it weighs 93.45 grams. Bottom carbon fiber plate is a little over 3 millimeters thick. Top plate looks like it's 1 millimeter thick. Side plates are 1.5 millimeters thick. Yeah, on both sides. Distance between the battery pads is 17.5 millimeters. If you take out the battery pads, you get about 20 millimeters. And motor post to motor post, I'm getting just about 97 millimeters. Comes with a Safe Flying Guidelines card in 2 languages and some promotional material about Darwin FPV. In the accessory bag comes with 2 little circular stickers. We have 3 extra rubber bands. We've got various screws that we'd use for motor mounting as well as mounting the carbon plates. And last but not least, it comes with 1 sheet of stickers. It only comes with 1 set of props, so pick up extras if you don't have more on hand already. I'm going to jump right into my more freestyle, typical sort of preferred flight style, but I can report if you fly more exploratory or flat sort of cruisy style, that on the stock battery, which is the Darwin FPV battery that does not have a balance lead, you get about 4 minutes and 15 seconds of flight time, just in that particular style. On the Lava 550, I got about 15 seconds on average across the several different Lava 550 batteries, but I only have the 1 Beta Darwin FPV battery to test, so there could be a variable there. And with the G&V, I got about the same as the Darwin FPV at 4 minutes and 15 seconds of exploratory flight. Of course, in this flight style where we're punching and hitting the throttle and we're weaving in and out and stuff, we're going to get less flight time, but it'll be apparent at the end of the video. You'll get to see the flight time that we have. Some of you may be wondering, yeah, the yard did get cleaned up, but we won't see that this year in a video yet. The yard just got cleaned up yesterday, and this was, well, as I recorded this yesterday, and this flight was a few days prior to that. It usually takes me a day after I've kind of satisfied my amount of flying that I like to do, especially weather permitting and light permitting. But I wanted to get this out before the end of the year, so I don't have flight footage from the clean yard, although I did fly this when the yard was clean. I just didn't have time to put flight footage together because I do have a secondary recording that I use for flight audio. And 2-inch 2S is always a lot of fun for me. I have for years enjoyed 2-inch 2S. It fits the backyard flight style. It's light, it's agile. You can still punch up and over stuff. You can still get a fair amount of float, as you can see from a lot of the typical moves that I do here, that it doesn't fall out of the sky like a rock like you might see in other quads that are smaller prop and just are lower weight. They still have a little bit of weight there to work with. Again, but the downside of going smaller and smaller and smaller is always the wind that it will tolerate. In this particular case, our winds are around 12 miles an hour, and you may be able to pick up some of those winds on my flight audio recording as it blows. The few leaves that are still on the trees around, as well as the leaves that are sitting all over the backyard. But like I said, they're not there anymore. Thankfully, it got cleaned up. You may have seen it in my thumbnail that the yard got cleaned up on a different video, actually, that I just released. So if you want to see that cleaner yard, look for the thumbnail. If I used that particular picture, I really can't remember. But it flies fine. I don't see any deficiency when it comes to the pin tune. 2-inch 2S usually is quite durable. I didn't have any breakages. I didn't really have anything to complain about other than battery strap. really needs to be in the box. You can see our flight did end 2 minutes and 36 seconds, but I could have gone a bit longer. I did not nail my ending voltage where I like to get 3.5 volts per cell, and it's popped up now at above 3.6 volts per cell. So the flight time, I probably could have gone another 10 to maybe even 12 seconds, depending upon what I might do. So Darwin FPV has kind of gone with this motif. We saw it on the last video that I had on Darwin FPV, the Baby Ape 3, where they have kind of reinforced arms, and that's good, especially when it comes to durability. So you have a little extra carbon fiber that protects the arms from getting hit, and then they snap off. They have a little bit of extra carbon fiber that will help make them more robust when it comes to taking impacts. Oddly enough, the foot pads, when you go to order, if you choose to order, I will link it down in the video description. The foot pads are extra. So maybe if you've got a printer and you have some design, you can just do that yourself, maybe. As in the last video, I think a cheap and easy and enjoyable upgrade is to change the camera. If you just want to fly this around for a time and then you want to go out and get a Caddx Baby Ratel 2, it should slide right in and be a direct replacement. This camera is also made by Caddx, so the pinout on the camera connector should be the same, so it should be a really easy swap. And that's a nice camera. I like that analog camera. That's one of my favorites. Especially when you go to 2-inch where you have, or larger props, you have a little bit more thrust, so you can add the additional weight. The ant is going to be about 1.5 grams is my recollection. It might be as much as 2 grams less than the Caddx Baby Ratel 2. But that Baby Ratel 2, if you're not familiar with it, it's a nice little camera. As I said, I recommend a strap, and I think Darwin FPV should include a strap. They didn't design it for a strap, obviously, because you have the carbon cutouts that are there to hook your rubber band. But I experienced on the Baby Ape 3 a battery ejection. I did not in this particular case, so it could be safe. I'm still, if you have a battery strap on hand, and if you get the version where you can thread your battery strap between the top plate where the battery goes and your VTX, I would go ahead and do that. It's going to add, again, a couple more grams, but I think it's worth it, especially in battery ejection scenarios. As far as the battery goes, let me take my rubber band off. Stock battery makes things real nice and clean, as I showed in the Baby Ape 3. I think we slide it in sideways so we get the label in, and we shove it up in here, and it fits real nice and neat, obviously designed for this battery and this print. And then with the battery lead length, we just plug it in, and it keeps our battery leads out of the way. Now, with other non-Darwin FPV batteries, we still have the option of using them, as I said and I reported in the flight time. Just like with that one, I kind of what I do with my balance lead is I put it between the 2 wires because it holds pretty well, and then I just kind of slide my battery up there as I can, and then we take our rubber band, I flew it. You can, in this case, I didn't do it exactly like I flew it. Let me take it apart, and I'll do it exactly like I flew it. So I thread the battery lead between the carbon fiber and the battery, and then I line things up, and we plug it in, and then we take our rubber band, and we just run it. Oh, I just broke it. So, for the purpose of this video, normally you would take the rubber band and just loop it across, and it holds everything nicely in place. In the case where you have the battery lead on opposite sides, I just kind of do this one on here. I do this a lot on a lot of different quads, but then we put it in here, we shove it as far forward as we can, and we do the same thing. We take our battery lead, we put it between the battery and, well, geez, there we go, I got it. And then we plug in, and with a non-broken rubber band, we run it across the top. That's how I flew it. I did fly it without a battery strap. I just recommend a battery strap, especially if you are a little bit like me, maybe risk averse. It is going to add a little bit of weight, so you will have a little bit less agility and performance, but it'll be pretty negligible on this particular prop size. As far as the construction goes, they use posts here and here to secure the 2 side plates, and you can get access to pretty much everything. Oh, there's also another post down here, I believe. No, that's not a post down there. But like I said, the posts are right here, just below the battery plate or the top plate, and then you would take the screws out, and then you can slide after you remove the camera screw. You remove a side plate, and then the other side should be free. You might have to remove your props in order to do that. I didn't need to get in there, but we've got a fair bit of clearance between the side plate and the props. If you kind of turn the props, I had that kind of high. You could then slide this out. You should be able to get it beyond anything that's connecting it down to the bottom plate, slide that off and then remove it so you can get direct access. When it comes to repairs, they are soldered motors, so you won't be able to use motor connectors, but they are kind of exposed. So with a needle nose or a tweezers and a fine tipped soldering iron, you will be able to make motor replacements probably without removing any of the screws in the plate. So the repairs should be relatively easy. In this particular print for the camera, you can see we've got two positions that are available to move the camera forward or back for more camera protection. On this particular mount, with the camera mounted in the forward position, you can see that the camera lens does stick out just a touch from the print. So anything we might hit directly in this area could damage the lens. You could move that back. I did not, but if you move that back, you might start to see edges of the canopy come into your view when you're in the goggles. So something to consider, but it's still nice that we do have an option. Myself, I would prefer an option where there was just one slide piece that you could scoot it, back and forth. The upside of having two definite pieces is your camera doesn't end up, cockeyed in there. Because you've just got the two holes rather than a slide cut out in the sides to where your camera might get a little bit, cockeyed one way or another. So that does clean things up, but it also limits how much movement you can get when it comes to adding some camera protection for your maybe new Caddx Baby Retail 2 if you were to put one in here. They did use my favorite motor wire tape to secure the motor wires down to the frame, so I obviously approve of that. Without the feet, if you go without the feet, do note you're going to be coming down on these screws, so if you tend to land in a sliding fashion, I tend to hover and then disarm and just kind of plop down, but some people come in kind of sliding. Maybe it's just a fun thing you like to do on a nice smooth parking lot or something, go sliding across it. If you don't have the feet, you're going to be sliding across all these screws, so after a few flights or every flight, I would look at those screws to make sure you haven't worn too much of the head off and that you can still get a good bite on the screwed head in order to unscrew those to make repairs. Otherwise, if they rub all the way down, that is a much more difficult time getting that screw out. So just something to keep in mind. Or just add some foam bits. If you have some foam bits, you can even buy those little rubber cabinet bumpers. I don't know how well they stick. I just know because past projects I've done, they have these little round cabinet bumpers. You could probably buy some of those from your local hardware store and put these either out on the arm or out here on the frame. Just raise things up just above the screws. I'm not vouching for how well they'll stay, but that is a kind of DIY solution if you don't have a printer and you don't want to buy the feet. I mentioned it in my Baby 8 video as far as the 1.2 watt VTX. I can't verify it's actually outputting that even though I was flying at that. Of course, you need to pay your local laws when it comes to that sort of thing and any sort of licensing you might need or anything like that. I don't have a tester to actually prove that that is actually outputting 1.2 watts and how long it might be outputting 1.2 watts. When things heat up, they tend to come back down in power level. But if you like to explore at more of a distance, in theory, that 1.2 watt should help you get to where you want to go for the most part. There's going to be limits to that are very, very much a big variable. Environmental for one, where, how, your antenna setup, things of that nature. But as far as price point goes, this analog version, pretty much like I have here without the feet, it's about $157. And then when you add the 04 Lite, as we've been calling it, it goes up to $278. So the price range really varies. But again, they have a listing for all the repair parts right there on the website. Matter of fact, I think you can buy extra parts at the same time you're buying the binder flight, save you a little bit on shipping if you want to pursue that. If you are interested in the Baby 8 III Mini 2, I will link it down in the video description and you can check it out, or you can just type in Baby 8 III Mini 2 into your favorite search engine and go find it from any vendor that you might be able to find it from and that you want to investigate further. And if you have any comments, questions, suggestions, or otherwise about the Baby 8 Mini 3 2, please let me know in the comment section below. I appreciate your time. And thanks for watching. This is probably my last video for 2025, and I just wanted to thank everybody who's come by the channel. And I know that not everybody will see this, but I don't really like the idea of just posting a video that's specifically saying, bye-bye 2025, happy 2026. I hope you all enjoy the holidays. So I thought I would just throw it in here, and those that maybe watch to the end of the video would see it. But I do appreciate everybody who comes by the channel. So hopefully 2026 is a more prosperous and enjoyable year for all of us in FPV and real life and in our work life and our family lives, all the other lives that we tend to live and experience. And I just wanted to thank everybody who's come by the channel, who's left a comment. Even if you haven't left a comment, I still appreciate everybody who comes by. I'm still surprised after all this time, more than 10 years now, that this old guy is still doing this stuff. My kids now are so grown, and they were little tiny kids when I first got started on YouTube. But it's been a fun experience, and I hope to be able to continue. And I wish you all the best now, today, as well as in the future. Hello everyone, today we're taking a look at the Meteor 75 Pro. This is kind of almost a revisit because most things are the same, but one big change that they have is they're now using a different flight controller. The primary purpose behind that flight controller is it now has the VTX on board, and it's also slightly lighter. It's got a 1mm thick board. As a reminder, this does not have the traditional micro USB port. They have this little adapter you have to plug in, and it is USB-C based. The motors are 1102, 22,000 keV, and on those motors are Gemfan, a 45mm tri-blade props. The camera remains the same. It's the Beta FPV CO3 camera. Connector is Beta FPV's BT20 with a 180-degree turn in it. As you can also see there, we have motor connectors, so we can swap out motors relatively easily without having to do any soldering. Those holes in the canopy, they have some accessories that you can make this kind of look like a knight from the days of yore. Also in the accessory package are two different additional camera mounts that change the camera angle. Though you can't change the camera angle by just pushing this down, you got to take the canopy off, unscrew that mount, which you can see right here. Put the new mount on, of course, with the camera inside. It weighs 30.24 grams, or 30.25 grams. I flew it and tested it with these three different 1S batteries. With the GNV 550, it weighs 43.43 grams. With the Beta FPV 550, it weighs 44.52 grams. And with the Beta FPV Lava 450, it weighs 42.75 grams. While it's called the Meteor 75 Pro, I am getting 80mm or a little bit over that, but they do list 80mm as the specification. Motor post to motor post. Of course, in the accessory pack, we get a micro or tiny Phillips screwdriver. We get the USB adapter. We get some extra props and some extra motor screws. The aforementioned accessories, a 1S battery checker and charger. It plugs in via USB-C, and it does come with the cable to plug in this little charger. Of course, we're going to start off with the inside flight, but I do want to call your attention to the time on the OSD. When we get to 3 minutes and 34 seconds, we're going to see a VTX issue that I sometimes experience. Also note that because we're talking about the VTX that I am flying R1, which is race band 1, typically I fly race band 8. This particular flight that I picked out just happened to be on that because I did fly race band 8 as well. I didn't think the VTX signal clarity that I typically get in the house was up to par. That's why one of the reasons why I changed channels is to see if I could get different sorts of reception. I didn't find it to change much. And the aberration, or the thing that I'm going to draw your attention to at the timer at the bottom right, at 3:34, I did experience that on both R8 and R1. It could be a one-off. That's just, mine, but it could impact the others as well. It could be something that needs to be corrected. I didn't experience this issue outside. Outside, I thought the VTX, or the video transmission, was pretty normal. For those that aren't familiar with the channel, I've been flying inside the house for somewhere around 8 or 9 years, and I get good video reception, mainly flying on the raceband channels, primarily raceband 8. That gets us up above Wi-Fi, which of course my home does have Wi-Fi inside of it, so that frequency is fairly important when it comes to getting good video signal. Also, our house is made of traditional sheetrock and wood. Your video reception in different sorts of home layouts and construction will be somewhere between markedly different to slightly different, depending upon how different it is. But you can see as we're down here in the basement, we're getting a lot of the black flashes around in our video, which I don't typically get. And you can go to any of the WOOP videos that I've
Alright, good day everyone. Welcome to today's broadcast. So moving right along, we're talking about Inventor surfacing and freeform modeling. And what you may notice right off the bat is I did not list a version of Inventor that we're going to be dealing with. The reason is this particular set of functions and features are within a couple of different versions of Inventor. So you don't have to be on 2019 or 2018. You can be as far back as 2015. The interface is going to be slightly different going through the different versions, but the capability is there. So again, my name is Kindred Cooper. I'm an MCAD Solutions Engineer with Hagerman & Company, and running the background Q&A, we've got Kevin Bosch, also an MCAD Solutions Engineer with Hagerman & Company. So the next slide, if you can hear me, great. Obviously, this is for those who cannot. But it also showcases the Q&A panel. Either during the broadcast, you're more than welcome to enter questions and Kevin will address them, but we will also have designated time at the end to address those questions. So by all means, if you have any audio difficulties, video difficulties, anything like that goes on, shoot a question in there and Kevin will help you out. So let's move right along. I don't have a lot of slides to show you today. I've just got a couple of slides and then I jump straight into the live demo, so I'm not going to drag this out too much. But I do need to cover some very basic differences. And one thing that comes up a lot in discussion of surface modeling is what's the difference between a solid and a surface? The bare bones of this is a solid is considered to be a lump of material. And it has a parametric history associated with it. You've got extrusions, you've got revolutions, you've got fillets and holes and drafts and things like that to build that solid model. It has mass. You can associate a material with it, and the material density combined with the volume gives you that mass. It also has a center of gravity calculation, and it permits Boolean operations. That's your join command or your join option in extrude or revolve, your cut option, and your intersect option. The difference from the solid to the surface is the best way to think of a surface. Infinitely thin sheet of material. It has no mass whatsoever. Typically with surface modeling, you can have some parametric history. You're going to do extruded surfaces, revolved surfaces, but you're not going to have that additional Boolean operation. There's not going to be any extrude cuts or revolution cuts. Usually surfaces are handled in a different manner. Also, there are no physical properties for surfaces. You can't assign a material to them because there's no mass calculation, there's no volume calculation. Looking across the bottom on the left, you're looking at a solid cube. On the right, you're looking at the same exact sized cube created as a surface. So you'll notice that the ends of it aren't capped off, so you can see right through it and see the internal walls. Again, it's good to think of surfaces as an infinitely thin sheet or a deck of cards that you're going to basically glue together to make whatever shape you're going to be working with. So why use surfaces? A lot of engineers start hearing surfaces and trying to work with surfaces, and very quickly they get burned out because it is a different mindset that it takes to work with surfaces. You can't approach it from the traditional solid modeling workflow. You got to kind of twist your brain around and think differently because the outcome, the end result is going to be a little different. You're primarily going to use surfaces when you get into incredibly complex shapes. A few versions back in Inventor, if you tried to perform certain sweep operations, you would encounter an error, and the error name was self-intersecting loop. In many cases, when you encounter that, the only way to get around that was to recreate that geometry as a surface. Then you could get around it in most cases. So you were dealing with some complex geometry, so you had to use surfacing to generate that geometry. Solid modeling might leave some extra material, garbage material, leftover material, however you want to describe it, but it's little pieces of solid mass that's left over. Okay, you had to create this shape with a loft and then a sweep and then a fillet, and when you did all of that, there's this little tiny lump left over at the end, and it's the result of how the loft came through an extrusion or the sweep turned a corner. There's just this little piece left over that you don't need. That's considered a garbage feature. There's various ways of dealing with that. You can clean up some of it, you can cover up some of it. In a lot of cases, when you're dealing with surfaces though, you can break those surfaces down to where you can remove that garbage material. Also, you would use surfaces if you wanted to limit your modeling history. Now, this comes into play if you're wanting to send your design outside to another vendor or maybe a partner that you're working with to design some project, and you don't want to give over any proprietary information. The internal components or the outside shape, you want to make it as difficult as possible for somebody to reverse engineer it. So you can construct your model using surfaces, or for that matter, break it down and change it into surfaces. That way they can't easily extract, here's this sketch, here's this extrusion, and get all that measurement detail. So now let's twist this up a little bit. So today we're talking about surface modeling and freeform modeling. Well, what's the difference? What would freeform modeling be, and what would it be used for? The capability for Inventor was introduced in Inventor 2015. And the best way to think about it, virtual clay. It's a lump of geometry that you start grabbing and pulling and twisting and turning. You can kind of sort of shave off corners, you can push corners in, be very much like having that mass of material in your fingers and just working with it. It is a mesh of surfaces that are connected by T-splines. Many may not be familiar with what T-splines are. If you've ever heard of Rhino, this technology was developed and to be incorporated into Rhino, and Autodesk bought the technology and plugged it into Inventor. T-splines are very close cousins to NURBS. If you've never heard the term NURBS, NURBS deals with advanced surface modeling. It stands for non-uniform rational B-spline, and it's an advanced curvature definition, typically based on spline curves with extra math on how to control the control points of the spline curve. T-splines are almost identical to NURBS. NURBS is an older technology developed on older platforms. T-splines are very new, developed in modern platforms. So the industry as a whole is kind of shifting their focus towards using T-splines. The math that goes into T-splines and NURBS is the same advanced math, very advanced algorithms. It takes a lot of programming to get this to work out. So it's a high-end surfacing and modeling level to create your geometry. Another term that you hear some in the industry use is taffy pull modeling. It's essentially what it's like. You got a block of material just like clay or taffy, and you pull and stretch it to get your different shapes. With freeform modeling, you are given a start point of some basic primitives: box shape, plane shape, cylinder, sphere, torus, and a quad ball. That helps get you started, but you can also take an existing model and you can convert those faces into untrimmed T-spline surfaces for mesh modeling. So what is it used for? Okay, well, you can use freeform for concept modeling. If you look at the image on the lower left, the basic shape of an SLR camera, perfect example for using freeform, because to work in this mindset of generating a camera shape using solid modeling, it can be tricky. Yeah, you've got some lofted shapes in there, you've got some draft angles, but it needs to be smooth. For one reason, it's a consumer product. So you're looking for ergonomic fit, form, and function in the hands of the user. So you want nice, smooth contours. Surfacing usually comes in this area, but to do this with surfacing, it's much more complicated and drawn out. So you can also use freeform for any kind of geometry manipulation that is too difficult for surfacing. Again, back on the camera, you could do it with surfacing, but it's going to take too much time and effort. You're also going to use it when you've got smooth contours, curves, ergonomic designs, as I mentioned, and you can mix it with solid and surface modeling practices when you're dealing with unique contours and need specialized control. Looking at the kind of claw hook component down on the right end, there is a mix of solid modeling and mesh modeling because trying to do this with a loft wasn't working out. I kept using cross sections and different control rails and things, and it just wasn't giving the output that the customer wanted. So you introduce mesh modeling, and you're able to tweak those surfaces better. In the middle is from Inventor 2015. Started out just being the head of a Doberman, kind of playing around and learning it. And to get that final form took me about 40 minutes. So learning curve wise comes into play here when you're talking surfaces versus freeform. The learning curve for solid modeling, for example, if you're in Inventor and using it daily, you can become pretty proficient in it in a week, even more so in 2 weeks. With surfaces, you're going to have to get in there and brute force, go through it, and force yourself to use that workflow. And it can be challenging. Even going through training, it can create a hurdle when you're trying to go from solid to surfacing. Learning curve for being proficient at surfacing, probably close to a month. So right there, you're 3 or 4 times longer than with part modeling. Learning curve for mesh modeling, about 5 minutes. It is literally that quick. It's easy to get in there, understand what's going on, and just start pulling things out. It actually functions more in how our brains are designed to function. Just grab it, pull it, let me do what I want to with it. So with that in mind, let's go and just jump into it. All right, starting out, we're going to look at surface modeling, some of the basics of surface modeling. So what I've got displayed here are 2 simple 2-dimensional sketches. Each of them has a series of arcs or spline curves. Now, when I incorporate something like a loft shape, of course, I can get a lofted surface, and I'll just turn off the translucent and get some nice curvature definition in there. I'm going to back up and I'm going to incorporate a third type of geometry to create that surface. And that's going to take place inside a 3D sketch. In a 3D sketch, it's a different animal than a 2D sketch. You get some different utilities to use, one of those being an intersection curve. So what I'm going to do with this is choose my first 2D sketch, then my second 2D sketch, and what this command is actually going to do, it's going to look at the profiles of each of them, and as they intersect, it's going to create a 3D sketch curve out here in space. So again, what's happening is it's looking at the front profile, how this shape projects back and intersects with the other sketch profile shape projected up. You get a mix of the two, so it's a 3D curve. I can incorporate that into the loft command and get a much more dramatic shape. So with that in mind, let's go and just jump into it. All right, starting out, we're going to look at surface modeling, some of the basics of surface modeling. So what I've got displayed here are 2 simple 2-dimensional sketches. Each of them has a series of arcs or spline curves. Now, when I incorporate something like a loft shape, of course, I can get a lofted surface, and I'll just turn off the translucent and get some nice curvature definition in there. I'm going to back up and I'm going to incorporate a third type of geometry to create that surface. And that's going to take place inside a 3D sketch. In a 3D sketch, it's a different animal than a 2D sketch. You get some different utilities to use, one of those being an intersection curve. So what I'm going to do with this is choose my first 2D sketch, then my second 2D sketch, and what this command is actually going to do, it's going to look at the profiles of each of them, and as they intersect, it's going to create a 3D sketch curve out here in space. So again, what's happening is it's looking at the front profile, how this shape projects back and intersects with the other sketch profile shape projected up. You get a mix of the two, so it's a 3D curve. I can incorporate that into the loft command and get a much more dramatic shape definition, again, using surfaces. The trick to using or generating surfaces, anytime you have an open profile, which means the endpoints are not connected, Inventor is going to generate a surface entity instead of a solid. Even if it's a closed profile like a square or rectangle or a circle, when you choose extrude or revolve, you do have the option to generate that as a surface instead of a solid. Looking more so on some of the other commands in a 3D sketch that will provide subsequent geometry for use in surface modeling. Back inside that 3D sketch, you have the project to surface command with various options on this. You're going to choose what curves or what sketch geometry to project onto particular surfaces. So I've got a cylindrical surface modeled out here, and my various options are project along a vector, project to closest point, or wrap to the surface. If I leave the default and project along the vector, it's going to project normal to the sketch geometry, to the two lines in the arc. And it's going to project it back onto that surface, and you get this curved shape. Okay, well, what does this curved shape do for me? I can use this for various things. I can use the split command to break up the cylinder surface with that curved geometry. I can trim it out in the surface tools and use this as a cutout for some kind of notch, some kind of anchor. Who knows what it's going to be used for. The next one to look at is same cylindrical surface that I'm going to use, but I'm going to wrap to that face. So I'm going to project on that same face, and my curves are going to be these pieces of geometry here, and it projects it and it wraps it around. In a sense, you're getting a path that you can follow with a sweep cut. Maybe a cam path, a screw path follower, who knows what you could use this for. The nice thing about these is, yes, it's a projection. Okay, so I cannot come in here and directly edit the yellow line. It's a projection just like standard project geometry in a 2D sketch, but they are associated back to the source geometry. So if I come back and I edit this particular sketch, and I change, let's say I just killed the dimensions to give me a little bit better control. If I change the length of the main arc, when I finish the sketch, the projected wrap updates. And that's the nice thing about using these intersection curve commands and the projection commands, is they update that geometry live. It's not just a static view of it. Another one of the commands to utilize on that projected surface, I've got a surface plane out here. It's kind of a curvy plane, just made using a lofted shape. And I'm going to project to the closest point, and I'm going to project that spline curve. Again, when you're working with surfaces, you're actually getting a curve that follows and intersects that entire surface topology. So the projection is actually curving and following along. And again, you could use this for a cam follower or something like that. So when you're working with surfaces, what can you do with it once you have a bunch of surfaces created? Well, take for example, in this particular file here, we have a series of surfaces that are creating an airtight void, for lack of a better description. Inside here, there are no gaps, there's no open areas. All of these surfaces intersect with each other, they cross over each other. So that can help us generate some modeling geometry. I can use the sculpt command on the surface panel, and I can select these various surfaces to generate and fill that void area with solid material. So I end up with this solid block of material. It's the startings of a mouse designed for a computer. You can use the sculpt command to not only build material, but also to cut material away to get different contours and different shapes. So you can build with surfaces, again, open profile, extrude, revolve, and use sculpt to close in all of those surfaces. Going a little bit farther and reintroducing that 3D intersection curve. Let's look at this particular file here. We're working with a series of 2D and 3D sketches. So that working with surfaces, what can you do with it once you have you can use this for? The nice thing about these is, yes, it's a projection. Okay, so I cannot come in here and directly edit the yellow line. It's a projection just like standard project geometry in a 2D sketch, but they are associated back to the source geometry. So if I come back and I edit this particular sketch, and I change, let's say I just killed the dimensions to give me a little bit better control. If I change the length of the main arc when I finish the sketch, the projected wrap updates. And that's the nice thing about using these intersection curve commands and the projection commands is they update that geometry live. It's not just a static view of it. Another one of the commands to utilize on that projected surface, I've got a surface plane out here. It's kind of a curvy plane, just made using a lofted shape. And I'm going to project to the closest point, and I'm going to project that spline curve. Again, when you're working with surfaces, you're actually getting a curve that follows and intersects that entire surface topology. So the projection is actually curving and following along. And again, you could use this for a cam follower or something like that. So when you're working with surfaces, what can you do with it once you have a bunch of surfaces created? Well, take for example, in this particular file here, we have a series of surfaces that are creating an airtight void, for lack of a better description. Inside here, there are no gaps, there's no open areas. All of these surfaces intersect with each other, they cross over each other. So that can help us generate some modeling geometry. I can use the sculpt command on the surface panel, and I can select these various surfaces to generate and fill that void area with solid material. So I end up with this solid block of material. It's the startings of a mouse designed for a computer. You can use the sculpt command to not only build material, but also to cut material away to get different contours and different shapes. So you can build, working with surfaces, what can you do with it once you have a bunch of live? It's not just a static view of it. Another one of the commands to utilize on that projected surface, I've got a surface plane out here. It's kind of a curvy plane, just made using a lofted shape. And I'm going to project to the closest point, and I'm going to project that spline curve. Again, when you're working with surfaces, you're actually getting a curve that follows and intersects that entire surface topology. So the projection is actually curving and following along. And again, you could use this for a cam follower or something like that. So when you're working with surfaces, what can you do with it once you have a bunch of surfaces created? Well, take for example, in this particular file here, we have a series of surfaces that are creating an airtight void, for lack of a better description. Inside here, there are no gaps, there's no open areas. All of these surfaces intersect with each other, they cross over each other. So that can help us generate some modeling geometry. I can use the sculpt command on the surface panel, and I can select these various surfaces to generate and fill that void area with solid material. So I end up with this solid block of material. It's the startings of a mouse designed for a computer. You can use the sculpt command to not only build material, but also to cut material away to get different contours and different shapes. Geometry. Surfaces intersect with each other, they cross over each other. So that can help us generate some modeling geometry. I can use the sculpt command on the surface panel, and I can select these various surfaces to generate and fill that void area with solid material. So I end up with this solid block of material. It's the startings of a mouse designed for a computer. you can use the sculpt command to not only build material, but also to cut material away to get different contours and different shapes. So you can build with surfaces, again, open profile, extrude, revolve, and use sculpt to close in all of those surfaces. Going a little bit farther and reintroducing that 3D intersection curve. Let's look at this particular file here. We're working with a series of 2D and 3D sketches. When I extrude, here's the option. By default, extrude will create a solid, but you can choose to create a surface if need be. For this operation, I'm going to choose the sweep option. Sweep that profile along this straight line path, and I'm going to incorporate a guide rail. Now again, this is creating solid geometry for me, so how can I mix in surfaces with this? I'm going to create one more sweep and another guide rail. That gives me a handle. This is the startings of a hairdryer, and you've got the finger grips down here. If I look, I've also got an extruded surface. Now again, this is just a simple sketch. Slice my graphics so you can get in here and see this. Simple arc or spline curve sketch, and I've just extruded it, making a sheet, so to speak. In the 3D sketch command, I can use that to create an intersection curve. So previously I had two 2D sketches, and I use those to create the intersection curve. You're not limited to just using sketches. I can use this existing feature and this existing feature. So it's looking at the surface topology and how they intersect, and it gives me this yellow projected curve. Okay, so what does that do for me? Turn off the visibility here. There's another sketch right here inside of this, just a little rectangular shape type sketch. And it's a hairdryer, it's a consumer product. So let's kind of jazz it up a little bit with some surface designs. I'm going to use the sweep command again, sweeping this rectangular profile, and my path is going to be that intersection curve that I just created from the surfaces. And I'm going to cut that. Well, the problem is, back here at the beginning, it's staying nice and normal to the barrel of the hairdryer, but out here at the end, it's twisting. It's twisting around. We don't want that twist. We want it to stay normal as it follows that surface. So you can use the path and guide surface option of the sweep command. The nice thing about this, if this was not a solid and it was still just a surface shape, you could still use that surface to help guide this cut. So now when I choose that as the guide surface, it maintains that normal alignment to the surface, and I get a groove that I can then apply fillets and cutouts and little designs to jazz up this hairdryer for consumer products. Let's go a little bit farther into the nitty-gritty of surfaces. So what we've got here is a surface of a razor, electric razor. And we need to do some geometry adjustments. So I'll just go ahead and take out this particular step. Oops, one too far. Take out that particular feature. And it's going to leave me with this open surface here. I could even break out the stitch and break it down to the simplest form. Again, basic surfaces, a couple of different surfaces created from a sweep, from a loft, and from an extrusion. You'll notice with this surface, there is no mass. If I run an eye properties on this, look at my physicals, no mass, no area, no volume, because it's an open profile, it's an open set of surfaces. I need to cap off this bottom end. There are a couple of ways I could do that. In the surface panel, I can extend faces. That's one way of closing this in. And you can apply measurement value, how far you want to extend it. But you can run into little issues with surfaces. If you extend it too far, then you get little mathematical discrepancies. And that's kind of what you're seeing here. The surfaces are starting to break apart from each other, and they're kind of overlapping. This is one reason that a lot of people don't want to use surfaces. It's a challenge to make adjustments and clean up some of that geometry, or it can be a challenge. So I could use the extend to bring that up if I wanted to, or I could just use the boundary patch. And what the boundary patch does is it looks for a chain of edges, and if it doesn't pick up the loop, you can pick edge, 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 edge until you generate the loop. It doesn't have to be auto-selected. But it's going to patch over that opening with a surface. A couple of controls you have with boundary patch. It can be a free condition, so it just flat face across this. Or it can be tangent, so it's going to look at the surrounding surfaces and create a patch that's tangent to those surfaces. As you see, it bumps it up. Or you can choose the G2 Smooth, and G2 is a higher level of curvature continuity control. You're getting into Class A surfacing and ergonomic designs when you're using G2 curvature control. It changes the profile slightly. We'll just go ahead and keep that. You'll notice all surfaces default to be translucent. That option can be disabled just by unchecking translucent in the tree. And you can change the surface color as well. You can use the appearance pull down on this just like you can solid modeling. So where this can come into play is not only in the design of the electric razor itself, but what if your job is you're the tool shop that's going to make the fixturing for this? How can you use surfaces? Well, more than likely, they're just going to send you a surface. They may not send you the solid geometry. They might just send you the surface profile that could have come out of Rhino or Alias or who knows. They're just sending you that surface model. In that situation, you can still use it. So what we've got here is that same razor design, and I've created a fixture plate, jig plate, and we're basically just going to create a way to mount this for consumer products. Let's go a little bit farther into the nitty-gritty of surfaces. So what we've got here is a surface of a razor, electric razor. And we need to do some geometry adjustments. So I'll just go ahead and take out this particular step. Oops, one too far. Take out that particular feature. And it's going to leave me with this open surface here. I could even break out the stitch and break it down to the simplest form. Again, basic surfaces, a couple of different surfaces created from a sweep, from a loft, and from an extrusion. You'll notice with this surface, there is no mass. If I run an eye properties on this, look at my physicals, no mass, no area, no volume, because it's an open profile, it's an open set of surfaces. I need to cap off this bottom end. And a couple of ways I could do that. In the surface panel, I can extend faces. That's one way of closing this in. And you can apply measurement value, how far you want to extend it. But you can run into little issues with surfaces. If you extend it too far, then you get little mathematical discrepancies. And that's kind of what you're seeing here. The surfaces are starting to break apart from each other and they're kind of overlapping. This is one reason that a lot of people don't want to use surfaces. It's a challenge to make adjustments and clean up some of that geometry, or it can be a challenge. So I could use the extend to bring that up if I wanted to, or I could just use the boundary patch. And what the boundary patch does is it looks for a chain of edges, and if it doesn't pick up the loop, you can pick edge, 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 edge until you generate the loop. It doesn't have to be auto-selected, but it's going to patch over that opening with a surface. A couple of controls you have with boundary patch. It can be a free condition, so it just flat face across this. Or it can be tangent, so it's going to look at the surrounding surfaces and create a patch that's tangent to those surfaces. As you see, it bumps it up. Or you can choose the G2 Smooth, and G2 is a higher level of curvature continuity control. You're getting into Class A surfacing and ergonomic designs when you're using G2 curvature control. It changes the profile slightly. We'll just go ahead and keep that. You'll notice all surfaces default to be translucent. That option can be disabled just by unchecking translucent in the tree. And you can change the surface color as well. You can use the appearance pull down on this just like you can solid modeling. So where this can come into play is not only in the design of the electric razor itself, But what if your job is you're the tool shop that's going to make the fixturing for this? How can you use surfaces? Well, more than likely, they're just going to send you a surface. They may not send you the solid geometry. They might just send you the surface profile that could have come out of Rhino or Alias or who knows. They're just sending you that surface model. In that situation, you can still use it. So what we've got here is that same razor design, and I've created a fixture plate, jig plate, and we're basically just going to create a way to mount this and keep it stable so that we can drill some holes in it for the battery cover and various little things like that. The problem is there's no flat area on here to grab a hold of or hold steady with a clamp. So what we can do is we can make a formed fixture. Now the bottom piece here, the bottom plate, I've already cut it out for the size and the shape of the end of the electric razor. But up here on the support block, I haven't cut it out. It's just got the surface laying into it. So here's how you can use these surfaces that are being sent to you, and you can use them to modify your solid geometry. I'm going to take this block and I'm going to edit it through the context of the assembly. Okay, then I'll take and use the command copy object. What this does is it allows you to copy faces or an entire body and promote it into your existing component as a surface. So I'll just copy out these faces. Actually, I'll copy out the whole body. That'd be more straightforward. Just go ahead and grab them all. And you can choose for it to be associative or not. If it's associative, then it will change and update as changes are made to the surface file. Okay, so right now it doesn't look like a lot changed. What I'm going to do is I'm going to return out to the assembly and open my support block by itself. What you'll notice now is you see a surface representation of that razor existing in this support block. I can use the sculpt command to cut out that geometry. The only thing I'm going to have to do first is patch up that composite and stitch it as a surface, and then use the sculpt command to cut out that material. So it's still working with surfaces. It's razor itself looks for a chain of edges, and if it doesn't pick up the loop, you can pick edge, 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 edge until you generate the loop. It doesn't have to be auto-selected, but it's going to patch over that opening with a surface. A couple of controls you have with boundary patch. It can be a free condition, so it just flat face across this. Or it can be tangent, so it's going to look at the surrounding surfaces and create a patch that's tangent to those surfaces. As you see, it bumps it up. Or you can choose the G2 Smooth, and G2 is a higher level of curvature continuity control. You're getting into Class A surfacing and ergonomic designs when you're using G2 curvature control. It changes the profile slightly. We'll just go ahead and keep that. You'll notice all surfaces default to be translucent. That option can be disabled just by unchecking translucent in the tree. And you can change the surface color as well. You can use the appearance pull down on this just like you can solid modeling. So where this can come into play is not only in the design of the electric razor itself, but what if your job is you're the tool shop that's going to make the fixturing for this? How can you use surfaces? Well, more than likely, they're just going to send you a surface. They may not send you the solid geometry. They might just send you the surface profile that could have come out of Rhino or Alias or who knows. They're just sending you that surface model. In that situation, you can still use it. So what we've got here is that same razor design, and I've created a fixture plate, jig plate, and we're basically just going to create a way to mount this and keep it stable so that we can drill some holes in it for the battery cover and various little things like that. The problem is there's no flat area on here to grab a hold of or hold steady with a clamp. So what we can do is we can make a formed fixture. Now the bottom piece here, the bottom plate, I've already cut it out for the size and the shape of the end of the electric razor. But up here on the support block, I haven't cut it out. It's just got the surface laying into it. So here's how you can use these surfaces that are being sent to you, and you can use them to modify your solid geometry. I'm going to take this block and I'm going to edit it through the context of the assembly. Okay, then I'll take and use the command copy object. What this does is it allows you to copy faces or an entire body and promote it into your existing component as a surface. So I'll just copy out these faces. Actually, I'll copy out the whole body. That'd be more straightforward. Just go ahead and grab them all. And you can choose for it to be associative or not. If it's associative, then it will change and update as changes are made to the surface file. Okay, so right now it doesn't look like a lot changed. What I'm going to do is I'm going to return out to the assembly and open my support block by itself. What you'll notice now is you see a surface representation of that razor existing in this support block. I can use the sculpt command to cut out that geometry. The only thing I'm going to have to do first is patch up that composite and stitch it as a surface, and then use the sculpt command to cut out that material. So it's still working with surfaces, no solid geometry yet, but it's looking at those surfaces where they intersect that support block, and it cuts out that material. Well, I actually did a join instead of a cut. That was my fault. There we go. And cut in the wrong direction, so we'll just flip the direction and cut out that center pocket. So now we have a very formed holding area. If you don't like it being an exact shape, you can always use the thicken and offset command and offset these spaces inward. We'll say 1/1000 of an inch, 2,000, whatever type of clearance or tolerance that you're comfortable with. So even though you're working in solids, you can still utilize surface geometry to manufacture against and build shapes from. That's surfacing in a nutshell. So how does that differ from freeform? Freeform modeling, in an empty part, there is a create freeform panel, and you have your primitives that you can start with. So if I look at something like a primitive box, for example, you're going to choose the sketch plane that you're going to create this shape on to define your orientation. It is creating a center point rectangle, so you just pick the center point, and you get a very rounded, purpley looking mesh of surface. You can adjust your length and height, so we'll say 7 by, say 5, and maybe 3 inches thick. And we're going to go ahead and make it symmetric. Then you can adjust your face mesh lines. So how many faces do you want across the length? Well, I'm going to jump this up to maybe 7. Across the width, I'll jump this up to maybe, we'll do 5 on that, and probably, I'll do 5 on that one as well. You can choose to have symmetry automatically when you're creating this shape, but you can also define symmetry afterwards. So I'll define it afterwards for this. When I say OK, it takes me into the freeform environment within Inventor. So you notice I have an entirely new tab that wasn't even visible a minute ago, and different freeform related commands. So how does freeform work? Well, you're going to start by editing your shape. So I'll say edit freeform. You have an edit freeform dialog that allows you to choose various areas of this mesh. Now you can isolate it to say, let's just look at points. So when I just look at points, you see the node control points of each mesh intersection. Or let's just look at edges. Then you're only selecting edges. You can't select anything else. Or isolate it to faces, or everything. You can select points, you can select edges, you can select faces. When you choose any one of those items, here's what happens. So right now, I'll choose a control point. And you get various little names for this guy: 3D gizmo, triad, transform handlebar. See all kinds of different references to it. the function is the same. You get 3 arrows to move and relocate that point, face, or edge along the X, Y, or Z axis. And you can even control how you make that adjustment. Is that X, Y, Z orientation based on the world coordinate system? Is it based on the view, which changes to a different orientation, or based on the local coordinate system of the point, edge, or face? So you got some options there on how you want to move this. Once you click, say, we'll drag it out in the Z direction. Click and hold down on that arrow. When I drag it, you'll notice it pulls that point, but look what happens to the other faces and edges around it. This is why it's called taffy pull. It's adjusting that geometry of those faces and edges to move with it. Now you can type in values. You do have numerical control on this, but there's no dimension to tie it into. There's no parametric history being kept. Again, this functions kind of how we want it to function, how our brains think. Grab it, let me move it, I'm not worried about dimensions yet. You also have control to move it spatially 2 directions at a time. So that's what each one of these little plane squares are for. So if I choose the bottom plane, it's going to move that point in the X and Z direction on the XZ plane. And it's not going to adjust it in the Y direction. It's just going to do X and Z. Inversely, you can scale it. So while it doesn't work much with a point because you're not going to change anything, if you're working with an edge, you can scale the edge to increase the length or decrease the length of the edge. Same thing goes with a face. You can scale, as soon as I get the mini toolbar out of the way, you can scale that face to increase its size or decrease its size. And then you have the rotation arrows. Now this works great on all 3 of them, points, faces, and edges. When you choose the rotation handles out at the end, you can actually change the contour just by rotating, and I'm working with a control point, and it's changing the contour as follows. Now the nice thing about this is whatever edits you make, when you finish the freeform environment, it converts it into a solid block. It is a solid block, so long as your edits have not violated any of the algorithms that define it as a solid. When you start pulling faces into each other and crossing over and things like that, you can get some weird topology that it cannot convert into a solid. You can define symmetry. So when I choose symmetry, let's say I'm going to choose symmetry on the side here. I want to define symmetry between the top and the bottom, so I'm going to click 2 faces, and in between those, it's going to define symmetry. You see it mimics the behavior I've already set up out here previously. So when I choose to edit the form, now when I edit and drag out, or if I move it up, you see the bottom takes shape along with the edits made to the top. Using symmetry can cut down your modeling time in half because in here you're working usually in a symmetric sense. In the standard modeling environment, we have mirror commands that we can model just a quarter of it or half of it and mirror it over. There's no mirror command in here to tackle that. So symmetry allows you to set up that behavior. You can clear the symmetry of that solid to generate it. Once you have your solid generated, or your mesh generated, then bottom, so they cannot convert into a solid. You may. Same thing goes with a face. You can scale, as soon as I get the, if I choose the bottom, make that adjustment. Is that XYZ orientation based on the world coordinate system? Is it based on the view, which changes to a different orientation, or based on the local coordinate system of the point, edge, or face? So you got some options there on how you want to move this. Once you click, say, we'll drag it out in the Z direction. Click and hold down on that arrow. When I drag it, you'll notice it pulls that point, but look what happens to the other faces and edges around it. This is why it's called taffy pull. It's adjusting that geometry of those faces and edges to move with it. Now you can type in values. You do have numerical control on this, but there's no dimension to tie it into. There's no parametric history being kept. Again, this functions kind of how we want it to function, how our brains think. Grab it, let me move it, I'm not worried about dimensions yet. You also have control to move it spatially 2 directions at a time. So that's what each one of these little plane squares are for. So if I choose the bottom plane, it's going to move that point in the X and Z direction on the XZ plane. And it's not going to adjust it in the Y direction. It's just going to do X and Z. Inversely, you can scale it. So while it doesn't work much with a point because you're not going to change anything, if you're working with an edge, you can scale the edge to increase the length or decrease the length of the edge. Same thing goes with a face. You can scale, as soon as I get the mini toolbar out of the way, you can scale that face to increase its size or decrease its size. And then you have the rotation arrows. Now this works great on all 3 of them, points, faces, and edges. When you choose the rotation handles out at the end, you can actually change the contour just by rotating, and I'm working with a control point, and it's changing the contour as follows. Now the nice thing about this is whatever edits you make, when you finish the freeform environment, it converts it into a solid block. It is a solid block, so long as your edits have not violated any of the algorithms that define it as a solid. When you start pulling faces into each other and crossing over and things like that, you can get some weird topology that it cannot convert into a solid. You can define symmetry. So when I choose symmetry, let's say I'm going to choose symmetry on the side here. I want to define symmetry between the top and the bottom, so I'm going to click 2 faces, and in between those, it's going to define symmetry. You see it mimics the behavior I've already set up out here previously. So when I choose to edit the form, now when I edit and drag out, or if I move it up, you see the bottom takes shape along with the edits made to the top. Using symmetry can cut down your modeling time in half, because in here you're working usually in a symmetric sense. In the standard modeling environment, we have mirror commands that we can model just a quarter of it or half of it and mirror it over. There's no mirror command in here to tackle that. So symmetry allows you to set up that behavior. You can clear the symmetry of that solid to generate it. Once you have your solid generated, or your mesh generated, then you can come in and you can use a mirror command that's in here to mirror your finished results. Back out of this, how is this going to work with surfaces and how's it going to work with solids? Let's take the example of seat cushions for cars and trucks, vehicles. So what I can do is I can start out by generating a basic shape of a seat cushion using surfaces. I've done an extruded surface here, just a 2D sketch that's an open profile, extruded out. Then I've done a lofted surface that's basically using 3 2D sketches. So I've got the first sketch back here in the background, the sketch in the middle for the middle profile, and the sketch at the end for the last profile. Generating those using surfaces, I can stitch surfaces together into one entity, makes it easier and cleaner to select geometry. I can then use the trim command. I'll trim out unneeded areas, so I don't need these pieces, these little V-shaped pieces out here. So I'll just use that stitched surface I just created and I'll trim out these areas. I can still use the trim command, use my lofted surface as my cutting tool, and then I want to remove the front area of that extruded surface that I've created. So I end up with something like this. Again, a series of surfaces. You can stitch those together and then take this and add to it that freeform shape. So if we're making a cushion, we're actually going to want to try to size this thing accordingly to where we can make all the little curves and adjustments within it. Again, we're going to add more faces to get more control over the mesh. We'll just add 11 faces. Well, actually, let's dumb that one down back to maybe 5 or 6. We'll go with 5. Okay, a few more adjustments I actually need to make. I'm going to edit the form, and you can grab the surfaces, and let's look flat to it, that'll make it a lot easier. Grab the surfaces, I'll translate them out. I didn't make it the original one thick enough, so I'll just pull those out. accept that flow. Look at my side profile. It's looking good. The sketch is in here. So what I'm actually going to do, or the surfaces are in here. What I'm going to do is just start editing this form. Actually, after I specify symmetry, that'll make my job a lot easier. So I can start editing this form, and using the control key, you can select multiple faces and edges. You have to be careful if you do a dragging window because you're picking not only the items in the front, but also the items in the back. And then you can use the control key to deselect those. So you can take these faces and drag them back, and you see the original surface model poking through. So for something like a seat cushion, I'm going to drag these profiles back until I see good uniform coverage and interaction between the mesh and the surface. Now this is a very time-consuming, tedious process. So I've already got a couple of these things in the oven and cooking. So I'll just jump to these guys. I've already done some adjustments here. The green is the surface model that I created. The gray is the freeform. So I'll edit the freeform. You see how the slight difference in color shows up. Again, just editing control points for this. I'm able to get the mesh and the surfaces back to where they can interact with each other or intersect with each other. That tells me I'm matching up on that shape. So just drag it back just a little bit. And again, the nice thing is over on the other side, because I've built in symmetry, it's defining those controls as well. As you see, the shape contours down and changes on the shading. So getting a little bit more of my seat cushion kind of adjusted. Again, I've got another one in the oven. I've already baked up. Got some more adjustments made to it. Getting closer, I got all the contour done in the back. The only thing I've got left is down here at the bottom. When I look in the mesh for this, I've got what looks like a sharp corner. One thing you might want to do to control and adjust this is you can take existing faces, you can break them up. So I've got all of these points and edges here. I want to increase my selection. So to do that, you can subdivide faces. So I'll just hold down the control key, pick all of these, go ahead and pick the one in the center, and it will subdivide those faces based on whatever options you choose, however many widths, however many lengths you want to work with. That's going to give you more faces, more edges, more control points to work with and make adjustments to round it out and finish it. So once you're done, jump out here to the finished product. Got my finished with my freeform right here. Just turn on visibility of it. You'll see very little of it kind of poking through. I got some very subtle surface deviations between it and the surface model. If I turn off the surface model, turn off visibility of that, you can see the freeform model. I've just applied an appearance to it to give it a texture like a seat cushion. We might need to make more adjustments though. If I turn on the visibility of my profile sketch, we can see, well, it's not big enough. So one question that might pop into your mind is, well, you created surfaces to start with, and then you made the freeform match up the surfaces. Why not just use surfaces? This is why. Because I need to edit the form of this. I need to make it longer, and I need to make it thicker. Not enough cushion. So when I edit the form, just grab the surfaces I need to manipulate, make it a little bit thicker, grab the other surfaces I need to pull down to make this a little bit longer. I'm not going to stretch out that surface too much. I'll redo my selection here, grab some others. So far, that could be done in surfacing. No big difference. What cannot be done as easily in surfacing is to make the individual edits on the back of this to change the lumbar support and the location of the cushion. So we're going to drag these points out, get a little bit closer, drag these node points out, again to give the driver or the passenger better support. We need to change the outside contours on the wing locations of the chair or on the seat cushion, and again give better support to hold them in place. This could be a high-speed racing vehicle. It could be a construction vehicle. It needs a lot of support. Maybe fatten this guy up to give more cushion around the edges. This is the kind of stuff that to do it in surfacing would be a near monumental task. You're going to spend a lot of time trying to construct these cross sections to get all this math to work out. Now you'll also notice I can't click OK. What that means is I've got something wrong in my surface topology. It's not liking the mesh. Something's wrong with it. So the easiest way to see those issues is to turn off the smooth contours. And what you're looking for are lines and edges that disappear, like on this vertex here. Got some things getting out of whack, so I need to clean up a couple of these points. As soon as I do that, OK lights up, I got a good shape, and I can turn on the smooth. So now I've got a seat cushion that's sizing better, has more of the contours that the customer has asked for, or more of the contours that we're seeking. So looking at that mix, one question that comes up with surfacing and with freeform modeling especially, is it Mudbox? Some of you may have seen Autodesk Mudbox. If you haven't, I advise you Google it. It is really cool looking stuff, very impressive. The difference between it is different industry target, different technology. Mudbox is targeted at artists, game designers, game character designers, and some product designers. Yes, you're getting more ergonomic designs, but its core audience is artistic and game related type audiences and entertainment audiences like movie editing, special effects editing and things. You start out with a basic primitive solid in Mudbox, just like you do with Freeform, and then you start tweaking it. It looks very similar on what you're doing, but Mudbox has different tools and different techniques that's more centered around virtual clay. Whereas in mesh modeling, in Inventor, they're just giving you the ease of grabbing surfaces, points, and edges and just move them. We can flatten out things, we can add creases to things, we can bridge surfaces, we can torque surfaces, but one thing we can't do is control texture mapping on that surface. That's where the artistic side comes in. On the character he's got here, you've got something like scales down around the chest plate. You've got different, what may be hair follicles or skin creases. All of that is done with texture mapping in Mudbox. So the technologies look similar, but they are very dissimilar. With that, we will open it up for questions. Kevin, how's the Q&A panel looking? Or how's it been looking?
It's been pretty good. Quiet so far. The seat cushion demonstration was extremely applicable. One of the questions was directly related to creating seating, so that looked out pretty good. So far, we've had a question about the difference between Fusion 360 and Inventor, and then CNC for Inventor. So I've answered those. Okay. Can you add dimensions? Here's one from Randy. Can you add dimensions to the freeform?
Well, short answer is no, because it's designed to be controlled by adjustment dimensions, not overall dimensions. What you're actually going to do is, like I did in the seat cushion demo, have a sketch that has your dimensions and your shapes, and use that as a guideline. Essentially, your sketch or your surface is going to be an overlay that you're going to adjust the freeform to get close to. And as I pointed out with the seat cushion, where freeform really comes in, it's not on those outer edges. That's kid stuff. No big deal there. Where it really comes into play and gets your power is what happens in between. One thing we have always mentioned with lofted features and swept features, especially with a loft, it's a mathematical best guess. And the only way you can get a better guess with lofts is more control rails. I have seen my share of surfaces where we could not figure out what that shape looked like halfway through unless we took the sample part and cut it into sections and traced over it, and just a headache of a time. So with freeform, you're able to control what happens in the middle without knowing what goes on in the middle. You can make the adjustments to it and have it look visually correct. There's math behind it, yes, but there's no math to control the overall. So no dimension to control the overall.
Very good. Let's see here. The next one, and this is definitely one that I'm not real familiar with, creating a relationship between 3ds Max and Inventor. I'm not sure, does 3ds Max pull out the SAT, or I just type files?
It does create, or it does pull out those files. It can actually pull in Inventor native IPT files. Last time I checked, I think it was a service pack you had to download, but there's no existing current way to connect the two seamlessly and have one update the other automatically. It's still kind of an external export out, import in process. And for Max, you're going to pull a file into Max to add more texturing, more colors, higher resolution rendering and material and lighting, and possibly even some animation.
Sure. And then surfaces converted to solids. I'll let you dig deeper into that one, but can that be done?
You know what? That's a good question. So let me pull this up. One of the questions that I answered earlier, one of the questions that I put out there, why didn't you just do this with surfaces? Why would you go through all this trouble to just take a surface and fill it with a freeform? Okay, you saw part of it, but the other part is this. We turn off visibility of the freeform and of the sketch. So when I bring my surface on, everything looks nice and clean, doesn't it? Looks good. Yeah, you got different colors because you can make faces be different colors. That's not a big deal. But one thing that I cannot do, you'll notice I can't put fillets on these edges. It grabs that one, doesn't grab that one, it grabs that one. 1/8 inch fillet, that should just give you the ease of grabbing surfaces, points, and edges and just move them. We can flatten out things, we can add creases to things, we can bridge surfaces, we can torque surfaces, but one thing we can't do is control texture mapping on that surface. That's where the artistic side comes in. On the character he's got here, you've got something like scales down around the chest plate. You've got different, what may be hair follicles or skin creases. All of that is done with texture mapping in Mudbox. So the technologies look similar, but they are very dissimilar. With that, we will open it up for questions. Kevin, how's the Q&A panel looking? Or how's it been looking?
It's been pretty good. Quiet so far. The seat cushion demonstration was extremely applicable. One of the questions was directly related to creating seating, so that looked out pretty good. So far we've had a question about the difference between Fusion 360 and Inventor, and then CNC for Inventor. So I've answered those. Can you add dimensions? Here's one from Randy. Can you add dimensions to the freeform?
Well, short answer is no, because it's designed to be controlled by adjustment dimensions, not overall dimensions. What you're actually going to do is, like I did in the seat cushion demo, have a sketch that has your dimensions and your shapes, and use that as a guideline. Essentially, your sketch or your surface is going to be an overlay that you're going to adjust the freeform to get close to. And as I pointed out with the seat cushion, where freeform really comes in, it's not on those outer edges. That's kid stuff. No big deal there. Where it really comes into play and gets your power is what happens in between. You know, one thing we have always mentioned with lofted features and swept features, especially with a loft, it's a mathematical best guess. And the only way you can get a better guess with lofts is more control rails. I have seen my share of surfaces where we could not figure out what that shape looked like halfway through unless we took the sample part and cut it into sections and traced over it, just a headache of a time. So with freeform, you're able to control what happens in the middle without knowing what goes on in the middle. You can make the adjustments to it and have it look visually correct. There's math behind it, yes, but there's no math to control the overall. So no dimension to control the overall.
Very good. Let's see here. The next one, and this is definitely one that I'm not real familiar with, creating a relationship between 3ds Max and Inventor. I'm not sure, does 3ds Max pull out the SAT or IGES type files?
It does create, or it does pull out those files. It can actually pull in Inventor native IPT files. Last time I checked, I think it was a service pack you had to download, but there's no existing current way to connect the two seamlessly and have one update the other automatically. It's still kind of an external export out, import in process. And for Max, you're going to pull a file into Max to add more texturing, more colors, higher resolution rendering and material and lighting, and possibly even some animation.
Sure. And then surfaces converted to solids. I'll let you dig deeper into that one, but can that be done?
You know what? That's a good question. So let me pull this up. One of the questions that I answered earlier, one of the questions that I put out there, why didn't you just do this with surfaces? Why would you go through all this trouble to just take a surface and fill it with a free form? Okay, you saw part of it, but the other part is this. We turn off visibility of the free form and of the sketch. So when I bring my surface on, everything looks nice and clean, doesn't it? Looks good. Yeah, you got different colors because you can make faces be different colors. That's not a big deal. But one thing that I cannot do, you'll notice I can't put fillets on these edges. All right, it grabs that one, doesn't grab that one, it grabs that one. 1/8 inch fillet, that should be no problem. But it is a problem. There's issues in this surface geometry. Remember, surfaces can intersect each other, they can cross over each other, they can go through each other, they can have gaps between their edges. So you get into situations like that. For that matter, I can't even come back out here and reselect these pieces of geometry. I've got one subsequent stitch on some of these faces. I can't run another stitch because there's problems in this surface. So this is another reason you wouldn't want to tackle this solely with surfaces. You can fix these problems. We can take it into the repair environment, take it into the construction environment. Both of those are strictly for surface diagnostics and surface corrections, and remove parametric history so you don't have a tree full of surface modifications. Yeah, we can fix them. It's going to take time. It's going to take time for the learning curve. It's going to take time for the actual process. So that's why I didn't use this or do this solely with surfaces. One reason is because of the errors in here. It will not let me convert it to a solid. But as you might have saw with the sculpt command, for example, if I come back in here to this guy, this is nothing but surfaces. Good, clean surface geometry, no issues. And with the sculpt, we can take all of these surfaces, close it in, and make that solid block. So you can take existing surface bodies, you can stitch them. The stitch command will convert it to a solid if there's no gaps and no overhangs in the surfaces. So basically, if you have a good watertight seal and all the edges are clean, it'll automatically convert it to a solid. That's one of the benefits of Stitch. So if you download a STEP file or a SAT file or an IGES file and it comes in as surfaces, sometimes that'll work. Sometimes it won't because of the quality of the file you're bringing in.
Very good. Let's see here. Suggestions for continued training or continued learning. I know YouTube has got a number of things out there. We don't have a specific surfacing class that I'm aware of.
We actually recently added, and I recently taught the surfacing and freeform modeling class about 3 weeks ago. We just now found a training manual that will accompany it. We've been looking for one for a couple of years. Well, let's say it this way. We've been looking for a good one for a couple of years. And I think we finally found one. The class flows very well. It's I can't remember if it's a 1 or 2 day class. It might just be a 1 day class, I think. But it flows very nicely. You cover a lot of the surfacing tools, and you cover some good in-depth basics of freeform.
Very good. Very good. That was one I was not aware of. Here's a real good question. How well would freeform models export into the CAM software for machining? Would the splines be compatible for creation with G-code? And I think we've seen some examples of some of that.
Yeah, I'd say it's going to depend on the topology and the curvature control of the mesh, of the freeform. It could be 50-50. You might get some models that export well and others that might not.
Okay.
If you run into that situation and it doesn't export well, obviously contact Hagerman. We can help you out on that.
Absolutely. And converting the freeform into a solid, that's pretty well done automatically when you export or exit the freeform environment. Is that not correct?
That is correct, so long as the freeform is still a complete bound form. So in other words, if you go in and you delete one little face square, it's no longer a bound form. There's an opening. So when that happens, it converts it into a surface.
Very good. And let's see, can you cut, extrude solid models from freeform parts, then re-edit the freeform part? And I believe kind of your couple of different examples that you showed did express some of that.
Yeah, it did. The challenge is the freeform, because it still exists in the parametric history, right? You still have that main history tree that's governing all of this. So you'll have the freeform as one feature. The extruded cut will be below it. So when you go back to edit the freeform, the cut is gone.
Right. And let's see. We had some questions about HSM.
I think questions like that we'll address offline. We do have HSM presentations if you're interested in those as well. Those are coming up. We also have some archived ones on the website.
Absolutely.
Okay, well, thank you everyone for attending today. Any questions that come in at the last minute or so, we'll definitely get back with you on those. If you have any other questions or want to see any other products or other demonstrations, by all means contact Hagerman. We're happy to help you out. We offer phone support, we offer training in person, we offer remote training, system setup, and consulting on system design and layouts. We're here to help you guys in any way we can.
Thanks, Kindred, for the presentation. This will conclude our broadcast. If you do think of additional questions later, you can simply reply to the confirmation or reminder email you receive from GoToWebinar, and we can get those to Kindred or whoever to get your questions answered. And once again, if you could take a few moments to fill out the survey, it'll just pop up as we close down today. And thank you for attending today's webcast, and have a great day, everybody.
Hello and welcome to this Autodesk Invented Tips and Tricks tutorial covering iPod creation. What is an iPod? If you're wondering what an iPod is, an iPod is a master part which has derivatives which are essentially the same part but with various different sizes changes. So let's say for example you're a company that manufactures this little doodah thing here. You might do the same part, but variation 2 might have a different number of holes, variation 3 might have a different width, variation 4 might have a different hole diameter. Instead of going save as and having to then edit the part, change the features, change the dimensions, save as again, change another one, blah blah blah, you create a master part, you convert it into an iPod, and the master part drives the
various different variations of that part. And you might know it as a factory number, factory table, factory part, depending what package you come from. Inventor calls them iParts. Right, how do we get going? I'm going to keep this as simple as possible. I'm just going to model them. A tube. Let's keep it very simple. A tube with width, length, height, and thickness. And we'll change those values in the iPart. So let's just start by sketching a very simple square profile. The first tip I can give you when working with an iPart is to name your parameters. Whatever it is that's going to change in your iPart, give them a name. So as we're sketching, I know this one's going to change, so we're going to call it width. I'm going to say that's going to be 50 mil. And this one's going to be length. And that's going to be 50 mil. This is just a master part, so these are kind of our starting values. So width and length. Let's finish that sketch. And then we'll do an extrusion. And we'll say this is going to be height equals I don't know. Height equals 100 mil. Okay, it's a bit of tube, so we need to hollow it out. So let's do a shell, and let's remove the top and bottom faces, so we're going to make a tubular. We'll call the thickness parameter PHK. So the initial thickness will be 2 mil. Pretty much part designed. If you go to the parameters, you should see we've now got width, length, height, and thickness. And there's the value.
Alright, good day everyone. Welcome to the form end of the sketch. So when I bring my surface on, everything looks nice and clean, doesn't it? Looks good. Yeah, you got different colors because you can make faces be different colors. That's not a big deal. But one thing that I cannot do, you'll notice I can't put fillets on these edges. Alright, it grabs that one.
What should I do?
Lasers and jelly spoons, welcome to TFI CAD Tips. And in today's tutorial, we're looking at grill. Now you might be thinking, grill? What grill? Grill. I see no grill. What is this grill you're speaking of? Say Englishman, I see no grill. Well, it's one of the plastic power buttons which OMS have deemed so infrequently used that they just went and hidden it completely. They've just disabled it so you've got to switch it on. So right click them on your ribbon bar, your blank area here, go to show panels, and then switch on plastic part, and you'll see 6 new buttons up here. Oh, new toys, quite right, quite right. New toys, 6 new buttons, and the one we're looking at is grill. So these are the features which assist you with the design of plastic parts. You've got things like snap fit clips, lips, rests, bosses, real filler, which is a mystery to itself. And we've got grill. So grill creates a grill, man. Obviously, creates a grill. You can't really use it creatively to do things which aren't meant to be a grill. It is a grill. That's pretty much all it does. So that is very niche, but I'll show you how it works, and you might be able to use it creatively. I don't know. It depends entirely what you're doing. But let's take a look. So I'm going to start by creating something extraordinarily basic, and then we'll look at something a little bit more advanced. So I'm going to start by, we're going to do something from scratch. So follow me if you will, if you want to, you can do. So I'm going to sketch on the XY plane, and then let's just snap at this rectangle. And make this, I don't know, 100 by 100, something like that. In fact, hell no, that's too small. Let's go 500 by 500. Right, 500 by 500. Finish that sketch and then extrude this both ways by 10 millimeters. Right, that'll do. So that could be a bit of plastic that we need to put a grill in. So the first thing you need to know about the grill command is you don't grill the entire thing. You can't convert a part into a grill. Basically what you're doing is you're creating a grill feature. So you're putting a grill into a part. So you need a new sketch to start with. So we're going to start a new sketch on this face. And your grill sketch, the sketch that you create to define the grill can be on the face or above it. So you can hold the left mouse button down and drag up by, say, I don't know, 50 mil, something like that. And then that could be the sketch for the grill. It doesn't have to be on the face. It sort of projects it down onto the surface, which is really good actually, because then this could be So the grill itself, right? You need two things. Well, at a minimum two things. You need a boundary, and then you need your grill lines. So we'll start with a boundary. Let's keep it simple. Let's just do lines and squares, because that's just, if you're not familiar with the grill, it helps you understand the concept of keep it simple to start with. So let's draw another rectangle, and let's keep it central. So snap there, and then we'll say this one will be 100 by 100. That's 100 tab 100, and it jumps between the dimensions. There you go. Just in case you didn't get that, if I'm like zipping ahead here. When you in the middle of sketching rectangles and stuff, if you type in 100 straight away, it types into that dimension. Then if you press tab on the keyboard, it jumps into the next one, and then you can just press return, and then you've got your thing you've done quickly. Just saves a bit of time. Saves a bit of time having to edit dimensions later on, which is what you used to do back in olden days. So that's the boundary for the grill. It might be difficult to visualize something like that. Hell no, that's too small. Let's go 500 by 500. 500 by 500. Finish that sketch and then extrude this both ways by 10 millimeters. Right, that'll do. So that could be a bit of plastic that we need to put a grill in. So the first thing you need to know about the grill command is you don't grill the entire thing. You can't convert a part into a grill. Basically what you're doing is you're creating a grill feature. So you're putting a grill into a part. So you need a new sketch to start with. So we're going to start a new sketch on this face. And your grill sketch, the sketch that you create to define the grill can be on the face or above it. So you can hold the left mouse button down and drag up by, say, I don't know, 50 mil, something like that, and then that could be the sketch for the grill. It doesn't have to be on the face. It sort of projects it down onto the surface, which is really good actually, because then this could be curved. You can actually have a curved surface to grill onto, which is nice. It's nice. Right. So the grill itself, right? You need two things. Well, at a minimum two things. You need a boundary, and then you need your grill lines. So we'll start with a boundary. Let's keep it simple. Let's just do lines and squares, because that's just, if you're not familiar with the grill, it helps you understand the concept of keep it simple to start with. So let's draw another rectangle, and let's keep it central. So snap there, and then we'll say this one will be 100 by 100. That's 100 tab 100, and it jumps between the dimensions. There you go. Just in case you didn't get that, if I'm like zipping ahead here. When you're in the middle of sketching rectangles and stuff, if you type in 100 straight away, it types into that dimension. Then if you press tab on the keyboard, it jumps into the next one, and then you can just press return, and then you've got your thing done quickly. It just saves a bit of time. Saves a bit of time having to edit dimensions later on, which is what you used to do back in olden days. So that's the boundary for the grill. It might be difficult to visualize where I'm going with this, but if you just follow me, you'll sort of understand in the end. And then we need to do a pattern. So this is one of those rare occasions where a sketch pattern is okay. In most instances, a sketch pattern is not okay. You need to do a 3D pattern. It's absolutely fine. So we're going to do a rectangular pattern, and then we're going to pattern this edge here, the direction. So you're going to click that red arrow, pick this edge, and we're going to have 10 lines spaced by 10 millimeters, which means it fits in the 100 boundary. Click OK, and then the second pattern is going to be this one here, and then the direction is going to be that line there, and we're going to flip it so it goes that way, and then we're going to have the same. We're going to have 10 by 10. There you go, right, so there you've got sort of profile for the grill. This outer rectangle is the boundary, and then these inner lines are the actual grill lines themselves. So we can finish that sketch, we can get rid of this work plane just by right clicking on it and then turning it off. And we're ready to launch the grill. So when you select grill, the dialog box for grill it's as, I guess, as user friendly as a developer could make it. That's all I can say about it really. It's got a diagram in it. It's kind of helpful once you know how it works, but when you first look at it, you're like, shit, the bed Christ and bite, that is just moving on. I'm not even going to look at this. We haven't got time for that. So you want to first select the boundary. So that's the first tab. The boundary is going to be the outer rectangle. Now, this is potluck, right? It's potluck. Sometimes you'll get a preview underneath when you select the profile. Sometimes you do, sometimes you don't. In this instance, I'm not getting a preview, which is extraordinarily annoying because in most instances in Inventor, if you don't get a preview as you're defining a feature, it means it's not going to work. But in this case, that's not necessarily true. I'm not getting a preview, but I'm pretty confident this is going to work. There's very little that can actually go wrong with it. So I've defined the boundary, and then the rest of these dimensions here are the sizes of the boundary. So the one important one is the depth. So this is how far the grill's going to go through the plastic part. So at the moment it's 2 mil, but if you want it to go all the way through, so if you want to grill that grills through the entire feature, you can just put in 10 mil, because I know the thickness of that plastic is 10 mil. So I can put in 10 mil there, that means the boundary's going to go all the way through. And then this here is sort of the lip that runs around the edge. So it's converting this into a plastic grill, so it's allowing you to define like the edges and the lips and the raised features of the grill. So we can have maybe 1 mil wide boundary, and then you can have it raised off the surface, and that's this dimension here. So you can see that line there, and then there is representing the plastic part. So you can have it sort of raised up slightly, so you can maybe put in a value of 1 mil there. And then you just preview what it's going to look like. You just click OK, you get this. You're like, oh, I see. But because we've raised it up by 1 mil, we're now only going down by 10 mil. So actually, we need to go down by 11 mil because we've added a millimeter onto it. So if we just edit this growth between the tree and change this one to 11, that should now go all the way through. So we've now got a 2 mil wide lip, raised 1 mil off the surface, and it goes through by 11 mil. That's pretty much where we're at. Actually, it's 1 mil wide. It's a 1 mil wide lip, 1 mil raised off the surface, 11 mil down. Okay, right, so the next thing you need to do is define the internal ribs. So that's these bits here. So you want to go to rib, and then you can just select the lines. You need to be a little bit careful with window select and stuff, because it can pick up entities and points and make things go a little bit screwy. So as long as you don't have thousands of lines or even hundreds of lines to click, I would just, if you can, just click them individually. I know window selecting is a hell of a lot more time efficient, but it can get you in a bit of trouble if you do window select stuff. It's probably not too bad. I know all I'm picking up is lines there, so I can pick those up. Right, so this is the dimensions of the inner grill lines, the ribs. So the width of these I can say is 1 mil. How far do they go down? Well, that's this one here. We can say 11 mil. Not 112, that wouldn't do very good. And we can raise these. Shall we raise these a mil off? No, let's just keep those the way they are, right? And then you click OK, and you can see there's your grill. How good's that? How good's that? That has saved me so much time. If I was in the business of making grills and business was a booming, then that would save me so much time. I thank you. You are welcome. So there's your grill. Right. Other things you can do. You can put an island in the middle of it. I've got, since I said that, I've got La Isla Bonita stuck in my head. You know, Madonna song. But I haven't got an island here, so I need to edit the sketch. So there's sketch 2. So the island is essentially just like a solid plastic body in the middle of the grill. So that can be anything. Let's just draw a circle. Let's keep it simple. Keep it simple, stupid. There you go. There's your island. So you can finish the sketch, edit the grill, and then go to island, and then select this circle. And then if you just click OK straight from the bat, you just get like this solid region in the middle representing an island, which you can then shell out if you want to. If you go back to the island tab, you can then add sort of a lip running around the island. So we can say 1 mil, and then when we look underneath it, we should have a hollow 1 mil thick island. So it's pretty simple, isn't it? It's pretty simple once you sort of get the hang of it. You're like, oh, I see. Right. And there's other bits in here. You can add draft angles to the, if you're actually interested in manufacturing this, you can then add the draft angles to the ribs. You can also add spars, which is just basically strengthening beams, which would just, you would deselect some of these lines and then select them again as spars, and then you can add slightly thicker members in there. But that's pretty much it. Pretty much it, isn't it? You can see the flow area there. I don't make plastic parts, so I'm sure that's useful to somebody, but it's a number and it looks like it's accurate, and that's good enough for me. That is good enough for me. Right, and there you go. So that's how you create a simple grill. Grill. Kind of a grill, I guess. Kind of grill. There you go. There's your grill. Right. So you can get quite creative with this. So what I'm going to do is just delete this, and then we're going to start again. And I'm going to create something a little bit more funky. And then you might start to say, oh, I see. Alright. Let's make a work plane up there. Let's turn them off. I don't like work planes. Let's make a polygon. Let's do a 6-sided polygon. That would be a hexagon. Math. I was at school that day in math. And then we can snap to the middle, and then let's just make a polygon. Wow, concentration, sensation in there. Too many dots, man. Too many dots. Don't like all those dots. Let's constrain him that way. So he's all parallel. And let's put a dimension on. So that's D. That's shortcut D for dimension. and we can go from there to there, and let's make that. Let's make that 20 reeds. And then what I'm going to do, I need to pattern this. I'm going to pattern this because basically what I'm creating like a honeycomb. I'm creating a honeycomb grill, in case you hadn't noticed. So we can do a line, construction line, and this is going to be the pattern directional arrows. That's no good. You just oversnapped. So we can go from there to there, and then from there to there. So I'm sort of pre-creating my pattern directional lines, and then we're going to go rectangular pattern, and I'm going to pattern that. It would be nice if I could select all of this in one go, but I can't. So that's not really anything I can do about that. Right, direction 1 is going to be that line there, and it's 21 there, because I'm going to make that 20. So we're going to say, no, I don't want 20, I want 5. And the distance is going to be 20. And then we go that way. Right, there's 5 too few, probably. Let's make 8. And then direction 2, we're going to go that way, and then we want 8 by 20. So this is a bit fiddly, but this is all the advanced section of it. This is the advanced section. Okay. And then you've got like a honeycomb kind of pattern. I can't make this into a grill straight away because I haven't got a boundary. You need the boundary also needs to be a closed profile in sort of a selectable region. So to try and create a boundary from this, it would just be an absolute nightmare. So what we're going to do is finish that sketch there, and I'm going to make another sketch, and they're working are hidden, which is that one there. And the boundary is also going to be a hexagon. So we're going to say let's just make it out of the way first. Let's make it so big, and let's constrain it in place so we can go vertical, and that doesn't really look vertical, but just the way the camera is. And then distance from there to there, let's say 100. So that should now fit over a good section of hexagons. We can probably drop them about there. Right, so in order to get them right bang in the middle there and in line with the other pattern items, what I need to do is project some geometry. So let's project that edge there and that edge there, and that allows me to snap that line. There's probably a better way of doing this, but I'm going to do that way, and then I can move centralize that middle of the big hexagon to that little hexagon line there. There you go. So we've now made it perfectly smack bang in the middle of that pattern. So essentially, I'm going to make a grill with this being the boundary, and then I want to use the internal hexagon honeycomb pattern as the ribs. So all of this pattern stuff over here is just wasted. I don't need any of this, but because it's a sketch pattern, it's not really all that easy to sort of suppress them out. You can do it, it's not really time efficient. I don't need to. So I can finish that sketch, and now we can create a new grill. The boundary is going to be that there, still no preview, which sucks cock, but what can you do? And then we're going to keep this all the same. Let's just keep it the same. So it's going to be a 1 mil lip, 10 mil deep, and it needs to be 11, doesn't it? Yeah, it needs to be 11. And then the ribs. Right, again, the ribs. You can't window select these because we've got points inside here, we've got construction lines, we've got all sorts. If you do a window select, it doesn't work. It just doesn't work. So this is really irritatingly fiddly, but it is what it is. There's nothing really that you can do. You just gotta keep selecting. How was your day? I'm just now going to fill in time. How was your day? You know, good weekend. I went to home base and bought lots of stones. I was stoning my garden. I dug up the turf and put stones down instead, and I had an absolute mathematical fail. I bought 16 bags of stones, and it covered about 10% of the region which I needed to cover. So I needed about 5 trips back to home base, and 300 quid later, I have stones in the garden. It was a great story. Would you like to tell me it again? Well, tune into the next episode. Right, so there's the internal ribs all selected. So we've got 1 mil thick, so all of these ribs are going to be 1 mil thick. They're going to go down by 11 mil, and I need to raise them up a mil, don't I? I'm not sure that metal is a sexual looking honeycomb grill. Look at that. Boom. Now that's more of an advanced grill. So that would be, yeah. You can see how creative you can get with this. It depends entirely on the ribs that you're creating. And you need to have a boundary, and you need to have solid grill lines in the middle for it to actually work. But that's pretty much it. That's plastic part and creating grills. And that'll do for this one. chums, friends. If you like that, slap a like on it, subscribe, and I'll see you in the next video. Test drive, so it's useful to throw these tips out there. On this finished Carrier, you'll see the bottom faces here are shiny, right? Because it's kind of a machined feature, so you get like a shiny finish on the metal there. It's been sort of sliced out or machined out. So if you want that effect, what you can do is go to the revolver feature in the browser here. The browser all along, you don't need to be aware of it as such, but the browser's been keeping a track of what we're doing. There's the pattern of the legs, there's the fillet, there's the hole, the circular pattern, there's the revolve. So right click that revolve and go to properties. And then where it's got feature appearance, you can drop this down, and providing you haven't completely bollocksed up your install, you should have a load of textures here. You should be able to scroll down and then select something like chrome polished, and then that puts the chrome polished appearance under the faces of the revolve. Right. I mean that's kind of almost it. That's almost it. The only other thing I want to do is, I'm not too sure how beneficial this is going to be for a beginner, but we've got a keyway. We've got a keyway cut here, and that's been done using an iFeature. Now, if you've managed to download these files, I've included the iFeature in the downloaded files. And an iFeature is basically, an iFeature is a predefined, it's a pre-created 3D feature which you can save and reuse in other models. So for example, that hole, that revolve, you can save the revolve out, for example, as an iFeature, and if you want to do the same revolve again in the future, you can import it as an intelligent feature and reuse it without having to do the sketches again. But they're a bit tricky to use, they're a bit tricky to export, they're a bit tricky to place, because models are different faces, different sizes, that sort of thing, so they are quite tricky. But this iFeature is, it's set up to work straight away. So what we're going to do is go to the Manage tab, and then we're going to select Insert iFeature. Right. Where you've got here, look in, drop this down, and then go to wherever you've saved the downloaded files. In my case, I've saved them in C, Autodesk, Workspace, iFeatures, and so yeah, you want to browse to the downloaded files. There's an iFeatures folder, and then select the keyway iFeature, and then click Open. Right, this is asking for 2 reference points. So the first reference point is going to be the edge here, and then the reference or the profile plane is going to be the top face. And you can see what it's going to do, kind of. If you click refresh, it should update it. It's going to create, all the iFeature is just a sketch rectangle which cuts through the feature, but click finish, and then that drops in. You can change the size, change the position of it. If you want to go in and just start messing around with the iFeature, by all means do that, but that's just a sort of a sneak peek glimpse at what iFeatures are. Might be doing an iFeature video. I can't even remember. Wow. I might have done it if I haven't. Let me know now. I might do one something. Alright, that's pretty much it. That's the Carrier done. If you want to assign an actual material to the Carrier, though, you can do, because at the moment it's made of nothing. Yeah, it's made of nothing. We don't know its weight. We don't know anything about it. If you want to assign a material to it, right, there's a number of different ways you can do this. You can use this drop down here, or you can right click on the node here, or you can right click on the tab down here. You can go to iProperties, go to Physical, and then where it says Material, you can select what it's going to be made of. So, I don't know what we mean, probably stainless steel perhaps. Select stainless steel, click Apply, and then you've got an actual mass. So that's how much it weighs in real life. And you've got the centre of gravity, coordinates, and that sort of thing. You might find use for that, I don't know. I don't know. But it's useful to be able to set material. Now the actual appearance of it is changed based on the material. If you want to override, so this might get painted, it might get painted red, it might get painted blue, it might have a brushed finish to it. Select this drop down here and you can override the appearance. So you can say I want it to be stainless brushed. If you zoom in, actually it's, you can't really see the brushed effect on it. We'll change that to satin brushed heavy. Whoa. Right, if you ever do select an appearance in the scaling, now obviously the scaling of that is all wrong. select this little circle here, and at the top, find the texture that you're currently using, which is satin brushed, which is down there. Right click on it, go to edit, and then in the appearance editor, we can go to the relief pattern, click the little image icon here, left click that, and then you can change the sample scale. So at the moment it's set at quite a large scale, so you can maybe change that in 10 centimeters, right, 10 centimeters, and then you can see that's reduced the size. I want even smaller, I want that 5. That's good done. Right, we shut that down, click OK, shut that down. Yeah, just a little bit better. And that's that done. There's that done. Right, save it, and we're ready to put some of the assembly. We're nearly done. This has gone on for a bit longer than I thought. I should have known better because I didn't talk a lot. I shouldn't be surprised. Right, so the finished carrier, right, it does look a little bit different because we put a different texture on it, but we're going to shut this down. I've done that. We're ready to use our own carrier. So we're actually at the same point as the finished carrier. It's looking amazing. It's looking chickeny boo. Right, so we're going to go over to the go-kart. And, no, I'll tell you what, let's shut that down. I'm going to open up the, if you go to the download file, go to the assemblies, and then we're going to open up the rear axle assembly. So it's just the rear axle of the car. So we're going to put the part into here. To place the part into an assembly, select place on the assembly ribbon tab. So you're going to assemble, select place. If you can't see place, if you see something else, select the black arrow underneath it, and then you can select place. And then we're going to select the carrier that we saved. Click open, and then just drop it anywhere you want inside the assembly. Don't select it again, or you'll place 2, and you don't need 2, you just need 1, and then press escape. There we go. Right, that's our carrier placed into the assembly. Now that's free to move around, so it's just floating around in space. We need to put it onto the axle. Obviously that's got to sit on the axle, and this is going to be pressed up against this. I'm assuming it's like a brake disc. I don't know what it is actually, I don't know why it's the same brake disc. I don't know. But we're going to place it onto the axle. How do we do this? Right, we're going to use constraints. So one of the fundamental aspects of assembly design is understanding how constraints work. So we're going to select constraint, and we're going to use a mate constraint. And what we do is we select, you can either select a face or a center line, and then select that, and then select the axle. And then that places the axle, places the carrier onto the axle, mating the 2 center lines together. And click cancel. Right, so that's now constrained, so that's now free to move up and down. So if you hold the mouse button down on the part, you should see it sliding up and down the axle. And we want to place this now flat up against that disc. So what we're going to do is we're just going to zoom around, select constraint, and we're going to mate that face against that face. Right, and then that's now free to spin. So it's pressed up against the disc, but it's free to spin. Right, we're going to go next level again here. I'm taking the. So we're going to. Right, what we're going to do now is we're going to make this adaptive. Right, what does that mean? Right, well, as you can clearly see, the leg hole, the leg hole doesn't line up with the hole. Well, we want that hole to line up with that hole. Right, so if I was to say, right, constrain the center line of the hole with that there. Okay, right, it's just going to give us an error. It's going to say it can't do that. What we need to do, right, it's just, right, what you want to do is just rotate it around so the keyway lines up. Like that. So you can see the keyway lines up with the slot in the axle. Right. The reason that you do that is because that leg there is the original leg. All these other 5 are patterns, right? That's the original one that we sketched. Right, we want to make this leg adaptive. How do we do that? Right, go to your carrier, right click on extrusion 2, and then select adaptive. What that means is that this feature is free to adapt if another function asks it to. Right, very, very basic terms, algorithm, that's what it means. It can change based on something else happening in the assembly or in the part. So we're going to save that, we're going to go back to the assembly, and then we're going to right click on the carrier, and then we're going to make the part itself adaptive. Right? So the feature is adaptive and the part is adaptive. What that now allows us to do is create a constraint. We're going to select the center line again, and then we're going to select that hole. And click apply. And what happens is it adapts the leg based on the constraint. So I asked Inventor to line the holes together, but because the leg wasn't long enough, it needed to adapt that leg to suit that constraint.
In this video, we're going to reverse engineer a scanned fender in Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video we're going to take a scan of a 1976 Fiat Spider fender, and we're going to try to recreate this using forms. Now, we've talked about reverse engineering before. We did it with the dashboard component, the center console piece from a Dodge, and we've also taken a look at mesh bodies. But this one's a little bit different because we're going to try to recreate the fender, and it's going to be a little bit tricky for a few different reasons. One of the reasons always comes down to the quality of the scan. Now, the scan looks pretty good, but when we hide the edges, you can see there's a lot of wrinkles in it, and you can see that there's some areas of concern where we don't have good detail of the headlight bucket. So we're going to do our best to try to recreate this. It's going to take a little bit of extra work to go the final mile, but what we're going to focus on in this video is going to be getting the shape, the overall shape of this, because the intent here is to reproduce this as a fiberglass part that can bolt onto the car, and this is a race car application, so we don't really need it to be perfect. We're not looking for perfect seam gaps or anything like that, but we want to replicate the shape. We want to make sure that we can recreate what's here in terms of details. Now, the first thing I look at with something like this is first the quality of the scan that we're working with. If we have a really detailed high quality scan, it's much easier for us to just pull a form body down to it with high resolution. Because we don't have that, what we're going to be doing is we're going to be pulling a few points, and then we're going to use our best judgment. When we do this, we're going to be using the forms to sort of mimic and lay on that shape. Now, a couple things that we need to look at are going to be the seam that we see here. You can see the shadow where it changes from dark to light in the front and light to dark in the back. That's going to be not a crease, but it's going to be a detail or a body line that we want to make sure that we carry forward. And obviously the fender flare sort of goes away down in this section. Now, a lot of these older cars, you're going to find there'll be seams or panels or pieces where different pieces get bolted or welded together for different reasons. And you can see that we're missing some scan data on the inside. We're going to have to make some best guesses. And again, the main intent here is for us to replicate the shape. And then we can sort of go forward from there. Now, I will also say that this came from a subscriber, and when he sent this over, he said I could share the scan. So because it's harder to get the mesh file to you, you can go to the description in the video and you can download the Fusion data set with the scan already in it, and it's already sort of set up in this orientation. Now that we've sort of got that all out of the way, let's talk about first steps, because there's a right way and a wrong way to bring in scan data. Now, with anything in Fusion 360, when you have a Parasolid or you have an IGES or a step file, oftentimes you just upload it to your data panel and then open the design. However, with mesh data, that's actually not going to be a good way to do it. And the main reason is anytime you upload something to the data panel, what you actually end up doing is having that data converted, especially when it's an intermediate format. If you're uploading an OBJ or an STL or an FBX file, some other mesh file, then that's automatically getting converted to a solid or a surface body, and that's going to be the wrong approach when we want to use this mesh data for something like a forms. So the right way to go about doing this is to start a new design, go into your mesh tab, and use the insert mesh. Now, in this case, I'm just going to bring this in to show you. Again, you can download the Fusion file that already has this aligned. And the reason that I want to show you this is because this is often the case, especially when you're talking about dealing with hobby or consumer grade scanners and the software that comes with them. One of the big things that you'll notice when you're talking about high-end scanners is there is going to be a high level of precision on the scan data, but there's also going to typically be a high level of data translation and alignment that happens in the scan software. Most of the scanners that you see on the market on the consumer side will come with a free or a watered down version of a mesh manipulator. But when you get to the higher end, you typically will buy a piece of software that can range anywhere from $1,000 to $10,000 or more that is specifically made to help translate that mesh data and align it to a coordinate system. That alignment of a coordinate system is a really critical point, especially when dealing with parametric models. With the fender, we're not as concerned with it, but I did want to at least show you the way that I go about sort of setting this up in Fusion, because it's not really straightforward. So the first thing I want to do is I center it at the origin, and you'll notice it instantly sort of flips around. That's because the coordinate system just goes back to home view. We can move it to ground, again, home position, and we can also flip the up direction. Now this isn't really going to make much of a difference for us, but just note that we do have these options. I'm going to say OK, and the next step for me is to use the move command, which is M on the keyboard. What I want to do is I want to select this entire body. We need to be mindful of the orientation of the gnomon or the little manipulator that you see on the screen, and make sure that it doesn't change direction when you select a different part of your mesh. Now in this case, I just want to pick somewhere because we're selecting the mesh body, and all I really want to do in this step is I want to try to rotate it to a position that looks like it might be the orientation that we would see on the car. So about 25 degrees, it looks about right, and I'm going to say OK here. Now it's very easy to try to get all of the rotations down in one move command, but the reason I don't do that is because if I do move again, now my coordinate system is realigned with X, Y, and Z, which means because I'm looking at it from this orientation, I can just flip over to this view, and then I can begin rotating it to where I think it's correct. So in this case, it looks like about 35 degrees. Once again, I'm going to say OK, and now you can see that it looks roughly aligned, but I am going to select it again, and I want to rotate this down. I want this to be in approximately the right orientation. And again, it doesn't have to be perfect. It's not like I have a picture or blueprint of the car behind it, but making sure that the orientation of the mesh is correct is really going to help downstream when we start to use our form tools. And the reason is because the form tools, especially the translate manipulator, is based on the coordinate system X, Y, and Z of your design. So if you don't take the time to actually get this in the correct position, then it's just going to be harder downstream. Now, if you have been using forms for a while, you might be saying to yourself, well, that's true, except there are other coordinate system options when we're working with forms. We can rotate and base it on our selection. And yes, that is true, but it's much easier to just spend a couple minutes getting this in the correct orientation. Now that we know that, let's go ahead and start with the file that I already have set up. So if you're going to follow along, I need to make a few notes here. One, I have not gone through this process on this fender before. This is going to be the first time, and if I don't use this recording, then so be it. But we're going to go in sort of from scratch, how I would approach it. I like to do that with these types of videos because it really helps, at least with me, it helps go through the process how I would approach it. Now, if I went through and I modeled this a dozen times and then presented the video, it's not as realistic. We don't really get those pain points that we get along the way. So I like to do that. I like to start from scratch and at least try. The first time I record it is just try it from scratch, and that's where we're at. The second thing is this is probably going to take a good bit of time. I don't really have a good idea of how long it's going to take. It might take half an hour. It might take 4 hours. I don't know. So obviously if you've clicked on this video, you know exactly how long it's going to take. But just keep in mind that this process, there's no set amount of time that it's going to take. It really depends on the scan quality that you have, the level of detail that you want. So if you're starting with me, let's go ahead and create a form. And the first type of primitive that I'm going to create is the face primitive. I'm going to use the object snap, which automatically gets me away from having to select a plane, and I can snap directly onto the mesh. There is this offset option here, and if I change this offset value, I've never really had great luck with it sort of offsetting correctly. But what I want to do here is I want to be real careful not to start out using a lot of different faces. I want to get just a big, broad shape. I want to start there and then divide it up as needed. It's very easy for us to come in and start making a bunch of small faces on here. And if I had a really high quality mesh, I might do that. But when we have issues where we've got these like these different bumps and undulations that happen along the details, then it's not going to be worth your time to really try to get in and match it. So what I'm going to do is I'm going to start on this edge here. I'm going to start right there. I'm going to come all the way to the back. I'm going to come down, and I'm going to come back over. That's my first face, and I'm only going to do 2, so I need to come in here and find that endpoint. I'm going to come up here, come to the back corner, find that other endpoint, and then say OK. So all of that just gave us 2 faces.
Hello everyone, today we're taking a look at HD Zero's very first radio on the market. And this radio seems to be designed around being compact and packable, and it does come with its own carrying case, as displayed here. But not only the carrying case, but the stick ends, they come out and they store right in the back. They screw in so they shouldn't pop out like those other designs. And this is the least expensive radio to come on the market. It has a screen, no additional cost. You don't have to buy batteries because it's built right in. And that battery boasts a usage time of 10 hours. I can't say whether that's 100% accurate or not. Quickly go around the horn. We have momentary switches here, momentary switches here, and 3 position toggle switches right up here. These are your trim buttons for 4-way adjustment, our lanyard, our power button. This is how we drive and select the menu. This is a binding button. This is your Buddy Boxer trainer mode, and this is your USB-C port, both for charging, which the light goes from red when you're charging to green when you're done charging, as well as for FPV simulator purposes, plugging into your computer. Pretty straightforward, right? We got the gimbals right here on the menu, and this does not run EdgeTX. They have boiled this down into much more simple, and we will dive into the menu and give kind of an overview here. If we sit here for a few seconds, we will see the screen dim. That's one of the power-saving features that are built in. Of course, as we move the sticks, we can see our movement around. We can see our battery level up here at the top with a voltage displayed by it. We can also see our signal, but I've got nothing connected. If we go to the right, we can see all of our channels that are set up on the radio. And we then go one more to the right, and we can see where we have our menu. And to go to the next menu, we go up or down on the button. So calibration is next on our list. We have the battery and the calibration in there. We've got the startup check. So if you get a warning that your throttle is out of position, or you want the warning to be with your throttle out of position, you do have that option. We've of course got timers that we can select. We have the trainer mode or DSC mode, as well as firmware update. And then we have to reset settings. If we go into the firmware, mine is still on version 1.0.0. I have attempted to update this a number of times, but I seem to have some sort of issue on my computer where it gets started and it seems to go to somewhere between 30 to 70%, and it just stalls out. Here we can go into programming the transmitter, or we can program the backpack functions. If we dive deeper into the channel map, you can see here how it's got everything set up for each individual channel and the directions that we have for each one of these. You can add or subtract these at will. I'm sure Ryan Quillett, the HD Zero representative, has already got a tutorial on many of these things ready to go, so I am not going to cover them real deep because, you know, this is a budget radio. This is for FPV starters, and if it's not a starter, you've probably already got a pretty good idea how this probably all works because you've been using much more complicated operating systems like EdgeTX and OpenTX. This is our stick calibration, which I don't feel a need to do because I think it's pretty accurate as so far, but if you were to drop it or otherwise feel it needs calibration, it is here for you. Our battery, you can see where it shows our voltage, our warning voltage, and our warning type. Warning type meaning a beep and a little vibration mechanism, much like our cell phones. Previously mentioned startup check. You can set any of the channels to have any startup check that you would like. Timers, you can enable the timer. You can set it to 1 minute. You can set an action with it. An alarm type, trainer mode, that would be if you were to have another radio plugged in, of course. And we've already dove into the firmware reset settings. That is the entire menu. As far as how the gimbals feel, these are nano gimbals. So some people are less comfortable with those because they have a shorter throw distance versus a much larger gimbal. But these gimbals, they're this size at the very least. Is pretty typical on our budget radios, as well as those radios that are made for backpacking or just throwing in your pack for otherwise robustness. Buttons, in my case, I have found them to be fine. These are a little foreign to me, even though I continue to see these on radios that I do test and review on the channel. I am much more comfortable with the longer stick ends because that's what I started with for many, many years. And it's quicker for me because I like to be able to quickly access things. Aux 1 is set for this channel right here, but you can go into the channel map and change that if you'd like to where you can use any of the buttons per channel, or maybe you want to have a pre-arm on yours as well. far as the textures and features, you know, it's a small radio, and as you can see here in the stick cam, I am a pincher or hybrid pincher, and I just kind of cup the radio in my palms with my pinky and my index finger. I think if you're a thumber, which I started out as a thumber, but I haven't flown thumbs in a while, this would be pretty comfortable. I did notice that on the center points on the sticks, that with these types of gimbals, kind of all of them in this product line, not just with HD0, but all of the budget radios, that center point, which I fly around a lot, especially when I'm flying inside, is a little bit heavier than I find on much more premium gimbals. But that is to be expected to some degree. Also, the USB port here at the bottom, and you can use that for flight simulators. I did test it with Uncrashed as well as Velocidrone, and my super old now copy of TinyWhoop Go. It can work normally, although I'm not a very good FPV simulator. Around back, there's really nothing to show other than the screw points as well as where you hide the gimbals. The case that it does come with, it's got a zipper, one zipper, and well, I guess two zippers if you count this pocket, and inside the pocket you can see we do get an HD0 lanyard as well as a USB cable, and then the radio goes